Welcome to the first session of our series on Advanced Java. Here we will introduce ourselves to the Java Enterprise Edition. We'll start with discussing various Java editions. We'll move on to describing distributed applications. We'll then explain client-server model and important terms related to it. Let's start with Java editions. There are predominantly three editions that Java works with: the Standard Edition, the Enterprise Edition, and the Micro Edition for handheld devices. The Standard Edition is the core Java programming platform. It contains all our Java libraries. The Java Development Kit, or the JDK, is part of the Standard Edition. The latest version is JDK 8, and it helps to develop and deploy Java applications on desktop, servers, and embedded environments. It is also used to build standalone applications. The next is the Java Enterprise Edition. The Enterprise Edition platform is designed to help developers create large-scale, multi-tiered, scalable, reliable, and secure network applications. The latest version is Java Enterprise Edition version 7. It is portable, so it allows an application hosted at one common place to be accessed by users across the world over the internet. It provides application programming interface to develop distributed applications that allow the client-server model. It also facilitates the development of web applications. Next, we have the Micro Edition. It's a technology that allows programmers to develop programs for mobile devices. The latest version is 8.3, and it consists of programming specifications and a special virtual machine, the K virtual machine, that allows Java ME encoded program to run on mobile devices. The Java Enterprise Edition differs from the Standard Edition in terms of the libraries it provides to deploy fault tolerance, which means that in case there is an error, there is capability of your database transaction or something to roll back, so your data is always in a consistent and durable format. It ensures that there are libraries so that you can develop distributed applications. Distributed applications would mean part of the processing being done on the client, part of the processing being done on the server, or also the processing load being distributed across multiple nodes. We have multi-tiered Java software, which is basically based on modular components running on an app server. So we can create an application server and deploy some code over there which can be commonly called from multiple clients. Now, built on top of the Java Standard Edition, Java Enterprise Edition provides additional libraries for database access via JDBC and also for persisting data using the JPA API, remote method invocation, where you can have some code on a remote machine and call that code remotely onto multiple clients, so that if there are changes or updates to the code, you just have to update it on a central system. You have messaging done by JMS. Messaging would mean when you're sending information from one application to another remotely, and that application probably is not live and active when the communication is happening. In that case, your data can be stored in a message queue, and the moment the end application becomes active, the data will be received there. Very similar to an SMS. When you send an SMS to your colleague, and if the colleague's mobile phone is switched off, in that case he will receive the SMS when he switches on the mobile. Until then, the message will be stored in a queue. Web services and also XML processing. And it also defines standard APIs for creating enterprise Java beans, server-side servlets, portlets, and server-side scripting with JSP. So here is how the enterprise architecture looks like. We have a client which is connected via a web browser. It's connected to a web server. On the web server, we have our server-side code which is set up, which could be written in servlets or JSP. And here we have a controller. So here we can implement a model view controller pattern, where the controller will accept the request and pass it to the appropriate view, which should be returned to the user. If there is some business logic to be processed, it can be pushed to an application server on which we can have an EJB container which has your data model. So the controller can be here, which can pick up data from the model class which is connected to the database. And the benefit of isolating common code on this application server is you can have different UIs connecting to the same code. In case you have a desktop based GUI application that also needs to use the same processing business logic, it can simply go ahead and call that EJB or the enterprise Java bean code that is hosted on the central application server. So that is reusability at its best. The Java Enterprise Edition platform facilitates an architecture in which the business components are placed in a separate tier as we saw. It also enhances features such as better scalability, where you can enhance the number of users accessing your application easily. You can extend the capability of your application, and also maintaining the application is easier because any change is isolated to just one box in the deployment strategy. Its modular design allows easy modification of business logic. It provides more security because it partitions business services from the web tier. It also permits clean job separation of job roles. The enterprise component can also leverage their EJB container for service such as component and resource management, better security, better persistent, and also transaction management. So here you see that there is a scale going from left to right which manages complexity, and a scale going from the bottom to top which looks at robustness. I can develop an application and host it on the server side purely in HTML. In that case, you cannot really create very complex apps, and it's not very robust as well. On the other hand, we can create a basic JSP and a servlet page. If I create a basic JSP and a servlet page, it consists of HTML pages, JSP pages, and servlets. You can create fairly complex applications using this, and they are fairly robust as well. The next level, you can create JSP pages with modular components, where it consists of HTML pages, JSP pages, servlets, Java Bean components which are deployed on a application server, and a set of custom tags. In that case, the complexity increases and the robustness also of the application increases. Finally, you can create an application with HTML, JSP, servlets, the application server hosted Java Beans, custom tag, and also enterprise Java Beans, which give you better security, maintainability, better object management, etc. In this case, you can create highly complex and highly robust applications. The key points here is, as the richness and robustness of web applications increases, so does their complexity. The complexity of the application can be managed by proper design that helps in getting rid of programming concerns. The Web Container and Java Enterprise Edition platform provides components that can be used to manage such complex application design. Let's go to distributed applications and the client-server model in Java Enterprise Edition. Here we'll talk about distributed apps, client-server model, the HTTP protocol, types of server responses, client request types, HTML, and running HTML code with Apache. Java Enterprise Edition provides an API to develop distributed applications that follow the client-server model. So part of the application can be hosted on the server, and part of it can use the processing speed of the client. In distributed applications, same applications can run across different machines at the same time using the internet. One machine acts as a server where application is deployed, and the other machine acts as a client. So here you see a server with multiple clients connected to it, and all these servers are further connected to each other using the internet. So we are actually using the processing speed of multiple nodes, multiple clients and servers which are spread across our connected network, and hence the application will perform much better. It will execute quicker because of the processing speed that is well distributed across the available nodes with us. The client-server model is a distributed application structure that partitions tasks or workloads between the providers of a resource or service and service requesters. Both web client and web server are actually programs. Now the web client is not a user. It is actually a program. Someone who uses this program to send requests to a web server is known as the end user. Here we see the architecture. There is a client which could be a web application, it could be a chat application, which sends a request to the web server. The web server would be something where it hosts a web application, a database application, could be an email server. In response to that, the moment we send an HTTP request to the web server gives us a response. One cycle of request and response is termed as a postback. Here we see we are making a request to HTTP. We are saying HTTP localhost 8080, which is the port on which your application is hosted on the web server. and we are providing an application name. This application name is a custom application name of your choice that you can host on the web server. The web server accepts requests from the client and gives back a response which can be either static or dynamic. I can return a static page in response to this request which will be hosted on the web client, or I can return a dynamic page where, depending on the request received, for example, if I accept the user ID, based on the user ID accepted, I can provide an attendance page or an account detail page to the client. And the responses that you are provided to the client being a browser, are always in the HTML format. So this request and response is typically working on the network on the HTTP protocol. The HTTP protocol is a TCP/IP based protocol which is used to deliver data on the web, and it provides a standardized way for communication. So we can focus on the business problem and we don't have to worry about how data is going to be sent between the client and the server. The Uniform Resource Locator uniquely identifies a resource on the internet. So here you see the protocol, the name of the machine on which the application is deployed, the port number on which the server is listening, and the custom name of your application, which is the root folder which holds the app inside. If you're using Apache Tomcat server, it typically runs on port 8080, and you can also configure it, so remember to check during installation. Here are the features of the HTTP protocol. It is a TCP/IP based communication protocol which is used to deliver data over the web. So the moment you send data, you can be guaranteed that this data is received at the other end. You do not have to bother about checking that. The protocol is used to change or transfer hypertext. So you can send HTML or hypertext markup language. Hypertext is a structure of text that uses logical links between containing text. It is a stateless protocol, which means it does not remember what it last did. You cannot send information and expect it to remember what it last did. So that is not the job of HTTP. For example, if a postman is delivering letters to your home, it is not his job to read the letter and remember the contents of the letter. If the postman or the courier guy starts doing that, he would reduce the number of letters he would deliver per day, and that would impact performance. The job of the courier guy is just to ensure that the letter is taken from point 1 and delivered to point 2, and he forgets about it, and hence HTTP is a stateless protocol. The server generates response for client requests. It sends three things: the status code, which tells the whether the client's response has successfully reached the server or not. Example, a 404 response would indicate the page is not found. Information about the type of content the server is going to send, which is the metadata, so that the client browser can prepare itself to display videos, flash files, audio content, etc. An actual content, for example, google.com, if I put it in any browser, the server will go and navigate to that particular HTML content which is hosted in this particular URL. There are different server response types. I can get a static page where it's just a flat file that comes from the server, which could be a CSS file, a JavaScript file, or a JPEG file. Or I can have dynamic content where, depending on the ID of the user or depending on the login ID, I will get a customized home page or a customized map page, etc. So either you can generate a page on the server at runtime on the fly and give it to the client in HTML, or you can just save a static CSS JS page on the server which is given to the client. You can have a static page on the HTML file on the server which is given to the client. So as we see here, there are two options. We can either have a static page which is displayed on the client that is generated from the server, or we can have a dynamic page that is generated by the server on the fly. So the static page is just a flat CSS or JS or JPEG page that is on the server that can be displayed on the client, or you can have a dynamic page that is generated on the fly by the server and displayed onto the client. The commonly used server types are as follows. We can have a web server which responds to HTTP protocol and gives HTML content. We can have an app server which executes some business logic on the server and gives a result. A proxy server where we can set security restrictions. It's a virtual server on which all the clients can connect to the proxy server first. You can have policy rights, access rights defined on the proxy server, and then that assists you with communicating to the outside world. Virtual servers which use virtualization, physical blade servers, file servers that look at saving files, and policy servers that look at implementing some security policy across the organization. Let's look at the difference between web and application server. Web server runs on the server. It looks for incoming requests and services. Those requests Once the web server receives a request, depending on the type of request, it might look for a web page or execute a program. Web servers have plugins to support scripting languages like Perl, PHP, ASP, etc., and they can generate dynamic HTTP content. It acts as a container which serves static content. Web servers only support servlets and JSP. Application servers, it is a component-based product, provide middleware services for security and state maintenance along with data access and persistence. Application servers can do whatever web server is capable of doing, as it has web server as integral part. Additionally, it has components and features to support application level services such as connection pooling, where you can have a set of connection objects created so that you don't have to spend time to wait for the object to be created and destroyed in memory. It will create a set of objects and simply reuse them. When you finished using the connection, it will move that object into the pool so it can be used again, so it does not have to destroy the object and recreate it, and hence performance is better. Object pooling also, so if you have some code on the server side and you want to generate objects out of it, you don't have to fire the constructor and initialize memory each time. It will just create an object, maintain it in a pool so that you can use, and the object is sent back to the pool, and this feature is given to you by the app server. Also, transaction support and messaging services, so in case your component is offline or if you're trying to connect to a service, it will store that message in the queue, and when that service or destination endpoint is active, that message will be picked up and submitted there. It also acts as a container upon which business logic is built, and application server supports distributed transaction and EJB. Here are the HTTP verbs to which your client can request. The client can send either of these requests to the server using the HTTP verbs. Get is used to get the resource. It can send limited data. It's not secured because your data is visible in the URL, and it is the default method for communication. Post is used to process data that is sent via a form, etc. It is secured because it cannot be bookmarked. There's no limit on the data sent as payload, as it is not appended in the URL. It's sent as the body of the message. If the URI refers to an existing resource, it is modified. If the URI does not point to an existing resource, then the server can create the resource using put. It replaces all current representation of the target resource, so you can upload new content on the server. If you want to delete, you can delete content on the server using the delete verb, and it allows eventual consistency while replication. Deleted documents remain in the database forever. You can trace request, which is used when the client wants to see if any change has been done by the intermediate server, and this request works for targeted resources. Option request returns the HTTP method which is supported by the server. It allows the client to determine the option requirement associated with a resource. The head request is used for testing hypertext links for accessibility, validity, and recent modifications. This is similar to get method, but it asks for response without response body. HTML stands for hypertext markup language. It refers to the way the web pages are linked together. The link available on a web page is called hypertext. HTML contains tags and elements which are used to format web pages. A typical HTML document has the following structure. So you can see doc type HTML indicates we are using version 5. You have the HTML tag, you have the head tag and the body tag, which typically contains the title. This is the standard structure of an HTML file, and you expect this as a response to any servlet or JSP code that you have on the server side. So you open an editor, you write HTML code, you save it with an extension in the drive of your system. You just double click on the file and it will open the HTML file if you just want to access it on your local system. If you want to deploy your content using a web server which will give you HTML response from the server to the client, you install Apache Tomcat. It typically has a couple of folders in it, and inside the web app folder you create a project folder and you put your HTML content there. So when you hit a URL from the client using the port number of the server, you will get that HTML response back again. And we will be looking at this in the subsequent sessions as we do hands-on for Apache installation and server-side deployment. So you create a subfolder in the web apps folder, then you add a name to your project, you put your HTML page inside it, you open your browser and you hit a URL which is localhost, port number of Apache server and the project name. And that is when it will return the name of your HTML file which is hosted on the web server. Here is a screenshot of web app. So in the Apache Tomcat folder, we've created a project folder, and that is where we will put our HTML content. At the end of the session, we've understood that Java has 3 editions: Standard, Enterprise, and Micro. The Enterprise Edition differs from the Standard Edition in terms of libraries it provides to default, fault tolerance, better deployment, better distribution of processing load, and multi-tier Java software. In distributed applications, same application can run across different machines at the same time using internet. One is client and other is server. The client-server model is a distributed application structure that partitions tasks or workloads between the providers of a resource or service, like a web server, and service requesters, which are web clients. Hope you had sufficient learning in terms of web concepts in this session. We'll see you in the next session. Welcome to the second session of the Advanced Java series, and here we are going to dive into Java servlets. We will discuss Java servlet architecture. We'll explain the important terms related to Java servlets. We'll explain the service lifecycle. We'll describe servlet request, response, config, and context, and we'll list the steps to configure and deploy a servlet. We will also look into servlet collaboration. Let's look at an introduction to servlets. We will go through static and dynamic response, client-server architecture with Java servlet, web container, client-server architecture with web container. We have learned that web server generates two types of responses, static and dynamic. However, a web server can generate static responses in the form of HTML. To generate dynamic response, a programming language that performs dynamic operations is needed. Servlet is a Java program that can perform dynamic operations and send it to web server. The web server can then send the response to the web client. Every time you type google.com in your browsers, for example, you're directed to the Google homepage. This is called a static page, as the web server displays the same HTML page every time the client requests. When users log into their Facebook account, different pages will be generated for different users. These are not static pages that are served and saved on the server side. They are dynamically generated based on the user ID. So you would hence see pages that are relevant to your login. And this requires multiple responses from the server called dynamic response, and hence we need servlets, which is programming capability on the server side to generate such dynamic content. Here we have a user connected via a browser, sending an HTTP request to the web server. On the server, we have a web container which has a servlet inside, which probably would want to talk to a database, pull data, do some processing, and generate an HTML file as an output. That HTML file is sent via an HTTP response to the client browser. Web server is a program that sends HTTP response, and servlet is a Java program that deals with classes and objects. How is the response generated in the HTTP format? Of course, it is the web server at work which purely works on the HTTP protocol that does that. So this is done using the web container which is there on the web server. Let's understand what is a web container. A web container is built on top of Java Enterprise Edition platform, and it implements the servlet API and the services required to process HTTP and other TCP/IP requests. Java servlets are components that must exist in a web container. Web container activates the servlet that matches the requested URL by calling the service method on an instance of servlet class. Activation of the service method for a given HTTP request is then handled in a separate thread within the web container protocol. Here we see the client-server architecture with web container. The life cycle of a servlet is controlled by the web container in which the servlet has been deployed. Here we see the client browser sending an HTTP request to the web server. The web server forwards the HTTP request to the web container. The web container further forwards the request to the servlet in the form of a request object. The servlet generates a response object which it sends back to the outer enclosing web container. The web container converts that into an equivalent HTTP response and sends it to the web server. The web server sends that HTML content via an HTTP response back to the client browser. Let's look at Servlet API interfaces and methods. The Servlet API contains a number of classes and interfaces that describe the contracts between a servlet class and the runtime environment provided for an instance by a confirming servlet container. Servlet API provides the following two packages that contain its classes and interfaces. We have the servlet javax.servlet package. These are classes and interfaces that define contracts between a servlet and the runtime environment provided for an instance of such a class by a confirming servlet container. Then we have javax.servlet.http. These are classes and interfaces which define contracts between a servlet class running under the HTTP protocol and the runtime environment provided for an instance of such a class by a confirming servlet container. This largely is the ecosystem in terms of the set of functions, APIs, interfaces and classes available as part of the Servlet API. So first we have javax.servlet.filterConfig, which passes information to a filter during initialization. We have javax.servlet.requestDispatcher. This sends request and response objects to any source such as a servlet, HTML file or JSP file on the server. Moving to javax.servlet.servlet, which defines methods that all servlets must implement. Servlet.servletConfig is a servlet configuration object used by a servlet container to pass information to a servlet during initialization. Servlet.servletContext defines a set of methods that a servlet uses to communicate with its servlet container, for example to get the MIME type of a file, dispatch requests or write to a log file. The servlet context attribute listener. This is an implementation of the interface which receives notifications of changes to the attribute list on the service context of a web application. Similarly, we have servlet context listener, which receives notifications about changes to the servlet context of the web application. Servlet request, which defines an object to provide client request information to a servlet. Servlet request attribute listener, which can be implemented by the developer interested in being notified of request attribute changes. Servlet request listener, which can be implemented by the developer interested in being notified of requests coming in and out of scope in a web component. And servlet response, which defines an object to assist a servlet in sending a response to the client. So all servlets must implement the servlet interface that defines lifecycle methods. The servlet can also be created by extending generic servlet abstract class that implements all methods of the servlet interface except the service method. Another way of creating a servlet is to extend HTTP servlet abstract class, which extends generic servlet abstract class. And then you can create your user-defined servlet. The servlet interface has 5 methods as part of it: init, service, destroy, getServletInfo, and getServletConfig. The init method is called by the servlet container to indicate to a servlet that it is being placed into service. It is declared as void init and it takes a servlet config object. The service method is called by the servlet container to allow the servlet to respond to a request. So it takes a response and a request object. The destroy indicates that the servlet is being taken out of service and it has to be destroyed. ServletInfo returns information about the servlet. And servlet config is an object that contains initialization and startup parameters for the servlet. The generic servlet abstract class implements servlet interface. It defines servlet generic and is independent of protocols. It doesn't give implementation for service methods of servlet interface. If your servlet extends generic class, implementing service method is necessary. So here we see the abstract class generic servlet, which implements servlet. the getInit parameter, which returns a string containing the value of the initialization parameter or returns null if the parameter does not exist. GetInit parameter names. This returns the names of the servlet initialization parameters as an enumeration of string objects, or returns an empty enumeration if the servlet has no initialization parameters. Servlet context returns a reference to the servlet context in which the servlet is running. GetServletName returns the name of this servlet instance. VoidInit, a convenient method which can be overridden so that there is no need to call super.init. Similarly, we have the init, the log, which is a servlet log method. You can also write an explanatory message to the stack trace using log, and a service method which allows the servlet to respond to a request. The HTTP servlet abstract class is an abstract class to be subclassed to create the HTTP servlet suitable for a website. Following is the list of methods. We have a doGet method used if the servlet supports GET requests, a doPost method which will execute when you provide a POST request to the servlet, similarly a put and a delete based on the HTTP verbs, initialization and destruction, and getServletInfo, which provides information about the servlet itself. Let's talk about the servlet lifecycle. The lifecycle of a servlet is controlled by the container in which the servlet has been deployed. When a request is mapped to a servlet, the container performs the following steps if an instance of the servlet does not exist. It loads the servlet class, it creates an instance of the servlet class, it calls the init method, it then calls the service method, and then calls the destroy method. Let's look at configuring and deploying servlets. The steps are: create a dynamic web project in Eclipse, then add a web server to the project, run the server. In this case we will use Apache Tomcat as our web server, create an HTML file, click on src and create the servlet, create the web.xml configuration file, configure a servlet definition, configure a servlet mapping, and activate the servlet in the web. First thing, we will create a dynamic web project using Eclipse. We will give the project a name. We will add a web XML by selecting the web XML checkbox, and we will click on finish. We'll then click on Windows in menu bar, Preference Server, and Runtime Environment, so we can add a server. We'll run Apache with Eclipse, so we click on Windows, Show View, Server, New Server Next. The server will now be added to your project in Eclipse. To start the server, we right click on the Tomcat server and simply say restart. Then we create a new HTML file inside the web content folder. Then we create a new Java class, which is the servlet class that extends HTTP servlet and that has the doPost, doGet, and the service method. We then create a web XML or a deployment descriptor file which is used by the web container to configure the servlet component. The servlet definition also specifies the fully qualified class that implements the component. The web container creates an instance of each servlet's definition in the deployment descriptor. Then we configure the servlet definition inside the web container of the web server. Inside our deployment descriptor file, we provide the configuration name and the package name for the servlet. The web container will create only one servlet object for each definition in the deployment descriptor. The deployment descriptor is also used to configure a URL pattern that is used to invoke the servlet component. the web container receives HTTP requests for specific URLs and it matches the URL to either a physical component or a logical mapping to a servlet component. Finally, when we hit a URL of localhost port number 8080, which is the default port for Tomcat, and the name of the file that we are looking for, it will do a lookup in the web container. It will check in your deployment descriptor whether you have a mapping to the correct servlet. It will process it, generate an HTML file as a response, and provide that to the client. When the URL pattern becomes something like server name, port number, project name / folder name, the web container looks in the web XML to find the location of the servlet class using the servlet name and the servlet mapping. Check is URL pattern. Hello servlet is logical name for servlet and my servlet is the servlet Java class. When the user selects the home page to the URL, the web container responds with the HTML code for the home page. This is how a servlet will execute on your Tomcat server. We will get into a small demo to configure and deploy our first servlet. The first thing we will need is to download Tomcat. So in our browser, if we Google for Apache Tomcat, we can go to the website and select the appropriate version to download. Once you have downloaded Tomcat, you just need to unzip it into a folder. So here you see I have Apache Tomcat 8.5 downloaded and unzipped. Now we need to configure that with Eclipse. So we'll go to Eclipse, click on Window, Show View, Other. Under Server, we'll select Servers. We'll say Open. And moment you do that, you will get a Servers tab below with a link. We'll click on the link. From the drop down, we'll select Apache. We'll come down and select Tomcat version 8.5, matching the version that we have downloaded. We'll go next. We'll click on Browse. We'll navigate to the folder that has Apache Tomcat. We need the root folder, which further has the bin folder inside it. We'll say OK, next, and finish. The moment we say finish, a server entry will be added into Eclipse, indicating that Eclipse has been successfully configured with Tomcat. Now, Tomcat by default would attempt to start on port 8080. So we can right click on the server instance and say start. In case we have Oracle also installed on our system, it could give us an error like this which says port 8080 is already occupied, because Oracle Express Edition also utilizes this port. In that case, just double click on this server. It will open the configuration file, and here you see Tomcat running on port 8080. We will change that port number to 8181. Moment we do that and hit Ctrl S and save, we have configured Tomcat to run on a new port. After saving, we will right click and attempt to start the server. We'll give it a moment, and it may also prompt us for access. We will allow access on that port so the server can start. And there you see it gives us a reference saying the server is started and is properly synchronized. Now it's time to create a project. We'll right click and say new. I can go ahead and say Java project. On the other hand, let's select new project, and under web we will select dynamic web project and move next. Here we will give it a name which says my first web app, which is the name of my project. We'll select version 2.5 because in 3 and above it does not create the deployment descriptor web XML file, and we would want that to be generated so we can configure it, especially when we are working with Spring MVC. So we'll move next and simply click finish. So a new project called my first web app should be created. We'll give it a moment so that Eclipse can configure itself, and a project is created. If I open the project, you will see there is a web content folder with a web INF inside it with a lib. The lib folder will have external jar files, for example JDBC drivers for connecting to a database. The web XML is a deployment descriptor configuration file that has configuration information about this project. We can also click on the source tab and open it up directly in the XML view. Servlets are nothing but .java files that have to be created inside the Java resources source folder. This is where we will be creating the Java files. As a best practice, it is always recommended that you first create a package. So we'll create a new package here. We'll name the package as com. You can give it any name, and we'll finish. So a new package has got created. We'll right click on the package and we'll create a new servlet. We'll give the servlet a name. We'll call it my servlet. We'll click on next, move next, and you see the servlet methods do post and do get. We will also add the service method. Once we do this, we'll click on finish, and you can see that the web INF file has got updated with the servlet information that we just added. The servlet file has got created in the com package with the do get, the service, and the do post method. We can see class myServlet extends from HTTP servlet. We can also see the 3 methods that have got added. We'll now go to the service method, which is the first method that will get called when the servlet executes, and we'll create an object of print writer. Out equal to response object dot get writer out dot print, and we'll print hello world service method. We'll copy this and we'll paste it into the do get method, and we'll also paste it inside the do post method. We'll modify the text which says do get method, and here we will change it to do post method. To execute, we will save with a Control S, Control F11. It will say that it's going to run on Tomcat server. We'll go next and finish, and it's mandatory to restart the server every time you make changes to your code. We will say OK to that. It will open a small inbuilt browser and you can see that the service method has executed. Any modification that we make to the service method, let's say we introduce an h1 tag and we close an h1 tag, we will save this. When I hit Ctrl F11 to execute, it will again ask me for a server restart, which is mandatory, and it will then refresh the page inside the browser and with the updated outcome. The highest priority in this code will be given to the service method. So we'll comment it. And after we comment it, we will execute, restart the server, and you will see this time that the toGet method has now executed because we've sent a GET request to the servlet. We'll now create a client page to call the servlet method. In the web content, we will add a new HTML file. This is the folder where HTML files or CSS or JavaScript or JSP files should be created. We'll create an index.html file and click finish. We'll just change the title to HTML page. We'll add a simple form which says action equal to my servlet, that's the name of our servlet, and the method will be equal to get. And inside the form we'll have a simple input button, type equal to submit, with a value that says click here for toGet, and that's all we need in the input as of now. We'll just add line breaks in the HTML, copy the same code, paste it again. This time we'll change the method to the HTTP post, and we will change this to toPost. We will now run the HTML page with a Ctrl F11, and it says click here for toGet. We'll click and you see it executes the toGet method in the servlet. We come back to the index.html file using the back button. We'll click on the toPost and you can see it executes the toPost method inside the servlet. Similarly, we have a doPut and doDelete based on HTTP verbs, but in case you have the service method, it will have the highest priority. Let us now try to pass a value from the client HTML page to the servlet. So here we'll say input type equal to text, name equal to fname. We'll copy this and also pass it in the action equal to post form. Now let's go to our servlet code and here in the get we'll create a string object equal to request.get parameter fname. And we'll simply try and say out dot print. We'll add a line break and simply print hello plus the parameter that we passed and retrieved here. We'll copy the same code into the post, and we'll also copy this code into the post. We'll come to the index.html file, we'll save everything and Control F11 to execute. We restart the server. And you see two text boxes. We'll enter a name and say click for doGet, and you see the name retrieved by the servlet. You'll also watch the URL. It was sent using a GET request, so it's visible in the address bar. It's not a secure way. In the post, we'll give the name Rohit, and you can see it's a clean URL, but it was successfully retrieved at the other end using the message or the body of the HTTP message that was sent. So there we saw a simple demo to configure and deploy a servlet. So let's move on to our next topic, which is servlet request and servlet response. Here we look at servlet request interface, and servlet response. If you look at the servlet request interface, it defines an object to provide client requests information to a servlet. The servlet container creates a servlet request object. Servlet container calls service method by passing servlet request object. This object provides data including parameter names and values, attributes, and an input stream. These are the methods available in the servlet request interface. Get attribute, which returns the value of the named attribute as an object. Get attribute names, which gives an enumeration containing the names of the attributes. Get character encoding, which returns the name of the character encoding used in the body of the request. Get content length, which returns the length of the request body in bytes. Get content type, which returns the MIME type of the body of the request. Servlet input stream, which retrieves the body of the request as binary data. Get locale, which returns the preferred locale that the client will accept. Get locales, which returns an enumeration of the locale objects. Some of the other methods that are there in the servlet request interface: get locale name, which returns the host name of the IP interface on which the request was received. Get local port, which gives you the port number. Get parameter, which returns a parameter value based on the key. You also have a get parameter map and a get parameter names, which returns an enum. Get parameter values returns an array of string objects containing all of the values the given request parameter has. Get protocol, which gives us the protocol. Get reader, which retrieves the body of the request as a character using buffered reader. And set attribute, which allows us to store an attribute in the request object. Then we have the servlet response interface, which gives us a set of methods and properties that allow us to access the response via the response object. It defines an object to assist a servlet in sending a response to the client. The servlet container creates these objects to call servlet's service method. To bind binary data in a MIME body response, use the servlet output stream returned by get output stream. And finally, to send character data, we can use the printWriter object, which is returned by the function called response.getWriter. To mix binary and text data, for example, or to create a multi-part response, we can use servlet output stream and manage the character sections manually. Let's go to servlet config and servlet context. Servlet config object is created by the web container based on the initialization parameter specified in the deployment descriptor file or the web.xml file. There has to be one servlet config per servlet. Then we have a servlet context, which is used to share application specific data across independent web components. There can be one servlet context per application. The context object is accessible to all the servlets in your web application, and a servlet context object is the runtime representation of the web application. Here are some of the methods available in servlet config. We have getInit parameter, which returns a string containing the initialization parameters. GetParameter names, which returns an enumeration of string objects. The getServlet context, which returns a reference to the servlet context, and the getServlet name, which returns the name of the servlet instance. Here is an interface called servlet context, which defines a set of methods that a servlet uses to communicate with its servlet container. And getAttribute, which returns the servlet container attribute with the given name. GetAttributes names, which returns an enumeration containing the attribute names available within the servlet context. GetContext, which returns a servlet context object that responds to a specified URL on the server. GetInit parameter, which returns a string containing the value of the named context file's initialization parameter, and getInit parameter, which returns the names of the context initialization parameters as an enumeration. Let's look at a demo where we will explore and use some of these methods in the API, which are part of servlet config and servlet context. So we'll come back to our Eclipse editor. Let's close some of the existing files. So to summarize, before we start, the servlet config tells us about the configuration written for an individual servlet. The config is a reference to one single servlet. The servlet context, however, refers to application scope, and parameters set in this are visible throughout the application. Hence, it helps to share attributes across servlets or JSP pages within the application. So we'll create a new project for this demo. So we'll right click, new dynamic web project. We'll give it a name as context config demo. We'll select version 2.5 so that it creates a deployment descriptor web XML file. We'll say next and finish. Create a new package. Name the package as com, and we'll create a new servlet inside the package. Let's name the servlet as servlet1. We'll go next, and we'll only select the service method and finish. We'll add one more servlet. We'll call it servlet2. Again, we'll only select the service method and finish. Now if I go to the web XML file, the config parameters for configuring a servlet always have to be given within that particular servlet tag. So within the servlet 1 or servlet 2 tag. Context parameters, however, can be given anywhere inside this file, since anything set as a context parameter is of application scope and can be shared across the servlets. So we need to attach a config parameter for servlet 1. So we will go inside the servlet tag for servlet 1, and here we'll add init parameter. We'll give the parameter a name. Let's call it SQL, for example. And let's add a parameter value which says select star from employees. So we can use initialization parameters so that we can probably set up connection strings or some initial values that you want to retrieve within your servlet. We'll add one more, so we'll copy this and paste it again. And let's call it message, and let's provide a value which says hello from message attribute in servlet 1, and we'll save this. Let's come to servlet 1, and here we'll get inside the service method. Here we are going to say servlet config equal to get servlet config print writer out equal to response dot get writer. We'll just add the java.io namespace on the top, or package name on the top rather, and out dot print, and we'll say SQL equal to, and now I need to access that value in the config file, and we'll say get initialization parameter, and the name was SQL. Close the quotes. So we pass the key, we get the value, and then we simply go ahead and print on a new line message equal to plus config dot get init parameter message. So we've tried to get the values of both the parameters. I'll hit Control F11. We'll just have the context config demo hosted in Tomcat. Restart the server. And you can see the values that were picked up from the config file, select star from employees and hello from message attribute, and these were the values we had actually provided in the config file, which has been successfully retrieved. Now let's take the code. Let me stop this. I'll just copy this code we'll go to servlet 2 and paste it here. Okay, so the same code is being copy pasted into servlet 2, and this time we'll execute servlet 2. And you see the output. Servlet 2 is unable to read the initialization parameters because the config parameters are specific to a particular servlet. So this is bound to servlet 1. Servlet 1 could read it, but moment you try to read it in servlet 2, they would not be available. We'll now try and add some context parameters which can be accessible across the application. So we'll add context param. Here we'll add a parameter called name with a keyword driver, and parameter value for that will be, let's say, com.mysql.jdbc.driver, for example. Make this in lowercase and save this, and we'll copy this, paste it again, so that we add one more parameter, and let's call this URL, and let's give a value jdbc.mysql.localhost. Now I'll come to servlet 1 and we'll give an out.print message with an h1 that says accessing content parameters just close the h1 tag. Just copy this, and here we'll say accessing config parameters in servlet 1. Okay, we'll just add in servlet 1. Now we need to create an object of servlet context equal to get servlet context we'll just import the servlet context package, and here we'll say, so I'll just copy this, so two out parameters. The first one is driver name, and we need to pick driver, and for the second one we'll pick URL. We'll say URL equal to and URL. So that's what we've added in servlet 1, and here we need to replace this with application dot get init parameter because this comes from the servlet context. And we'll just take this and paste it in servlet 2. So we'll try to read the same values from the context in servlet 2. Okay, here we'll just change this to servlet 2, and we'll just take this as well and put it into servlet 2, change this to servlet 2. Okay, let's come to servlet 1, close this, and we'll try and execute servlet 1. Accessing config parameters in servlet 1. So you can see, since these parameters were set specifically to servlet 1, they are accessible. And here again you see that the context parameters were successfully retrieved. Let's try running servlet 2, and you can see in servlet 2 the config parameters which were specific to servlet 1 are not retrieved, but the context parameters which are scoped application wide are retrieved. So this was a demo showcasing how you can set up servlet specific config parameters, application wide specific content parameters, which will be accessible across all the servlets or JSP pages that you have in the application. So let's come back and move to our next topic, which is servlet scopes and attributes. Attributes allow data to be stored and used in inter-servlet communication, and the methods associated. The scope of the data will be duration of the request, HTTP session, only available while the client is active, and servlet context, which is the available across the entire life of the application. Public void set attribute is the first method available, which is used to set the given object in the application scope. We have a get attribute, which is used to return the value of the attribute. We have get init parameter names, which is used to return the names of the context initialization parameters as an enum, and remove attributes, which is used to remove the attribute with the given name from the servlet context. We now move to servlet collaboration, and we'll understand what is servlet collaboration, what are the ways of servlet collaboration, what is forwarding and redirecting, the forward and include method, and the request dispatcher interface. The servlet collaboration involves sharing of information among multiple servlets. Collaborating servlets is passing common information that is to be shared directly by one servlet to another servlet of HTML or JSP through various invocation of methods. There are various ways of servlet collaboration. We can use the request dispatcher, include and forward method. We can use HTTP servlet response, send direct, redirect method, and we can use servlet context, set attribute and get attribute methods. The request dispatcher interface is used to forward the request and response objects to another servlet. The send redirect method is used for redirecting request and response objects. The HTTP servlet response has send redirect method, which is response.send redirect, and provide the URL as to where you want the user to get redirected. The servlet request has get request dispatcher method that returns the request dispatcher object. There are two methods available, forward and include. So this is how it works. If we use the forward method, the client will send a request to servlet 1. Servlet 1 can go ahead and forward the request to the second servlet, and in parallel servlet 1 can also generate its own response. The second servlet also goes ahead and generates a specific response which is returned, and the responses are finally returned back to the browser. This is the syntax of the forward method. Request dispatcher object equal to request.getDispatcher, the URL pattern for the servlet or HTML, and then request.forward with the request and the response object. The include method, you can see here that the include method will send the request to servlet 1. Servlet 1 can generate its response, which is sent back to the client, or servlet 1 can go ahead and call another servlet 2, which can generate its own response. This response of servlet 2 is also included in the servlet 1 response. So the difference here between the forward and the include method is, in the include method you will get a consolidated response from both the servlets, which will be consolidated into a single response object and then sent back to the client. In the forward method, you had two individual responses that were getting generated. This is the syntax. The request dispatcher RD equal to request.getRequestDispatcher and the URL to navigate to, and rd.include request object and response object. So here we see a simple use case of a login screen with a username and password input field and a login button. When we click on the login button, we navigate to the validate servlet, which is providing validation and checking if the username password is valid. If the username password is valid, we forward to the welcome servlet, and the welcome servlet generates a response. On the other hand, if the validate servlet fails validation and the code does not successfully clear the validation parameters for username password, we simply include the HTML file in the response and send it back. So you see here you have the current index.html file along with the specific error message that is also consolidated and returned. Let's see a small demo of the request dispatcher so we understand better the difference between the forward and the include method, and also how do we navigate users across servlets. So to summarize on what we covered, the request dispatcher is an interface that is used to chain and called one servlet from another, or an HTML page from a servlet. The request dispatcher will bind the current request and response while chaining calls. No new request will be generated. The include method, as we saw, the response of the URL mentioned in the request dispatcher along with the current page's output will be shown. So the include method will include the current page along with the page mentioned in request dispatcher's configuration. The forward method, on the other hand, in this case only the URL mentioned in the request dispatcher, that outcome or that response will be shown. So it will not be a consolidated response that you will see. So let's look at this working. We will take a new dynamic web project. Let's call it dispatcher demo. Set the version to 2.5 so it generates a web config deployment descriptor file. We'll finish this. In the web content, we'll add a new HTML file and let's call it login.html. Let's add some code here that will simulate a login page. So an h2 tag that says login app version 1.0, for example. We'll add a form with action equal to login controller and method equal to post. Within this, let's say enter username. Here we'll have input, type equal to text, name equal to username, and we'll also have enter password. Just add a new line here. This will be password, type will be password, and we'll need a button to submit the form. So we're going to say input, type equal to submit, and value equal to login. So that completes our simple form. We'll now add a new package in the source folder. Call it com. We'll add a new servlet in the package, and this will be the login controller. That is what the form was posting to, action equal to login controller. We'll only select the service method. Here we will import javax dot servlet dot okay. So this is one way that I can use to actually go ahead and do a explicit import, and if I do not want to do that, then we follow the standard approach that we have been following so far, where we directly start with the code and it will prompt us for adding the relevant package imports, which we can do as we proceed with writing the code. So we'll come to the service method. Here we'll create string username to trap from the request object using the get parameter method. We'll pass username, which was the value we provided as the name of the input element in the form, and besides the username we'll also trap password, then we create the request dispatcher object equal to null. We import it from javax.servlet. Then we check if the username dot equals ignore case, so that will ignore the uppercase or lowercase, and if it equals Tom, so if the user has entered Tom as the username, and the password dot equals Jerry, in that case we'll take the request dispatcher object and that will be equal to request dot get request dispatcher, and we will associate this with a servlet that we will create later on, which will be called the success servlet. then we will use the forward method and pass the request and the response. So we will actually forward to the success servlet. So this will only show us the response of the success servlet. Now in the else condition, we will again initialize the request dispatcher, but we will display the login screen again. So in case there is an error, we want to continue to hold the user on the login screen, and we'll create an object of print writer equal to response dot get writer, and let's add the package for java.io, the imports on the top. Now this time we'll call the include method, which takes the request and the response. So the outcome of the login.html plus the current page output will also be displayed simultaneously. So the login.html and the output of the processing of the else condition, where we may want to print a custom message. So let's say we want to print a custom message here that says, let's add a span as well, and we'll say style equal to color red, invalid credentials. Close the span tag and close the center tag. So what we've done here is we've created a username password to trap the username password parameter, and that's what we had provided in the login screen. So here's the username password that we are trapping. Then we create a request dispatcher object. We check if the username password equals Tom and Jerry. We navigate the user to the success servlet. So the single servlet response success servlet will be returned. On the other hand, here we create a request dispatcher object pointing to the login screen in case validation is false, and we simply call the include method, which means the response of the login HTML will be retrieved. It will just redirect us to login HTML, and we have a print statement as well that is printing some additional content. So this print statement, the output of this along with the output of this login HTML response will be grouped together, included together, and we will get the output on the same page. Now let's go to the com package. We'll create a servlet which we will name the success servlet. Again, we need, and this perfectly matches the success servlet we gave here in case login credentials were successful, and we'll just keep the service method and finish. And as part of the service method, we create the print writer object equal to response.get writer, and we'll add the package and here we say out.print, and I give my h4 tag. We'll say welcome plus request.get parameter, and the success servlet will just display the username with a welcome message. So we'll display the username, and along with that let's concatenate login successful at, and let's say we take in the date plus, and finally the closing tag for h4. Okay, so sysout.print h4, we are saying welcome plus request.get parameter, and we are retrieving the username. To that we are appending a message which says login successful at, and to that we append new date. So I'll just put this onto the next line, and we'll just import java.util, which gives us the date class, and those imports automatically get added on the top using the ID. Okay, so in case the login is successful, if you look at the code that we wrote in the login controller, we were forwarding to success servlet. So success servlet just again picks up the username parameter and prints a message saying welcome user, login successful at, and the current date. We'll now go to the login.html page and attempt to execute this. We'll just have the dispatcher demo in Tomcat now. Restart the server. So it says enter the username and the password. And if I try to log in, I have my invalid credentials being displayed. So made a small spelling mistake there, so we'll save it and run the login page as normal. Restart the server and I get my output. I click on login, it says invalid credentials. Let's add some junk values. Continues to say invalid credentials. Let's add valid credentials. Tom as the username, Jerry as the password, and there you see it says welcome Tom, login successful, and it prints the login information. So the moment we tried to forcibly log in without correct credentials, you can see it returned the login page along with the print method that we had given. So this was the include, and you can see the URL is actually login controller. So it gave you the response from the login controller along with the response of the login.html page, which were both grouped and included together. However, when we added the correct credentials, we had the forward method that was working, and hence it just gave us the response from that specific servlet, which is the success servlet. However, please note that the URL continues to remain login controller. So the key takeaways from this session: servlet is a Java program that can perform dynamic operations and send to a web server the result. The web server then sends this response to the web client. The web container is built on top of the Java SE platform and implements the servlet API and the services required to process HTTP and other TCP/IP requests. The lifecycle of a servlet is controlled by the web container in which the servlet has been deployed. Servlet API contains a number of classes and interfaces that defines the contracts between a servlet class and the runtime environment provided for an instance by a confirming servlet container. Collaborating servlets is passing the common information that is to be shared directly by one servlet to another servlet of HTML or JSP through various invocations of the methods. Hope you did enjoy the session. We'll see you in the next session. Welcome to session 3 of the Advanced Java series, and here we would explore part 2 of Java servlets. In terms of the learning objectives, we'll start with discussing session management. We'll explain listeners in Java Enterprise Edition and filters. Let's start with session management. Here we'll talk about stateless web applications, stateful web applications, and session management and its types. We have learned that web applications are stateless by default since the given protocol, that is HTTP, is also a stateless protocol, which means it does not maintain any state. What is state? Let's assume that we visit a website. Now by default, we cannot expect the website to remember the information that we have entered into the web page when we close the web page and we next visit it at a later date. Hence, a programmer is expected to do some specific configuration and programmatic changes to the application so that the application can remember the information that the user last provided to the web page. It does not allow or provide data access to previous requests during the processing of current request in the servlet or JSP page. In a stateless web application, there is no way to preserve client data across multiple requests. So step 1, the client sends a request to the server. Step 2, the server receives the request. Step 3, the server responds to the client with some information, and step 4, the server closes the connection. And that is where the server will lose any information the client has entered into the server. Going forward, if you need to set up a fresh connection to the server is not expected to remember any information that you last provided to the web application. That is the default behavior of the HTTP protocol. A stateful web application, on the other hand, can remember or use the data of the previous request during the processing of the current request, and hence is termed as a stateful web application. In Servlet API, there are different ways of making web applications stateful so that it remembers client data across requests from the same browser. Making web applications stateful is known as session tracking or session management. So step 1, the client connects to the server. Step 2, we create a connection. Step 3, we get a response, and the server identifies the previous request state through session management. So the server knows that the last time the client connected to the server, this is the information that was available, and that information is provided back to the client. The server then closes the connection. Session management is a mechanism used by web containers to store information or session information for a particular user. The session is a conversational state between client and server, and it can consist of multiple requests and responses between the client and the server. Sessions are used for maintaining user-specific state, including persistent objects. The user session refers to a series of user application interactions that are tracked by the server. Types of session management. We have hidden form field, we have URL rewriting, we have cookies, and we have HTTP session. So let's explore the types of session management. The first is the hidden form field. When the server sends a response for one particular request, it sends one hidden field attached to it. The client gets the response with one hidden field, and in the hidden field, the name and value is set as a key pair value. If the same page sends the request the next time, the server can recognize it by getting the parameter of the hidden field. So here is the syntax: input type equal to hidden field, name equal to the key, and value equal to the value. One of the limitations of a hidden form field is that it requires extra form submission on each page. So here we have a browser with a form of a name and address. We send a request Moment we send a request, it hits the servlet. The servlet then sends a hidden field and name as an attribute, and that hidden field with name and attribute is stored along with the HTML page in the client browser. When we send a request again to the servlet can get that hidden field information and retrieve it. The second option is URL writing. In URL writing, one token is appended to the URL itself as part of the address bar. This token contains one name and one value as a key pair. With the help of hyperlink, the token's name and values are passed to the server. A name and a value is separated using an equal to sign. A parameter name value pair is separated from another using the ampersand. So here we see name 1 equal to value 1. This is one key pair, the ampersand symbol separating the second key pair value. URL writing works with hyperlinks and sends text information. So here we see the browser sending a request to the servlet, and the moment the user enters some data into the page, the second request that goes, the URL is modified with the key pair value. So here you have the name and the value with the second set of name and value. The third option of storing state and doing session management is a cookie. The Servlet API provides javax.servlet HTTP cookie class to maintain session. This class extends object class and implements clonable interface. While creating a cookie, a small amount of information is sent by a servlet to a web browser, saved by the browser, and later sent back to the server. Cookie has a name, value, and optional attribute. The browser returns cookies to the servlet by adding fields to HTTP request headers. The cookie has the following information: the name of the cookie, the value, the comment, the maximum age, which is the duration after which the client should not send the cookie back to the server, the domain to which the cookie should be sent, the path, and specifies if the cookie should be sent via the secure HTTPS protocol. So the client sends a request to the server. The server responds along with a cookie. So a cookie is a small file that ships along with the request back to the client, and on the next communication that happens between the client and the server, the cookie is sent along with the client back to the server. The code to construct a cookie with a specific name and value: we have the cookie constructor, which takes the value and the name as a key pair. The cookie class has the following methods: get name, that gets the name of the cookie; get value, that gets the value of the cookie; set max age, to set maximum age of the cookie; and set value, to set value to the cookie. Here we create an object of cookie with the name and the value. We add the cookie to the browser response by saying response.addCookie, so that the cookie information is stored on the client machine. To retrieve the cookie, we create an array of type cookies and we call the getCookies method. We iterate over the array and we print the name and the value that is stored on the client system. The limitations of the cookies are that all data for a session are kept on the client. Hence, corruption, expiration, or purging of cookies can result in incomplete, inconsistent, or missing information. Cookies may not be available for many reasons. The user may have disabled them, the browser version may not support them, or the browser may be behind a firewall that filters cookies, and so on. HTTP session is the fourth option. This is an interface which provides a way to identify one user across more than one page. The servlet container uses this interface to create a session between HTTP client and HTTP server. Servlet can view and manipulate the information about servlet. HTTP session has a method called getSession. The getSession method gets the current valid session associated with this request. If create is false, or if necessary, it creates a new session for the request. These are the set of methods available on HTTP session. Get max inactive interval, which returns the maximum time interval in seconds that the servlet container will keep this session open. Get ID returns a string containing unique identifier assigned to the session. Set max inactive interval, which specifies the time in seconds between the client requests before the servlet container will invalidate this session. Invalidate terminates the session and unbinds any objects bound to it. Get session returns the current session associated with the request. get session with a bool create, returns the current HTTP session. If no current session, create is true, it returns a new session. So here the client browser sends a request to the servlet. The servlet creates a HTTP session object and sets a key pair value as an attribute, and on the subsequent request that comes from the client to the servlet checks if that attribute value exists in the session object. It retrieves the value and sends it back to the client browser. Let's look at a small demo on session management in servlets. Let's go to Eclipse. Now, to summarize what we covered, HTTP is a stateless protocol, and hence if we have a wizard based navigation where we have a series of pages where we are passing data between pages, and finally on the last step of the navigation or the wizard we would want to save that data into a database. Now, HTTP being a stateless protocol, as we discussed, it cannot carry such information from one page to the other. It's only the browser's history object which keeps track of the forward and backward links in our page. Hence, to share data between pages, we need session management. Now, session management has 4 techniques. We saw hidden form fields, which requires a lot of GUI and code, also slows down performance. URL rewriting, where we have to manually rewrite and modify the URL of every page so that we can store information in the address bar. Cookies, which are stored on the client side. You cannot use it to save passwords, etc., because it's not secure. It can also be disabled by the client browser. Finally, HTTP sessions, which creates a unique session ID. It's server-side storage, and the data that you store in a session can be shared across pages of the current session that the user is interacting with the web server. Now, we have 3 types of scopes when we work with servlet. We have the request, the application, and the session scope. So events that occur between login and logout process of our website is called a session. So the moment we connect with a web server, the web server creates a unique session ID, assigns it to the client, and identifies that particular client by that unique session ID. And we can also track the login or logout time for the user. Simple example would be that when we go to a net banking website, and if we do not interact with it within the specified timeout interval, the session would expire and we are redirected to the login page again. So let's look at how do we do session management. We'll create a web project and we'll call it session demo. Set the version to 2.5 so we can create a web config file. We'll create a new HTML file in the web content. We'll call it 1.html since we want to simulate a wizard kind of an interface. We'll create a simple form with an action equal to first servlet and method equal to post. So we'll be creating this servlet. Later on we'll say enter first name, input type equal to text, name equal to fname. We create one more input text box which says input last name, and we'll change this to lname. A submit button, input type equal to submit, value equal to next. We'll add another HTML page since we are creating a wizard. Now this will be 2.html. we'll change the title to second. I'll use the form code, paste it into the second form, and here we'll say enter the age, type will be number, name will be age, enter email, type will be email, should be number, and name will be email, and the submit button would remain the same. We'll add a third HTML page. We'll call it 3.html. This would be the final page in the wizard. We'll change the title to third, paste the same code and change the fields to contact and city. So we've changed the field name to contact and city. Finally, on the SRC folder, we'll create a new package. We'll name the package as com. As a convention, it always helps to create a separate package for our servlet. We'll add our servlet, which is first servlet. We'll say next. Next again. And here, like we've been doing in the past, we'll select service and deselect post and get and finish. Now, if you look at the page 1, the 1.html page, it posts to first servlet when I click on the submit button. When I go to the second form or the second HTML page, we'll make this post to second servlet, and the third HTML form we'll make this post to summary servlet. So there are three different servlets that each HTML page will post to, and we will see how we can collect the data from each and every HTML page and summarize it into the final page and print it in the last servlet. Now we are accepting individual values from the user like first name, last name, and here let's change this to contact city, okay, and here age and email. Now instead of storing using session storage individual values like this, it will make more sense to store these values as an object of a class. So we'll create a plain old Java class, a Pojo, a plain old Java object, and we will map these variable names as data members inside that object, so we can retrieve these values, store it into a object of a class, and persist that object using session management. So we'll right click on the SRC folder and create a new package called data transfer object or DTO, and within this package we'll add a new class. We'll name this class as user, and we'll add the following code to this class. So we need a first name. This is the information that we were retrieving from the text boxes. Last name, email, city, contact, that will be of type long for a telephone number, and integer age. So this was the data that we were accepting as text boxes. We've created a separate class to store it, and we will create a constructor, default constructor, which is always a best practice when you create a custom class. I'll right click here, select source and select generate getters and setters, select all and OK. So it generates a get and a set for every variable that we created, which is first name, last name, email, age, contact and city, and we save this class. We'll right click and what we would want to do is we will say generate toString so that it overrides the toString method and prints all the values available in the class. So here you see it prints first name, last name, email, age, contact and city. This code was auto generated for us, which is very helpful. So it overrides the default toString method and returns all these values on the object of this class. Now let's go to the first servlet, and here we'll import the DTO package dot star. Okay, we'll add it to the end of our stack. So we've imported the DTO package, and within it we have our user class. Now we are interested in the service method. So here let's create an object of the user class, an object of HTTP session request dot get session. We'll import the required package. We'll set the first name by getting the value from the text box that the user enters. So we'll say get parameter fname. So the value that is entered in the text box is stored, and we want to store the last name, so we'll also get the last name value. Using the HTTP session object, we will call the setAttribute method, where we'll create a unique key, and the value to be stored in the session will be the user object itself. Once this is done, we simply send redirect and redirect the user to the second page in the wizard, which is 2.html. Okay, so we create an object of type user, we create a session object, we store the data in the text boxes that the end user has entered into the setName and LName function using the setters. We store that object into the attribute variable of session object so that it gets stored with the key user, and we navigate to the second page, which is 2.html. Now we'll add another servlet this servlet will have the name of second servlet. Again, we'll just have the service method and finish. We'll use the code that we had added here, paste it into the second servlet service method, and here we'll pass false to this constructor, indicating that we don't want to create a new session, but the session that was started from the first file, which is the first servlet started the session. We are getting a reference to that same session that is started in the first step of the wizard when the 1.html file posted to the first servlet. So now we need to check if the session is not equal to null. That means an active session exists. Okay, the moment an active session exists, we need to get a reference to it. So we'll create the object u and retrieve the existing user object that is there in that session. So we'll say get attribute, we'll pass the key which is user, and we'll typecast that object as type user so that we are type safe, and store it inside u. We'll now set which are there in the second HTML page. So the user will enter these values into the text boxes. We will retrieve it and we will store it into the same particular object which is u. We'll have to convert this into an integer since we had given age as a int value. So we convert this to an integer, store the value from the text box email into the object u, and age also into the same object, right? So here we are connecting to the same session that is created in the first servlet. We are checking, is that session not null? If not null, we retrieve the user object that is already stored in the session by giving the key, update the additional 2 parameters from the text boxes which is in the page 2, that is the second part of the wizard. Again, set the updated user object into the session with the same key, and this time we will redirect to the last page of the wizard which is 3.html. So this is how the pages will be maintaining the state and moving from one page to the other. We'll add the final servlet which is the summary servlet, which is relevant for page 3.html. Again, we will select the service method. We'll go to the second servlet. Okay, I'll just remove the declaration again because we've already declared this as a user object. So we'll just go ahead and assign it to the value that comes from the session. Okay, alternatively I could have also got rid of this and created the user object here itself. Now I'll just pick up this code, paste it into the summary servlet. So here as well we want to continue with the same session that was created in the first servlet. So I pass false and get a reference to the same session. We check if the session is not null, we get a reference to the user. Now we'll have to set the city which is on the third form, and we'll have to set the contact information. We'll remove the %, and replace with long dot parse long because that was a telephone number which is a long value, and replace this with contact. Now once this is done and the object is updated, we'll create a print writer object equal to response dot get writer out dot print line. We'll try and print the values that we retrieved. So we'll say hello plus user object dot get email. So we'll retrieve the email plus close the h2 tag. We'll copy this. Let me add the print writer imports on the top. And we'll print the details. So we just need to print the object u because we had overridden two strings, so it will retrieve all the values for us. And maybe we'll print this in an h3, in an h4. We'll go and print the session ID that we were speaking about. So session ID is session object dot get ID, and we'll also attempt to print session created at session dot get creation time. So this will tell us what time the session actually got created, and before that we will print the session ID. Post that we will destroy the session object, very similar to when the user logs out from the website. We will call the invalidate function, which will invalidate the session. We'll now go to the 1.html page. Hit a Control F11. We'll just ensure the session demo is published on the server. And it says enter first name and last name. So we say Amit and Kumar, and we move next. The next step is checking for the age and the email. So we enter some age and email, and the final step of the wizard says give me a contact number and a city. And here you see the entire object printed. Hello Amit at gmail.com, username, last name, email, age, contact, and city. So this information was stored into the session object and retrieved. You see the session ID, and you also see the session creation time, that is the timestamp. So this shows us how we have saved the data into the session. So the first file posted to first servlet, this is where we created the session. We saved some data into it. The second file we trapped data and we posted to the second servlet. The second servlet used the same session object, retrieved the user information stored inside, updated it, and pushed it back into the session, and that's what we retrieved on the final step and simply printed it out. So this showed us how do we actually store session information and retrieve it across various pages in our web-based application with servlets. Let's now move to our second topic, which is listeners in Java Enterprise Edition. Here we'll talk about events in the Servlet API, event class in the Servlet API, and event listener interface. Let's start with events in the servlet API. Change in the state of an object is known as an event which occurs during the life cycle of an object. There are important events related to a web application and servlets which are handled by event listener. To be notified of events, a custom class that implements the correct listener interface needs to be coded and the listener class needs to be deployed via web.xml. The event class servlet APIs consists the following set of classes and interactions with them. So we have the servlet request event, the context event, the request attribute event, and so forth. Listeners are objects that notify whenever any event occurs. They contain event processing logic. The listener interfaces in servlet APIs are as follows: servlet request listener, servlet context listener, servlet request attribute listener, servlet context attribute listener, HTTP session listener, HTTP session attribute listener, HTTP session binding listener. The first one, the servlet request listener, handles servlet request event. It notifies when servlet container is initialized and destroys request object. The servlet container generates servlet request event which it creates and destroys servlet request object. You have the request initialized and the request destroyed methods available. Then comes the servlet context listener. It handles and processes servlet context event. It receives notification when the servlet container creates or destroys context object. Again, two methods available. Next is the servlet request attribute listener. It receives a notification of the servlet request attribute event. It is used to find out when an attribute has been removed, added, or replaced from the request object. So we have the attribute event which receives a notification that attribute has been added. The attribute removed function which is called when a notification is triggered that an attribute has been removed, and then if an attribute has been replaced. Next we have the servlet context attribute listener. It receives and processes servlet context attribute event. Again, you have a attribute added, removed, and replaced method that responds to relevant notifications based on updates for the attributes in servlet context. Then we have HTTP session listener. It receives and processes HTTP session events. This listener is used to find out total active users. You have a session created and a session destroyed which receives notification that a session has been created and subsequently invalidated. Next we have a session attribute listener. It handles and processes HTTP session binding event. It is used to find out when an attribute has been added or replaced from the session. So here we have attribute added event that responds to a notification, removed and replaced. Then we have the HTTP session binding listener. It handles and processes HTTP session binding event. It notifies when the object of the class has been added or removed from the session. So here we have the value bound method which notifies the object that it has been bound to a session and identifies the session, and a value unbound, it notifies the object that it is being bound from a session and identifies the session. The last is the HTTP session activation listener. It receives a notification of HTTP session event. It notifies when the session migrates from one JVM to another. The methods session did activate, which notifies that the session has been activated. Session will passivate, which notifies that the session is about to be passivated. Application events provide notifications of a change in state of the servlet context. Each web application uses its own servlet context or of an HTTP session object. Servlet listener configuration. @WebListener annotation is used to declare a class as a listener. However, the class should implement one of or more of the listener interfaces. And then in the deployment descriptor web.xml file, this is how you would go and register the listener in the configuration. Let's look at a demo that demonstrates implementing the listener interface to do event handling and handle events. We'll go to Eclipse. Let's close this and We'll quickly summarize what we discussed and what we are going to attempt in this demo. Now listeners, listen for various events happening within our application. Events are associated with three different scopes: session, application, and request. When there are lifecycle changes for these scopes, an event can be triggered. For example, a session is created or a session is destroyed, and the practical usage of this is they can be used for auditing, like if we need to create a logging framework which will log to a file or log at a central location when the user logs in and user credentials are accordingly trapped, so we can maintain an audit trail. Whenever some attribute changes within these scopes, so if we have stored some attribute or information within this scope and that value changes or is updated, the event can be triggered. So the events triggered would be when you add, update, or replace an attribute value. For example, you cannot have multiple simultaneous logins when you log into your net banking account. The moment you log in, the information is stored in the session or some persistent media saying that this login ID has logged in, and that is tracked. The moment you try to log in again with the same ID, it will give you a message saying that this user is already logged in and does not have a option to log in again since the active session is already in progress. So let's take a small example and see how this works. We'll create a new dynamic web project. Let's call it listener demo. We'll select the version as 2.5. We'll go next and finish. We'll create a new package. Rename it to com. We'll add a new servlet inside the package, and we'll call it test servlet. Again, we'll select the service method and say finish. Let's come to the service method. Here we'll create an HTTP session object equal to request dot get session. So we create a new session. We'll create a system.out.println where we'll just log a message which says session created, listener will be invoked. Now we will add some data. Let's say username, and we'll give a value as Tom, and we'll also set another value in the session and name it as Jerry. We print another message which says session attributes displayed, and we'll just say listener to come here. Okay, so the second message, and then let's also let's update the username attribute, so we can have that update event, modified event, and we'll replace this value with Jim instead of Tom. Okay, let me add one more print statement, and here we'll say attribute modified, listener will be invoked. Finally, we will invalidate the session so that the session is destroyed, and we simply print a message saying session destroyed. Now, as a best practice, we'll add a new package. We'll call this as listeners. Within the listeners package, we'll now add a new listener that will listen for events. We'll name this my listener. We are interested in the lifecycle events of the HTTP session object and changes to attributes inside the HTTP session object. Lifecycle events would mean when is the session created. Changes to attributes mean when we update or add the username and password field. So we'll say next and finish. So in the listener, it will actually add event handlers for session created, destroyed, attribute added, removed, and replaced. This is what got added as part of the listener. So let's go to the session created first. Here, let's print hello from listener session created at and we'll say new date argument. So dot get session dot get creation time. So this will allow me to trap. Let me add the package java.util for the date class, and that's it. So we just copy this, we go to session destroyed and we say session destroyed. Finally, we go to attribute added, we paste here and we'll say from listener key with plus arguments of 0 dot get name. So we'll get the name of the key plus and value is plus arguments of 0, which is a parameter that is passed to this event. So we will be able to do an audit trail as discussed and trap the value, and then we'll just added successfully. So this is an event which will trigger when we add or we remove an attribute. So I'll just put this to the attribute added, and in the attribute removed we'll say removed successfully. Finally, the attribute replaced, if we replace or update the value, and we'll make this modified successfully. Okay, so let's go to the test servlet. We'll save all of the information. We'll use a control F11 to run. We'll remove the session and keep the listener demo published on Tomcat. Restart the server. And here you see hello from listener session created. This is the first message that came in with the date time, right? Now if you go to the listener, you will see this was the session that got created, hello from listener session created. And if you go to the test servlet, this is where we created the new session. Then session created, listener will be invoked. So this is the output. The moment we set attribute username and password, it trapped that in the audit trail and it said listener key with username and value Tom and password value Jerry is stored. So if you go to the listener, you can see that the attribute added was triggered and the added successfully got print. After that, session attributes displayed, listener to come here. So back to the servlet, this is the message that got printed. Then we updated username. So the modified successfully event actually triggered inside the listener. Attribute modified, listener will be invoked here. We invalidated. Moment we invalidated, the session destroyed triggered. So if you go to the listener, you see the session destroyed triggered. And finally, the removed happened because the session is invalidated, so the data from the session actually got removed. And lastly, the session got destroyed, so the session destroyed. So this explains the complete flow of how we were actually able to respond to events using the listener, and the events triggered in the right sequence based on whether we were creating the session, adding values, or updating values that we stored in the session. And this really helps from an audit trail perspective. If you want to log whether the user is logged in, you want to check what are the credentials of the current user that is logged in. And if you look at the web XML or the deployment descriptor file, you will see that Eclipse automatically configured the listener for you in the config file without us having to really do anything. So that completes our demo in terms of the listener events that we implemented on top of the servlet. Let's come to our next topic, which is filters in Java Enterprise Edition. Here we will talk about why filters, what is a filter, and filters in servlets. So filters are used when there is a need for an operation to occur every time a particular request is made, to perform one operation on other requests in the web application, and to allow one operation to be turned off at deployment. The filter API interface can be found in Java x.servlet package. A filter is an interface used to filter tasks on the request to a resource, a servlet or static content, on the response from a resource, or both. It has three methods as part of its lifecycle: public void init, do filter, and destroy. Filters are configured in deployment descriptor of a web application. So here you see the initial HTTP request hitting the servlet container. The request object is created, and before it reaches the servlet that exists inside the servlet container, the filter can be configured to execute. So the filter executes and then passes the request object to the servlet. This is called the pre-processing stage of the filter. The moment the filter responds with a data, this is called the moment the servlet responds with the data, the filter again processes that data, and this is called the post-processing step of the filter. So you can do pre-processing or post-processing before the request hits the servlet, or after the request is returned by the servlet and before it reaches back to the servlet container and then is sent out as a HTTP response. There are different types of filters: the request filter, which contains prerequisite processing logic; the response filter, which can be set as a post-response generation logic; and a request response filter that contains both pre-request and post-request processing. This is how we declare a filter in the web.xml file, and this is how we map a filter in our web.xml file. To write a filter program, we create a Java class to implement filter interface that has following methods: init, it is called once when the container instantiates a filter; do filter, it is called for every request intercepted by the filter; destroy, before the web container removes a filter instance from service, the destroy method is called; and we create one web.xml file to configure the filter. If multiple filters are configured for servlets, they are executed in the same order in which they are defined in the web.xml. So here we have the HTTP request, the servlet container, the request object is created. one filter is set up as a pre-filter processing, then the second filter picks up the request, finally the post filter, and the data is received by the servlet. The response object again goes through the same set of filters, and finally the HTTP response is sent out to the client. This is called as filter chaining, where multiple filters can be set up one after the other and they will execute in the order that they are defined. Let's look at a demo on filters so we understand the concept better. We'll go back to Eclipse and we'll run through a quick summary of what we discussed. A filter can be applied on any servlet or JSP page. The filter can be written either as a pre-processing logic before the request goes to the servlet, and it helps in reducing the load on the servlet or JSP page. It implements the interceptor pattern, which is one of the creational patterns part of the Gang of 4 or GOF design patterns. It is also useful to apply validations and check for the proper URL. If the user tries to ping the servlet without valid data, all such requests can be blocked at the filter level itself. They are generally used for validation purpose and intercepting of the incoming request. Filters can also read the data from JSP or HTML pages and create the object that can be shared with the servlet. The load on the servlet can dynamically and drastically reduce, and servlets can simply take that ready-made object that is created based on the data entered by the user in the UI screens and save it into the database. So we'll set up a new project to explain this and look at how to work with it. So a new dynamic web project, we'll name it as filter demo, set the version to 2.5 so we can create a web XML file and finish. Now filters also have a life cycle like a servlet. So filters, as we saw, they have three life cycle methods: init, service and destroy. That's what we saw as part of the servlet. Now a filter, we saw in the slides that it has init, do filter and destroy methods as part of its life cycle. Similar to the init, service and destroy that the servlet has, a filter would have init, do filter and destroy. Filter can also be connected with another filter which is called filter chaining, and the filters will be executed in the same order that they are created. So to explore this, we will create a new HTML file. Let's call it index.html. We'll add a form, action equal to, and we'll connect to register servlet and method equal to post. Here we say enter PAN number, input type equal to text, name equal to PAN, and input type equal to submit, value equal to validate. We'll save this. We'll create a new package, call it com, add a new servlet, register servlet, that's what our form was posting to, and we are only interested in setting up the service method. In the service method, we'll create an object of print writer out equal to response.get writer. We'll add the relevant package and we'll say out dot print, and let us say h4 pan number plus request dot get attribute, and we'll say pan, and we'll say plus validated successfully. Okay, and we will close on h4. Make this validated successfully. So here we have set up a filter, and you can see it extends. So rather, we have set up a servlet with a simple output method which says print. It just says the pan number. We get the attribute pan, and we simply print a value which says updated successfully. Now to do the validation for the pan number field, let's add a new package. We'll call it filters, and to reduce the load, as we discussed on the servlet, we will add a filter. We'll call it validation filter. We'll select the validation filter, click on the edit button, pick a servlet. The register servlet is going to be connected to this filter. We'll select that, go next, and finish. So if you view the web config file, the configuration for the filter would automatically be added as the filter mapping. Now let's come to our validation filter. So here you see the three methods. It implements the filter interface. It has the destroy, do filter method, and the init, which is part of the life cycle of a filter. Let's go to the do filter method. So here we see a method called as chain.doFilter, and this will call the next servlet in the chain once this filter has executed its doFilter method. So let's add our code here. We'll say string pan equal to request dot get parameter, and we will trap the value entered in the pan number text box. If the pan is null, or if the pan does not match, so we will give a match here, and we'll write a regex expression that the pan number should be having 4 digits, so it should have 4 digits followed by okay, so let's say let's make it 5 alphabets. So it will start with 5 alphabets followed by 4 numeric numbers, and at the end of that it should have another 1 alphabet. So 5 alphabets, 4 digits, 1 alphabet. That's going to be the format that we are going to validate for, and this will be a pre-validation step before the servlet is hit, because we said a filter takes off the processing load of the servlet and does a pre-processing. So print writer out equal to response dot get writer request dot get request dispatcher index.html. So we are asking for a reference dot, and we call the include method. We've covered that. We pass the request and the response. We'll add the package java.io for the print writer. So if the validation is fine, we then include index.html as the current response, and we also want to print a message within a span tag, and we'll say style equal to color, single quote, color red, close the span tag, and say invalid pan number, close span. Okay, so that's the error message. Now in the else part, we will, so if it's a successful validation, the else condition will move to the next servlet in the sequence and call it, and we will also do request.setAttribute pan So we'll store the pan value in the session. Okay, and the data that we stored inside the session object here by saying set attribute will be retrieved in the register servlet, because we are saying get attribute pan. So the pan number will be displayed successfully. Let's print some messages here. So we'll say hi from filter, and in the register servlet we'll say hello from servlet, just so that we are able to get the right sequence outputted and you would come to know what is executed. And once we print the message, we'll say bye from servlet, copy this, go to the filter, and in the else, if all is well, we'll say bye from filter. We'll go to our index.html and execute. We just need the filter demo to run, so we'll restart our server. So it says enter pan number. We just click on validate and it says hi from the filter. So you see the filter was hit and it validated and said invalid pan number. Look at the URL. This was because of an include. It included the current index.html and the return value of the processed servlet. Okay, and now if I enter junk data, doesn't work, still says invalid. Let's add a proper value, digits, alphabets, 5 alphabets, 4 digits, and 1 alphabet, and it says yes, pan number validated successfully. You see it started with a hi from the filter, it went to the servlet, finished the servlet processing, and came back to the filter and successfully printed the pan value. So that shows us how do we actually implement filters with servlets. So the key takeaways of this session: a web application can remember or use the data of a previous request during the processing of current request, and it's hence called a stateful web application. Session management is a mechanism used by the web container to store session information for a particular user. The hidden form field, URL writing, cookies, and HTTP sessions are type of session management. To be notified of events, a custom class that implements the correct listener interface needs to be coded, and the listener class needs to be deployed via web.xml. So hope you enjoy the session with Java series. And here we are going to explore and look at JSP or Java server pages. We will discuss the JSP architecture we'll understand JSP lifecycle, we'll explain how to create a JSP and run it in a web application, we'll discuss JSP elements and tags, we'll describe JSTL and custom tag libraries. Let's start with an introduction to JSP. Here we'll look at what is JSP, advantages of JSP, JSP architecture, JSP versus servlets, web container responsibilities, and JSP API. JSP is a text document consisting of HTML, XML, and JSP elements which can be expressed in standard and XML syntax. JSP is used to develop web-based applications. It supports the separation of presentation and business logic as follows. Web designers can design and update pages without learning Java programming language. Java technology programmers can write code without having to be concerned with web page design. It provides optional mechanism to configure web application file web.xml. JSP programming eliminates the need for repeated deployment, which means that saving the JSP and making a request whenever the JSP is changed actually will refresh the JSP page. The automatic deployment is taken care of by the container called Jasper, which stands for JSP Execution Environment. JSP programming languages also provides custom tags development. The JSP programming environment provides automatic page compilation. Here is the JSP architecture. We have a browser that sends a request to the servlet. The servlet plays the role of a controller in a typical MVC or model view controller pattern. The controller may forward the request to a Java bean, which is a Java class which acts as a model and defines the structure of the data. The Java bean gets instantiated. The response from the Java bean or the data can be forwarded to the JSP, which plays the role of the view. So here you see segregation of responsibility, where the servlet plays the role of the controller, which defines the flow of the use case. The data is managed by the model, which is the Java bean, and the view or the presentation layer is managed by the JSP. And finally, in case you need to connect to a data store to retrieve data, that is also possible. JSP is used to dynamically generate web content on a server and return it to the client. This can also be done using a servlet. So why do we need JSP? JSP performs a number of tasks. To understand, let's learn about the differences between JSP and servlets. JSP is a web page scripting language that can generate dynamic content. Servlets are Java programs that are compiled. They create dynamic pages. It is easier to code in JSP than in Java servlet. It involves writing a lot of code in the servlets. JSP, in MVC model, we saw that the JSP acts as a view. Custom tags can be used, which can directly call Java beans. JSP is generally preferred when there is not much processing of data required. It runs slower compared to servlets as it takes compilation time to convert into Java servlet. On the servlet front, in MVC model, the servlets act as a controller. There is no such custom tag option available in servlets, and servlets are best for use when there is more processing and manipulation involved. Servlets also run faster than JSP. What does a web container do in JSP? It provides standard libraries required for coding. It provides a suitable environment for execution. It calls the callback methods at appropriate times, and it maintains the life cycle of the program. JSP technology is based on JSP API. It consists of the following packages: servlet.jsp, which is the classes and interfaces for core JSP, servlet or the Java server pages library, and finally the EL or the expression language package. Let's look at the JSP lifecycle and its implicit objects. The JSP lifecycle involves the following steps: translation of JSP to servlet code, compilation of servlet to bytecode, loading servlet class, creating servlet instance, initialization by calling JSP init, request processing by calling JSP servlet, and destruction with JSP destroy. In the first step, the web container translates the JSP file into a Java source file that contains a servlet class definition. So when we request the web container for a JSP file, the JSP file is converted into a .java file. That is the first step. The compilation of servlet is then done to bytecode. So if you look at the hello.jsp file, this is the server-side scriptlet where we are initializing a count to 0 and simply printing it again in the JSP scriptlet. Here we have the JSP class hello JSP, which extends the servlet, and you can see how the JSP was translated into the equivalent code that we wrote in the previous demos to generate a servlet. In the second step, the web container compiles the servlet code to a Java class file. So the servlet source code will now be converted into a Java file, and further the compilation will happen to convert the .java to a .class file. In the third step, the servlet bytecode is loaded into the web container's JVM software using the class loader. So that you can see the web container will be loaded with the compiled bytecode. In the fourth step, the web container creates an instance of the servlet class. So here the web container will fire the constructor to generate an instance of the servlet class that was generated from the initial JSP. In the fifth step, the web container initializes the servlet by calling the JSP init method. So that is step number 5. The initialized servlet can now service requests, which each request the web container can call the JSP service methods for the converted JSP page. And here you see that step number 6. When the web container removes the JSP instance from the services, it first calls the JSP destroy method to allow the JSP to perform any requirement cleanup. What are implicit objects? These are the Java objects that the JSP container makes available to developers in each page. The developers can call them directly without explicitly declaring them. JSP technology has 9 implicit variables. They represent commonly used objects for servlets that JSP page developers might need to use. You can retrieve HTML from parameter data by using the request variable, which represents the servlet request object. Here you see the implicit variables. The request variable, the HTTP servlet request object associated with the request, the response object associated with the response, the JSP writer object associated with the output stream if you want to write content in the response, the HTTP session object with the session for the given user of the request, only meaningful if the JSP page is participating in a session, the application scope, which is application wide, data sharing, the config, which is the servlet config application object for the web app, page context that encapsulates the environment of a single request for this JSP page, and exception, the throwable object that was thrown by some other JSP page only available in a JSP error page, and finally the page scope, which represents current JSP page. Let's look at creating a JSP page and running it in a web application. Now, unlike servlets, deploying JSP pages is as easy as deploying static pages. JSP pages can be placed in the same directory hierarchy as HTML pages. In the development environment, JSP pages are placed in the web directory. In the deployment environment, JSP pages are placed in the top level directory of the web application. To create a JSP and run it, you need to configure the server, create a dynamic web project, create JSP files in the web content folder, and create relevant HTML files as well. Let's look at working with JSP elements. JSP elements is a JSP in a JSP page can be expressed in two types of syntaxes, standard and XML. Here you see the standard syntax for a comment and the XML syntax. Both of them are legal. A declaration syntax can be done in either of these ways. Directives for including @page and tag library, which is used for custom tags, can be written either in this or in this manner. Expressions for evaluation can be written either in this manner, and scriptlets with code that needs to be executed in server side would be written like this. The JSP comment is used when you are creating a JSP page and want to put comments about what you are doing. JSP comments are only seen in the JSP page. These comments are not included in servlet source code during translation phase. They do not appear in the HTTP response. The declaration tag, we can declare a variable or method in JSP inside the declaration tag. The declaration is made inside the servlet class but outside the service. We can declare static member, instance variable and method inside declaration tag. Then comes the directive tag, which is used for special instruction to web container. It includes three tags: page, which defines page dependent properties such as language, session error page; taglib, which declares tag library used in the page; and include, which defines the files to be included in the page. The page defines page dependent properties such as language, session error page. It defines a number of page dependent properties that communicate with the web container. We can use the following attributes: import, language, extends, session, error page, content type, buffer. The tag library declares the tag library that is used in the page. JSP allows you to define custom JSP tags that look like HTML or XML tags. A tag library is a set of user-defined tags that implements custom behavior. A tag library directive is used to define the tag library that the current JSP page uses. A JSP page might include several tag libraries. The include defines the file to be included in the source code. It has an attribute for file. The expressions are evaluated when a JSP page is requested. The results are converted into string and fed to the print method of the implicit object. If the result cannot be converted into string, an error will be raised at translation time. If this is not detected at translation time, a class cast exception will be raised at request processing time. The scriptlet tags allow you to write Java code inside JSP page. The scriptlet tag implements JSP servlet method functionality by writing script or Java code. Everything written inside the scriptlet tag is compiled as Java code. Caution: when to use declaration tag over scriptlet tag? If you want to include any method in your JSP file, use declaration tag. During translation phase of JSP, methods and variables inside the declaration tag become instance methods and instance variables and are also assigned default values. Anything we add in a scriptlet tag goes inside the JSP service method. We cannot add any function inside the scriptlet tag as it creates a function inside the service method during compilation, which is not allowed in a Java method. Let's look at a demo of JSP tags and implicit objects. To summarize what we did, we covered concepts which said JSP will be converted to servlets internally. A .jsp is converted to a .java file and then ultimately a .class file. The first phase of a JSP lifecycle is the translation phase, where the JSP is converted into a .java file. Then comes the JSP init, the service, and the service method. The JSP service method is the most frequently used method that we will use in our demo. We will look at writing JSP tags in this demo and look at the 9 intrinsic objects. Servlets are good for business logic and not presentation. JSP does much better there in terms of the view in the model view controller. Servlets do better acting as a controller. Servlets play the role of a controller and JSP hence plays the role of a view. Let's start with creating a new project. We'll call it JSP demos. We'll go to the web content, and here we'll create a new JSP. We'll name it as index.jsp. Let's add some code. Hello from HTML. And we'll say h1 hello from JSP. And we'll save this. So you see the scripted tags here, which will actually get executed on server side. We'll execute this. And moment it executes, we see the hello from HTML, and this is the hello from JSP that we wrote in the scripted. Let's add another. We'll define a variable int x equal to 10 and try to retrieve it in the HTML. So here we'll say input type equal to text, value equal to, and we'll give an expression here equal to x. We don't have to restart the server each time. We can save and refresh the servlet, and there you see the value bound to the text box. Let's say that we want to create a simple loop. Let me again open a scriptlet. We'll write a simple for loop which says integer I equal to 0, I less than 5, and I plus plus. Out dot print, and let's print the value of I equals plus I, and we'll put a break. Let's also add a break after this line. Let's refresh our page, and you see the for loop getting executed in the JSP page. Let's click on the web content, and this time we will add a HTML file. Let's call it footer.html. We'll delete the existing code and just add a div tag with an align equal to center. Simple text, I am a footer, and save it. Now we want to include this file inside our JSP, so we'll do that with a simple include which says %include file equal to footer.html. HTML. And when we refresh our JSP, you should see the HTML file included as part of the JSP output. Now the include directive performs the job of the request dispatcher similar to that, so it amalgamates the response even though the URL is index.jsp. It collaborates the responses of both the files and puts it into one single output. So there are three types of directives we can use: @include, @taglib, which is used for custom tags, and @page, which can also be used to import resources. Let's try printing the date. So we will say the current date is percentage equal to new date percentage let's import the package. So I'm going to select date here, and that will automatically import the package with @page import, and that shows you the usage of the @page include. So let us refresh the page and you see the current date. Let's go back. We had an additional bracket here, so let me copy this and paste it above the footer with some PR tags, and we refresh and we look at the output of the current date. If we need to add a comment is added like this. Now this obviously will not be printed onto the output because it is the comment. So we have a set of 9 intrinsic objects available. First is out, which is part of JSP writer scope. We have the application object available in JSP, which is of servlet context scope. We have the config object, which is of servlet config scope. We have page, which is of base object. We have page context, which is of page context scope. We have exception, which belongs to throwable. We have request, which belongs to HTTP servlet request. And finally response, which belongs to HTTP servlet response. So the page context is actually used for adding, modifying, removing attributes from any of the 4 scopes. Now in servlets we had 3 scopes: application, session and request. In JSP we have 4 scopes: application, session, request and page. So the page scope is accessible throughout the page at page level, and the response is used to redirect to or send data to the user or the page. Let us try to use some of the above objects. So here we'll create a form and say action equal to null, enter name, input type equal to text, name equal to fname. and we'll have input type equal to submit, name equal to click, value equal to click me. Now let's add a scriptlet. Here we'll say that if request dot get parameter click, so click stands for the button. Now this will indicate whether the button has been clicked or not. So we'll check if the button has been clicked, then this should not be equal to null. So if the user has hit the submit button, we will say out dot print hello plus, and we use the request object here, request dot get parameter f name. So we are just trying to retrieve the first name value from the text box and display it to the user on the screen. So let's refresh. So we enter the name, and that's the name that gets displayed. So it works. So with that, we have seen how to create a JSP page, host it, use some of the intrinsic objects within the JSP page, and also include HTML pages within the JSP page. Let's start with our next topic, working with JSP standard action or action methods. Here we look at JSP standard action elements, list of JSP standard action elements, JSP expression language or EL, and EL implicit objects. The standard action elements are basically the tags that can be embedded into a JSP page. During compilation, they are also replaced by the Java code that corresponds to the predefined task. Action tags can be written only in XML syntax and can be used for communication. Here are a list of standard JSP action elements. Forward include plugin, param, fallback, set property, etc. The useBean tag is used to interact with the JavaBean component using standard tags in a JSP page. So we have a useBean, the ID, the scope, whether it is scope to this page, scope to the request, scope to the current session or the application itself, and the name of the class. So the ID specifies the attribute name of the bean, location of the bean is specified by the scope attribute, and the class attribute specifies the fully qualified class name. The set property tag is used to store data in the JavaBeans instance. The name attribute specifies the name. This must match the ID attribute used in the useBean tag, and the property expression can be represented as follows. Property equal to star indicate we want to map all the values in the current JSP page form to fields that are there in a JavaBean class, and respective properties can also be mapped in this manner. The get property tag is used to retrieve a property from a JavaBean instance and display in the output stream. The name attribute specifies the name of the JavaBean instance, and this must match the ID attribute in the useBean tag. The action tag is used to insert the output of another JSP page into the current JSP page. The syntax is as follows: JSP include page equal to relative URL and flush true. This syntax is used to pass information to the including resources. JSP include page equal to relative URL flush equal to true, and if you have any parameters to pass, you can provide them in a JSP :param tag. Let's look at the include directive versus the include action. The include directive includes the source code, so it is static. Include directive is an attribute for file. It can be written in HTML or XML. It can include source code of a JSP and HTML but not servlet. We can't pass the expression as a value to a file. Include action includes the output, so it is dynamic. It has an attribute for page. It can be written in XML syntax. It can include the output of servlet, JSP and HTML. We can pass the expression as a value to the page attribute. JSP-EL allows you to create arithmetic expression and logical expression. It uses integers, floating point numbers, strings, built-in constants, and null. For example, dollar of expression. So here you see dollar of length into width is an expression that will get evaluated. Here are the EL implicit objects. The page scope, which provides access to variables stored in the page. Here we can access variables stored in the request, session, application scope. This gives us access to parameter values through getParam. We can also access param values. Here we can access the header strings, header values collection. Init param, which is used as context initialization parameter. Cookie maps the given cookie name to the cookie value, and page context. Let's look at a demo of writing a JSP program to demonstrate JSP standard action elements. A JSP action tags are used to perform certain operations like include, forward or set, as we saw. In this demo, we will look at how reflection API works and how a JSP can be reflected onto a Pojo class, which is a plain old Java object, directly using action tags. I'm going to open up a simple registration page with a form. Here you can see that there are fields like first name, age, email, password, etc. There is a checkbox and a select option with a submit button. We will now create a Pojo class on which we will reflect the form fields inside the class and the action tag that we will use, which will automatically call the setter methods of all the fields in the Pojo class, and it will also keep the object in the session, page, request or application scope accordingly. As per conventions, we have ensured that all the field names in the form are in lowercase. We'll create in our project a new package. We'll call the package com.to for transfer object, because this is going to hold the values that will be transferred from this form. We'll add a new class. We'll call it user. We'll add the data members of the class, and the reflection API will automatically internally convert the values from the fields in the text box to the individual values and data types that are required here. First name, age, which will be integer, email, these are the same fields we declared in the form, password, gender, which was the radio button, hobby, which was the checkbox, and finally country, which was the drop down list. We'll create getters and setters. Source, getters and setters. So let me select inside the class and now select all and OK. So I have my getters and setters created for all the properties. We'll add a default constructor which is mandatory. So we'll say private user, always a best practice. We'll generate our toString method. So let us say source, and this will help to create and return and print all of the values so that we do not have to individually print them in the JSP. Now let's come to our register.jsp page. Here let us add a simple scriptlet. Here we'll say if request dot get parameter register not equal to null, okay, we'll open another scriptlet here which will hold the closing bracket. This will hold this if condition, and here we will now say JSP use bean ID we will give as user, class will be com.to.user. We'll just hit the control button, and if you are able to click on this and it generates a proper link, indicates it has picked up the correct path to the Java Bean class. We now have to, by default the scope is going to be page scope, in which it will store this user object information. If we want to change it, we can say scope equal to, let's say, the request object. So now all the data entered in the form will be converted into an object of type user and associated with our user class. Now let's map this particular JSP so that it will call the setter for every property that we have inside our class. So the name will be user, and property we'll keep it as asterisk. So all the values in the form will be mapped to the variables inside the user, the Java Bean class called user, and this is the line of code that will call the setters for every property and assign the values. And finally, since we are using the request scope, we will call the forward method, so we can forward and keep the request object alive, and we will forward to register servlet. Let's add a new package. com.controller. The servlet will play the role of the controller in the model view controller design pattern. We'll name the servlet as register servlet. Move next. We'll keep only the service method. We'll import com.io, or rather com.to.user. We'll come to the service method, and here we'll read data from the user object equal to, we'll typecast the object as user and retrieve it from, we had stored the information in the request scope, so we'll get it from the request object by passing the same attribute user. We'll create the print writer object equal to response dot get writer and out dot print, and let's print in an h3 tag your details plus the user object. Since we already have overridden toString there, the user object will return all the data to us. And that should be good enough. We'll go to the JSP page, which is the register page, and execute it. So our form should come up. Oops. So com.to.user, you can see here, is what it is telling us that we need to set up. So let's go here. So it's properly opened up this particular class, which indicates the registration is fine. Let's look at what it says. In the register.jsp, the value of user bean class attribute is invalid. Okay, now there could be some mismatch between the attributes that we have provided. So we had a fname, age and email. Fname, age, email. We have password, gender. So let's check for that. Password, gender. We have hobby and country. So here we have hobby and country. Let's come back to our servlet. Here we have imported com.to.user. We are retrieving the user value and simply printing it. So let's look at the JSP use bean tag again that we have used. So we have set ID equal to user, class equal to com.to.user, scope is request, the name again of the set property is user. That's what we have assigned in the ID, and we are calling a register servlet on the page forward. So let's save this. Come to the user class again. Let's make the constructor as public so that it can be accessed. The default constructor should be public. And we'll execute. So let's just run through what we did. We had a register.jsp page where we created a simple form and we provided name values for each input element. We then said that the moment somebody clicks or the user clicks on the register button, we will map this form to a simple Java bean called the user class that we created, and all the properties that we have created in the user class, the setters will be triggered for that, and the values from the text boxes will be mapped to the user object inside the user class. In the user class, we had created setters and properties based on the names that we actually had in the JSP page. The values here as data members exactly map to the names that we created for the input controls in the JSP page. We had made the constructor as well public so that we do not get any errors on execution which could say that the object of this class could not be created. So this is essential that we have a public default constructor in the class, and then we have getters and setters and a toString method that is overridden to print the values. In the servlet class, we are actually picking up the user object from the request, since we had stored it in the request scope, and we simply print the details as an output. So the moment we run this, we get the form. Let's enter data into the form. The moment we enter data into the form, the data will be stored in the scope of type request. We'll add a password. We'll select the gender. We'll select some hobbies and the country and say register. And you see the data actually gets stored automatically into the user class object and gets outputted, and this is because of the mapping that we did of the JSP class, or rather the JSP page, to the Java bean, which is the user class. And the mapping here was done using the tag which was JSP set property. Let's now move on to the next topic, which is JSTL and custom tag libraries. JSTL 1.2 is a part of Java Enterprise Edition 5 platform. JSP Standard Tag Library, or JSTL, represents a set of tags used to simplify development of JSP. We can use the JSTL tags in various pages, and it avoids the use of the scriptlet tag. Here are the core tags of JSTL, which provide variable support, URL management, and flow control. We have SQL tags, which provide SQL support, XML tags to provide flow control and transformation, internationalization tags to provide support for message formatting and number and date formatting, and function tags to provide support for string manipulation and string length and flow control. Here are the core JSTL tags, which are used to write expressions and render data to the page. So we have a welcome.html page with the action equal to process.jsp and first name and fname and a submit button. So here you see the process.jsp page with the tag library, where the URI points to the JSP JSTL core prefix equal to C, and here you see we are prefixing that namespace of the imported tag library and simply using the JSTL tags to say out value and the expression binding block with the brace brackets param.fname. So the value entered in the text box would be outputted by the JSP page. So here you see the tag library, where we are again importing the core JSTL tag. The prefix is C, so we say C:set variable equal to income, scope equal to session. Here we have a simple if condition which tests if income is greater than 8,000, print my income is and the income value, and this is the expression to print out. So the test is a condition to evaluate, the var is the name of the variable to store the condition result, and the scope of the variable to store the condition result. Let's look at another example. Here again, after importing the core JSTL library, we have a catch where we store a variable equal to catch exception. Within the server scriptlets, we say integer x equal to 2 divided by 0, and we test. If the catch exception is not null, then print the type of exception that has occurred and the message, which will be an division by 0 exception. So this is similar to the try catch handler that we used to put in our core Java code. Let's look at the custom tag syntax rules. JSP allows you to create your own tags. They are known as custom tags. They use XML syntax. There are 4 fundamental XML rules that all custom tags must follow. Standard tag syntax must conform to the following structure: prefix name attribute equal to value. Empty tag syntax must conform to the following structure: tag name attributes and prefix are case sensitive, and tags must follow a proper nesting rule. So if the tags have to open and close and should be nested correctly. Let's look at a demo to build a custom tag. We'll go back to our Eclipse and we'll close our existing files. Now, JSP custom tags typically avoid code redundancy, and they also prevent code from being exposed in the JSP page. The JSP custom tag logical code is hidden and only the tag is actually visible in the page. The same tag can be reused any number of times across multiple pages. The custom tags hence promote reusability because they can be called from different places. JSF, Spring, Struts have multiple custom tags defined to make and simplify the programmer's effort. The types of tags available when you are creating a custom tag are: first, simple tag, where you can create a tag without any attribute or body, for example the BR tag in HTML. Then we can create tags with attributes, that's the second option. For example, we can say let's say align equal to center is an attribute for the div tag. Third option, tags with attributes and body. Fourth option, tags without attributes and body. So here we'll create our own custom tag in this demo. We will use the taglib directive, and the steps to create a custom tag would be: step 1, we'll create a tag handler class, override the doTag method, and we write the task this tag should perform there. Step 2, we create a .tld file, which stands for tag library descriptor. It is like a web.xml file, and one TLD file can have multiple tag libraries defined in it. We then import the TLD file inside the JSP page as required by using the taglib directive. So let's create a new project. We'll call it custom tag demo. Move next. And finish. We'll create a new package, call it com.tags, and say finish. We'll create a new class, let's name our class as print date tag. This could be, or this rather would be, the custom tag we are trying to generate. This class will extend single tag support, and you can see the import statement gets added automatically. We'll add, or let's try to override So the do tag method is what we are interested in, as we discussed. That's what we would want to override. The override annotation also gets added. We'll create an object of JSP writer out equal to get JSP context dot get out dot print. We'll open the h3 tag and we'll say current date is plus new simple date format. To it we'll pass td and after that hours, minutes, seconds and the day. Dot format, and we'll format the current date using this particular rule set plus, and we'll just close the h3 tag. Let's also import java.util package. So this custom tag that we are creating is simply going to print out the date, the current date in this particular format along with the time and the day. Now this is a simple tag without the attribute and without the body. So let's create a TLD file. We'll go to the web.inf folder. Let's create a new file. This is the tag library descriptor file which will hold the config information. mytags.tld. This is similar to the web XML file. We'll need to add the top part or the header of this file, which is constant without any errors. So we'll say XML version equal to 1.0, encoding equal to ISO -85 8859-1. So this is the standard XML encoding, and then we simply add our doc type tag library. Post that we specify the namespace, which is Sun Microsystems Incorporated document type definition is what DTD stands for. So this is the standard namespace that has to be provided at the top of the TLD file. 1.2 EN, and the namespace as java.sun.com/. So this is going to be constant for every TLD file that you create. web-jsp tag library _1_2.ddd. So we have added the fixed content that needs to be added at the top of the page. Now we need to add the entry of the tag class that we created. Now one TLD can have multiple tag definitions, so we are going to say tag lib tlib dash version 1.0 JSP dash version 1.0. This is standard syntax that has to be followed for a tag lib file. Now this would be the short name of our tag, so we'll just say st and then provide the tag information. The tag will have a name, let's call our custom tag with a name of myDate. Tag class will be com.tags.print date tag. When I press and hold the control key, if you get a link like this, indicates that the class has been successfully mapped. Body content is empty because this tag does not have any body. Let's now add in the web content a new JSP file. We'll name the file as testtags.jsp. At the top, let's add @tag library prefix equal to st, that is the short name of our tag, URL equal to web-inf/mytags.tlt. That's the name of our configuration, and we'll save this. So that has to be added at the top of the page. So we've said @taglib prefix equal to st, URL equal to web-inf /mytags.tld, and we quote it. Now this is mandatory as a step for your custom tag to be added. This is URI, or Universal Resource Identifier. So that's done. Now let's come to the JSP page, and here the short name for our tag is st and the name is myDate. So the tag gets recognized. So st was the short name of the tag and myDate is the tag name that we had specified, and here you see the date actually getting outputted, which is the current date and time. Okay, and that happened due to the custom tag that we injected here, and the custom tag can now be reused across multiple JSP pages. Now let's go for the second type. We'll create a custom tag with an attribute. So the date should be displayed based on an attribute that we provide to this myDate custom tag. So we'll go to this package, we'll add a new class. Let's call the class custom date. We'll pick up the do tag, but before that let's extend from single tag support. Let's also add the do tag method so it is overridden, and within the method I'll just go to this class, we'll copy this content and paste it here. Let's create a simple class variable called private string format. Let's create the getter and setter. We don't need the getter, so we'll get rid of it. And just have the setter, and we will replace this hard-coded value with the format variable that we created. So we will allow the user to pass this variable to our custom tag by saying format equal to whatever format the user would want to set, and we will be able to format our date based on the inputs from the user. Now we discussed that a TLD file can have multiple declarations inside it. So we add one more tag. We call this custom date tag. com.tags.custom date is the name of the class. Content is empty. We do have an attribute, so we'll say attribute, and the name of the attribute is format. So this is how we create a custom tag with an attribute. Now, to force users to provide the attribute name each time and make it mandatory, we will say required true. Now, to parse the format to our format variable we have created inside our JSP or custom tag class, we will need to set RTX, or rather RT expression value, to true. If we don't set this, we need to strictly pass the attribute value in the string format. If we set it, we'll get the value as an object, and we will not be required to strictly set the value in that particular type. Okay. If we get the value as an object, we then cannot receive it inside our custom tag, and hence it is essential to set this to true. So that's done. Let's now come to our JSP page, and here we'll use the short name custom date tag format equal to ddmmyy. We'll make a change in this class. We'll say custom date is, so that we know that this output is from the specific custom tag. Let's revisit. So here we set custom date tag and com.tags.custom date. So here is our class which is custom date, and here in the JSP we set custom date tag with a format that we actually provided. I could have also provided a format in this manner. Let us close this and execute. And there you see the output. The custom date is based on the format that we have actually provided. So we should ensure that we restart the server once we add a new custom tag to the application. Now we'll try and create a custom tag with a body. So let's go ahead and add a new class. So we'll try to create a custom tag along with a attribute and a body, and we'll call it uppercase tag, so that whatever value we pass to this custom tag, it will convert that body content to a uppercase. Again, let's say extends simple tag support to tag to be overridden. We'll pick up this object, the JSP writer. Then we'll create string writer equal to new string writer. Let's import that package. This will allow us to trap whatever content is passed to our custom tag, and we'll pass the string writer to the invoke method so that we can trap the value, or we can trap the body content that is passed to our custom tag. So the body content will be captured and passed to the string writer object. Out.print, we'll try printing in a bold tag plus sw dot toString dot to uppercase plus the bold tag. Now let's go to the TLD file. We'll simply copy the tag. We discussed that a TLD file can have more than one custom tag declaration. We'll call this upper. The class name will be uppercase tag, and body content will not be empty but scriptless, so that we do not have any script there, we just have plain text content. Now let's try adding this tag to the JSP page. So we'll add some PR tag, and here st upper was the name of the tag, will be displayed in uppercase st upper. So there we have added the custom tag. We save We restart the server since we have added a new custom tag. And there you see the content, actually the body content that we passed has been converted to uppercase. The key takeaways that we saw from this session: JSP is a text document consisting of hypertext markup language, XML and JSP elements that can be expressed in a standard and XML syntax. Implicit variables are the Java objects that the JSP container makes available to the developers in each page. The developers can call them directly without explicitly declaring them. JSP elements in a JSP page can be expressed in two types of syntax, standard and XML. And JSP EL allows you to create arithmetic and logical expressions. It uses integers, floating point, numbers, strings, and built-in constants, true and false for Boolean values and null. We'll see you in the next session. Welcome to the fifth session in this series, which is Introduction to Hibernate. Here we will discuss Hibernate basics, Hibernate ORM features. We'll set up a project with Hibernate, look at annotations, and move to create, update, and delete operations. Let's start with the basics. The Hibernate framework was created by Gavin King in 2001. The latest version is 5.2.10. Let's start by discussing why we need Hibernate and why it was created. It is a framework that simplifies the development of Java application to interact with the database. Let's understand why we need it with the help of two scenarios. Let's consider a scenario where a user has a program with MySQL database connectivity. Now, if you look at the illustration here, the user needs to write MySQL specific code to create the database connection. Now, just in case the user shifts from a MySQL to an Oracle database, the user has to repeat the process of writing database connectivity code, which is Oracle specific. So the connectivity code is difficult to modify because it's in the source code, and we'll have to recompile the application every time we change the data storage mechanism. Hibernate hence converts database specific queries automatically based on a dialect provided, and it uses HQL or Hibernate query language, which is independent of the database. So it prevents the user from changing the code and queries to map to different data source once you change a data store, let's say from MySQL to Oracle. Let's consider a scenario of a user with various billing records. The user in the billing records data needs to be stored in a DBMS. For this, the user class has to be mapped to the user table, and the billing records has to be mapped to the billing records table. So this is the class that we will actually set up. When you create the class, the schema for the user and billing records classes will automatically be created for you. So this is the class representation with the data members, and this is the equivalent SQL statement that will be created to generate the respective tables. Now, what could be the possible problems with this? The association problem. We are talking about object relationship mismatch problems. In terms of the association, Java can use association by having another class variable as a member. In SQL, no standard concept is available to represent association. Navigating data, it is different in Java and SQL, and cost mismatching due to manual handling of object relational mismatch. Let's add two subclasses, credit card and debit card, which are subclasses of the billing record. Now, what could be the possible problems here? SQL does not support supertable and subtable relationship. Table is not a type, so it is difficult to create supertable subtable relationship, and writing SQL query for polymorphic relation is difficult. In user table, ID is the primary key. This is a foreign key for the billing record table. It is hence difficult to change the ID. We need to update not only the ID column in user but also the foreign key column in billing record. We also need to add surrogate key in user and billing record table. The surrogate key isn't presented to the user and is only used for identification of data inside the software system. User surrogate ID and account number ID are system generated values. It is difficult to decide whether these columns should be added to data model or not. Different persistence solutions have different strategies, and this can cause confusion. What is the solution? Hibernate provides an ORM or object relationship mapping which takes care of these issues. Let's look at ORM and its features. ORM refers to automated and transparent persistence of objects in a Java application to the tables in a relation database using metadata that describes the mapping between the objects and the database. So here, once we create a Java Pojo class or a plain old Java class in your code, and let's say we provide data members like ID and name, we will automatically be mapping this to a table in the database, which the Hibernate framework will generate automatically for us with the same set of columns and mapped to the class structure that we have, and hence we said object relationship mapper. So the object structure that you have will be mapped to the database table structure. The advantages, obviously, it can significantly reduce development time, less code, better performance, and you can support different database management systems by adopting this. By mapping logical business model and physical storage model, ORM implements domain model pattern. It navigates the object relationship transparency. ORM provides one way to translate the query to appropriate database syntax. It also provides concurrency support where multiple users can access the database at the same time. It provides a host of services that enable developers to focus on business logic. It also provides cache management to reduce load on database. Surrogate key identifier and other key features can be automated in the ORM. So the Java application will connect to the ORM API, which facilitates create, update, delete operations. The ORM engine will facilitate the creation of the mapping information for the Java class that you create here to actual SQL statements meant for the database, and the JDBC driver will connect the Java application finally to the database. So it is the ORM that is doing the mapping to your objects that you write in the Java application to tables that are actually updated and created in the database. Let's look at Hibernate as an ORM framework from a architectural, feature, persistence, and API perspective. As an object relational mapping framework, Hibernate is concerned with data persistence as it applies to relational databases via JDBC. DBMS specific details and mapping file details are specified in a file called hibernate.configuration.xml and mappingfile.xml. The Hibernate engine uses these files to generate DBMS specific syntax. So the Java application will have all the configuration for your Hibernate written in the cfg.xml file. You can also have a mapping file if you want to map table names to column names in the XML file, and finally we connect to the database management system. Hibernate ORM provides its own native API in addition to full JPA, which is the Java Persistence API. It maps POJOs of Java objects to relational databases. It provides a rich tool set. It has better performance for caching, fetching, and enhancing code performance, and it is also part of the JBoss community. This is where we can go and download the latest version of Hibernate. The JPA provides a standard persistent API as part of EJB 3.0 specification. It is supported by all major vendors of Java industry. Hibernate model implements Java persistent object relationship API, and the Hibernate persistence provider can be used in any environment of Java platform, be it the standard or the enterprise edition. So here is the Hibernate programming model. You create the hibernate.cfg.configuration object. You load the metadata information. You then create a session factory object. You then make a Hibernate API call on a session object. You close the session and you close the session factory. So the Java application will create the persistence object. The entire Hibernate framework consists of the session factory, a session, a transaction factory, and a connection provider. And the internal API which is used by Hibernate is the JTA, the JDBC, and the JNDI. Let's look at each of these components of the architecture in detail. The session object is created within the database layer in every DAO method or data access object method. It is known as the persistence object. It has three lifecycle states: the transient state, where an object is transient if it has just been instantiated using the new operator and it is not associated with a Hibernate session. It is in a persistent state if it has a representation in the database and an identifier value. It might have been saved or loaded, however, it is by definition in the scope of the session. Detached is an object that has been persistent but its session has been closed. The reference to the object is still valid of close, and the detached instance might even be modified in this state. The Hibernate core APIs start with the configuration. Now you can see here the org.hibernate.cfg, which gives two services in the Hibernate application. It loads the mapping file and configuration file into memory and makes them available to Hibernate engine. It also acts as a factory to create the session factory. The session factory, which is part of org.hibernate.session factory. The Hibernate engine implements this session factory interface. It is one per DBMS, mostly one per application that you create. It is thread safe. It is not a singleton, which means it creates a session object. The session factory encapsulates second level cache, connection pool, meta information cache and pool of the session. The Hibernate interface also contains the session. The Hibernate engine implements the session interface. Session object acts as a persistent manager. It is a lightweight object. It encapsulates connection and first level cache. Session object is not thread safe. In every DAO method, session object is created. It is used for CRTD operations. The Hibernate engine also implements the transaction interface. When database connection is created by Hibernate, connection associated with session is in auto commit disable mode. Whenever a CRUD operation is performed, the changes will not be reflected in the database unless connection is maintained in auto commit enabled mode. All the generator classes implement the identifier generator interface. This application will help the programmer and may create own generator classes by implementing this interface. Hibernate framework provides many built-in generator classes. You have assigned. The default value has to be explicitly aligned to persistent object before you persist it. Increment, it increments value by 1. It generates short, int or long identifiers. Native, it uses identity, sequence or hello depending on the database vendor. Sequence, it uses the sequence of the database. If there is no sequence defined, it creates a sequence automatically. For example, in the case of an Oracle database, it creates a sequence named Hibernate_sequence. It is used in high and low algorithms to generate the ID of type short, int and long. Finally, the identity, it is used in Sybase, MySQL, SQL Server DB2 and SQL to support the ID column. The returned ID is of type short, int or long. So it auto generates the ID, which could be the primary key in your table. How do you set up a project with Hibernate? Step 1, you create a Java project. You add the required jars and libraries from the Hibernate downloads. You then add the JDBC driver or a specific jar file to connect to your respective data store. Create the Pojo class, save it in the src folder of your project. You then create the Hibernate configuration file, which is similar to the web XML file, and you specify which dialect of SQL are you using depending on the databases listed here, MySQL, DB2, Oracle. You then create the hpm.xml file, which is the mapping file, and finally you create the class that retrieves or stores the persistent object and saves it in the src folder, and then you go ahead and run the application. So first you download the latest version of Hibernate. You click on the right click on the project, click on build path, click on add external jars, and you add all the required Hibernate jars that you downloaded. Then you download the MySQL connector, assuming you're connecting to a MySQL database, or equivalently the driver for the Oracle database. You then create the Pojo class that needs to be persisted into the database in terms of its object. So here we have roll number and name. Then you create the Hibernate configuration XML file. Here you see the property mappings done. You see the connection URL to the database. You see the username, password. You see the driver name. You see the auto property set to create, which indicates every time you run the application, it will create the table. If the table exists, it will drop it and create a new table. And here is the mapping to the mapping file, which maps the column names to attributes that you have in the class. Step 5, you can actually see the mapping done. Name student, table, the ID and the name are being mapped. Then you create the configuration object by creating an object of standard service registry. You then call configure, you pass the XML config file. Then you create an object of metadata, call the build method, and finally an object of the session factory by calling the build method of the get session factory builder. You can use property names as create, update, create, drop to avoid creating the student table manually. So every time you have a change, and if you set it to update, automatically you will see that the record has been updated in the database without you having to manually write the SQL statement. And this is the SQL that will be generated in case you put the value as create here instead of update, which means the existing student table, if it is already there in the database, it will be dropped and a new student table will be created every time you execute the application. Let's talk about annotations in Hibernate. You have learned how Hibernate uses XML mapping file for the transformation of data from POJO to database tables and vice versa. Hibernate annotations is the newest way to define mappings without the use of XML file. You can use annotations in addition to or as a replacement of XML mapping metadata. So if you're using annotations, you do not need to create a separate XML mapper file which will map the values or the attributes inside your class to the fields in the database. So here you just need to specify @entity as an annotation on top of your class, @table as well, @ID if you're defining anything as a primary key, @column if you want to change the name of the column from a database perspective, and simply save this file and provide a mapping in the Hibernate CFG XML. That's all you need to do. So you save the effort of creating a separate XML file purely for doing a mapping of the class attributes to the column names in the database. So here you see we are creating a configuration.configure. Then we are configuring and loading that XML file and creating a metadata object and calling build on it, and finally instantiating the session factory. Let's talk about create, update, delete operations. The acronym CRUD stands for create, read, update and delete. There are 4 basic operations that any data-driven application performs, which is create, read, update, delete. Now Hibernate supports these operations by means of a session interface. Now multiple persistence objects cannot be retrieved, and this is the limitation of using session methods. Multiple delete and update operations are not possible in parallel. The required criteria cannot be expressed to perform some complex CRUD operations. To overcome the above limitations, we have HQL, which is Hibernate Query Language, the Criteria API, and Native SQL, which is Structured Query Language. What is HQL? It gives query language provided by Hibernate. It is the same as SQL, but it doesn't depend on the table of the database. It uses classes. The Criteria API is one way of querying the database in Hibernate application. It can be used for DBML operations. Criteria API is an object-oriented after native for HQL to read data from database, and it supports compile time checking for the query that we built, unlike HQL. Here is a create operation. We create a configuration object, a standard registry object. We then load the Hibernate configuration file. We then create a session factory, open a session object, begin a transaction, create a new student object, set the values as roll number and name, and save that into the session, call a commit on the transaction and close. This will create the table in the database and insert the first record inside it. If you need to read the data, this block of code until the session factory remains common. Then you again open the session, begin a transaction, get that particular student class object by passing the primary key and simply print the value. For an update operation, this remains constant. You then open the transaction. You then get that particular record of the student or the student object by passing the ID and simply do an update. For a delete, process remains the same. Get the student details, call delete on the session. Let's look at a demo on how to work with Hibernate. The first thing we will need is, of course, to install the Hibernate API. So the Hibernate software is available and you just need to go ahead and download it from the Hibernate website. You can Google for it and simply then go ahead and unzip it. Okay, so if I go to, this is the Hibernate folder that we've downloaded, and you just need to unzip it and you will actually see all the files and the jars inside it that are already there. So this is the file that we need, and you have a set of jars that we will actually need. So these are the set of jars that we will need to import inside our application. So once you install the Hibernate API, you then need to just go and download and install any database of your choice. In this demo, I have installed MySQL. The installation document for MySQL and Hibernate has been provided to you in the LMS, so you can access it and complete the installation of MySQL and Hibernate in case you need support on that. And Eclipse, of course, will be our editor. And besides that, we will download the MySQL Workbench. So the MySQL Workbench installation document is also been provided, so you can go ahead and download it. And once you download the MySQL Workbench, you will see that the installation or the instance of MySQL is available to you. You just need to click on that. It says opening in the editor. Just ignore this, and that's about it. Okay, so that's all we need to do to connect to the MySQL instance. And once you get the MySQL Workbench installation done and the SQL Server and the MySQL installation done, you simply start writing your SQL commands out here, which will start generating your database names. And then we will go ahead with configuring our Eclipse application to create a simple Java Pojo class, which will, via annotations, as we saw, we will map it to the particular database that we create here. Let's start with creating the new database. So we'll say create database, and let's say Hibernate demo. We'll execute this, and you can see the database has got successfully created. Let's come to our Eclipse now. Here we'll create a new project. We'll select Java project, the name Hibernate demo. Say new project, Java project, Java project, next, here Hibernate demo, next. We'll click on libraries, add external jars, and we will add our JDBC driver. So let's go to This is the Hibernate folder. So I'm moving to the Hibernate folder first. We'll go to our lib folder, and inside that required, and we will select all the files and open and say finish. Okay, so it would have added all the references, as you can see here. So the libraries, the correct references have been added. Now we'll need to also add the MySQL driver. So let's go to the web, open Firefox, and we'll just Google. Okay, and here let's say we want the MySQL Java connector or driver. That should take us to the MySQL website. Okay, and here you see the driver available. We'll pick the zip file, so we'll say download, start download. Okay, and it has downloaded the driver, so I'm just going to pick it up and put it into my folder that says jars, and we'll just extract it here. Okay, now the moment that is done, we'll come to our Eclipse. We'll again go to build path and configure, add external jars, go back, let me go to my jars folder, and okay, doesn't figure out, so let me check again. It is in this folder, so we'll go and go to the build path, configure, add external jars, give the path here, and pick up the MySQL connector, apply, apply and close. So that has been added. Now let's create a new package for our Pojo class, and we'll say com dot transfer object. We'll create a new class within it, and let's name it player, for example. Finish. Let me add data members. Start with a player ID. Let's add player name. Let's add team name. Let's add age. Okay, that's my constructor. Get rid of this. Let's add from the source the getters and setters. We'll also generate a toString. toString method, and save this. And let's also go to the source and generate a parameterized constructor. Now time to add the annotations for entity framework. So we'll say @entity. We'll pick it from the Java x.persistence.entity package. Then the player class is going to be a table. So we'll add @table as another annotation. And we want the player ID to be a primary key. So we will add @ID above the player ID. Now let's browse to the Hibernate folder, and within it we will search for hibernate.cfg.xml, and you will see that there are a couple of CFG XML files that come up, and these are the ready-made configuration files that are there in the folder. So we could just pick one and use it. So I've just picked a file from that location. Okay, and I'm just going to use it. So I'm just copy pasted a CFG file after searching for it randomly. So I'm just selecting that, coming to Eclipse again, clicking on the src and just pasting. So here's the file that we pasted. So if you go to the file, the first thing that we have is a database connection setting where we provide the driver name, the URL, etc. Then next we have the connection pool setting to set the pool size. We have the SQL dialect depending on which database you're connecting to. We have the cache if you want to turn it on or off. This is the line that will spit out the SQL that Hibernate framework will automatically be creating for us. This will allow us to drop and create the table. It will create the table at the first run, and on every subsequent run it will modify and recreate the table. So it will drop the table and recreate it. Now you see a mapping class here. Here we will map it to com.to.player. Okay, so that's the change we have made. Then let's come to class, and this will be com.mysql.jdbc.driver. Let's come to the connection string jdbc:/mysql. Since we are connecting to a MySQL database, localhost, the port number for MySQL by default is 3306, and the table name we created, or the database name we created, was Hibernate demo. The username on installation I had provided as root, and the password was also root, so we'll save that. Next, the SQL dialect, we will give it as MySQL 5 dialect. We'll add one more value, name equal to current underscore session underscore context underscore class, and we'll set this to thread so that every session runs in a separate thread and it's thread safe. So we are pretty much done with the configuration of I'll just validate the, so this is Hibernate demo, and that's exactly the same thing that we will provide here. Now time to add a new package, so let's do that. com dot control we'll add a new class and call it Hibernate main. Add a public static void main to this class, have it ready, so that's going to be our entry point. First thing, we'll create the configuration So we have created the configuration first. Configuration equal to new equal to new configuration dot configure just get rid of this. Let's get this from Hibernate package, and then we will say configuration dot add annotated class, and our class name will be com.to dot player dot class. Then next we create standard service registry builder equal to new standard service registry builder dot apply settings and configuration dot get properties. We'll put this onto the next line. So this will go ahead and get us all the configuration that is available inside our configuration class that we specified. So the first step, we are creating an object of the configuration class. The second step, we are going ahead and creating an object of standard service registry builder. We are also adding our class that had annotations with it, and that class with the annotations is nothing but the player class. So this line of code will actually allow us to apply the settings of the configuration file that we have set up. Post that, we will create a session factory object equal to configuration dot build session factory, and we will pass the builder dot build method. Next, we start creating the session equal to factory dot open session. Let's add the Hibernate namespace for session. Then we create a transaction equal to session dot begin transaction. Then we create a player object equal to new player, and we pass some values. We import com.to and also the transaction package should be the Hibernate equivalent, so we'll get that one. We also need to give a fourth parameter here, which is the team name, so we'll specify that. Then we use the session object to save the player object. Post that, we say transaction dot commit so that it persists the transaction, and then we do a session dot close. Okay, so here we are setting up the configuration. We are then adding the annotated class, which is player. We are creating the builder object, loading all the configuration properties from the XML file we created, setting up the session factory, passing the builder to it, which is the configuration information. We are then opening a session, opening a transaction, creating a new record in terms of the object, and hence it's called object relationship mapper, because we just create a new object, use the session to save it, and commit the transaction, and it will automatically create a table with the right name and insert that record into the database. Okay, so now all we need to do is attempt to execute it. So we'll just check the SQL connector is referenced. We'll go to our Hibernate config file and we'll just validate. So we had set the dialect and it is trying to reach the load the class, which is the information class, or rather the driver. So com.mysql.jdbc.driver. So let's run a check on that. Save this. Let's change this and use MySQL dialect. Oops. Let's come back to the Hibernate. Okay. Executed the incorrect file, so let's run it again. We delete the additional file that got created, come back to the Hibernate file, attempt to run that, save all. So the update that we did to the code, firstly, we have just changed the driver alphabet D to uppercase, which is system defined and case specific. And the next change that we will have to do is we'll have to add the entire namespace to the SQL dialect class. So we will say org dot Hibernate. So this is the package name dot dialect LECT dot MySQL 5 dialect. So we've said org dot Hibernate dot dialect dot MySQL dialect. Okay, and MySQL 5 is the updated version of the SQL dialect class that will automatically convert and write the SQL statements to insert the data into the database, and also create the updated table for me. Right, so these are the two changes that we have done, and the code here continues to remain the same. We have a player object that we are trying to store into the database. So we'll execute this and let's look at the output, whether it okay. So you can see here now, because in the config file we had actually given this configuration which says show SQL true. It has actually generated the SQL statements in the background. So it says drop table if player exists, and that was because we gave the auto mode here to create. Then it creates the new table and you see the SQL that is returned, automatically written for us based on the structure or the attributes in the class, and then it has attempted to insert a new record of type player into the database. Okay, but has it actually happened and updated in the database? So we'll go to our SQL. Okay, here we will just validate whether the update has really happened. Has it created a table out here, and are we able to retrieve the data? So we'll say select star from hibernate demo dot player. Okay, and you see the data that we actually inserted has come up inside the database. Let's try with an additional record. Save this, come here, and let us add another player change the age value, and we will also so we've created a new player P2 and we are saving it into the database. And you see after we've executed, it drops the table, creates the new table, and it inserts the data into the table. Okay. What I've also done is I've just introduced a try catch block, so in case there are any errors where we have gone wrong, it would return the error messages to us, right? Else it's the code continues to remain the same with just the new record. So let's check in the database now. We'll execute this, and here you see the second record that we just inserted is available in the database. Now let's go back here. Let's comment the second record and the save statement as well. And let's modify the value of the first record from Amit to Virat. Now when we execute this, let's see what happens. So you see it's dropped the table, created the table again, and then inserted our individual player record. So if we go to the database, you can see that it's now the updated value, but it has recreated the entire table, and hence the second record is gone. Let's now, if we need to preserve the records and just do an update to an individual record without updating the entire table, let's change this flag from create to update and save this. And now when we come back here, we will uncomment the second record and comment the first one since it's already there. So we'll comment this and uncomment the second player and execute. It's now generated a single insert command. Let's check in the database what has happened. So we had one record. You can see now it did not drop the table, it just updated it with the second record. Let's check what is that we'll need to do if we want to retrieve a record. So to retrieve a record, let's say player P equal to, we'll use the session object dot get player dot class. We want a object of type player returned to us, and let's say we want the first record, so we'll give the key as 10, and we'll simply print the details plus P. So we have a toString that we have overridden in the class, so that should do the job for us. Let's execute this, and there you see the player details are returned for the first player. Now let's say I want to write some code to probably update those player details. So we can say player dot set player name and change it to another player, and we'll say p dot set age So we've set the name and the age. Let's execute this. And it says update player. So you see the statement, update statement being generated here. Let's check in the database. The current value is Virat for player ID 10. Let's update, and you can see it has changed moment I refresh. What if you want to delete a record? We said it's used for create, read, update, delete. We have done create, read, update. Let's try the delete. So here we'll simply use the session object dot delete, and we will pass p1, or rather p, which is the object that we have just retrieved. Now when we run this, delete from player, where player ID is this, and you can see when I come here, let's refresh the table, and you can see the first record has got deleted. Now similarly, we have multiple annotations available. So let's assume that we want to auto increment the player ID every time a new player record is generated. So for that, we'll say source, we'll create a constructor with just player name, team name and age. So we've created a parameterized constructor. We do not need the ID to be passed. We want to auto generate it, and we'll say generated value strategy equal to, we'll use the enumeration generation type dot identity. Now this will auto generate the ID every time we try to insert a record. So let's come here and we will comment the delete code. Let's now add code to try and insert a record. So we'll add two player objects, P1 and P2. Give it 70 and we don't need these values now, so we'll get rid of it. So we just need the names. So we've just given the names there, and we'll say session.save P1 and session.save P2. Now we'll go back to here and we will say create, since we are recreating the table, since we have changed the column configuration, and we'll come to our Java code and execute it. Let's go now and refresh, and you can see the player ID 1 and 2 was auto incremented with and generated with the new values that we just added. Okay. Similarly, if we want, we can also update the column name. So let's say that for player name we want to provide a different name for the column in the database. So we will say column name equal to name. And let's say we want a different name for the table as well. So here we'll say name equal to player underscore table. So we've changed the table name from the database perspective that we want created. And for the column, if you want to put a constraint where you do not want null values to be stored, you can say nullable equal to false. Now let's come back, save the application and execute. Let's come here and select from, instead of saying player, we'll say player underscore table, which is the new table, and you see the new table got generated, and you see the name, actually the player name was converted to name, and that is the setting that we had provided. So this shows us how to create, insert, read and update data using the ORM Hibernate, and how easy it is to provide annotations in the object class and automatically map the entity model to the database, create the table and insert records. So we learned that Hibernate converts database specific queries automatically based on dialect provided. It uses Hibernate query language, which is independent of database. As an ORM, it is concerned with data persistence as it applies to relational databases via JDBC. The Hibernate annotations is the newest way to define mappings without the use of XML file. You can use annotations in addition to or as a replacement to XML, and Hibernate supports root operations by means of session interface. That's what we saw. Thanks for watching. We'll see you in the next session. Welcome to the session on Hibernate queries and relationships. Here we'll discuss HQL, we'll discuss native SQL query and criteria query, caching and transaction management. Let's start with understanding what is HQL. So here we see a simple example where we have a student class. The student class is registered in the cfg.xml. We are trying to retrieve student records from the student table. So we open a session, we begin a transaction, we create a person object as we saw in our demo, and we get the particular student by passing the student ID. To retrieve the student data, we provide primary key value for the student. If one table doesn't have a primary key, the records cannot be retrieved. Hibernate provides its own language known as HQL to solve such problems. The syntax is quite similar to database SQL language. HQL is used to communicate with the database. It is a Hibernate language for relational database management systems. HQL statements are used to perform tasks such as updating data on a database or retrieving data from a database. So we send HQL queries to a database and we retrieve data. If you look at a comparison between HQL and SQL, it is related to Hibernate. Here it is database specific. HQL queries are object queries. These are queries that you fire on tables. Example is a class student, and here we say where student is one class name. So the HQL query will be from student where student is one class name. So here we have a student table, and here we would say select star from student where student is one table name. HQL is object oriented. It works on objects of classes. It understands notions like inheritance, polymorphism and association. Its queries are case sensitive, unlike queries in Java classes. Using HQL, we can create a required CRUD operations like update, delete and select. However, using HQL, we can move data to another table, but we cannot insert data using HQL. So we create the configuration object by calling configure and passing the cfg.xml file. Then we create the session factory as we've been doing in our Hibernate demos. We open the session and we create a query, and this is where we will write our HQL query. The methods of the query interface, we have a get return type which returns the Hibernate type of the query result set, iterate which returns the query results as an iterator, and list which returns the query results as a list. This is the most common way of using named parameters followed by a parameter name with a colon to define a named parameter. Suppose we have a stock table with stock column. We are going to say from S where S.stock code equal to, and this is a placeholder prefixed with a colon. Later on, we set the parameter stock code with a certain number and then fire the query. Then we have a set string which informs Hibernate that the parameter data type is string. So here if we say placeholder where stock code equal to this, then we pass the stock code like this. Set properties can be used to pass an object to the parameter binding. Hibernate will automatically check the object's properties and match them with the colon parameter. So we create a stock code where stock code equal to colon stock code, and then we say set properties stock. Here we have the HQL syntax: from clause, alias, aggregate function, where, expressions, order by clause, and association. We start with the from clause. The from package name dot class name returns all instances of the class. So suppose we have a student table with roll number. We say from student query equal to session dot create query HQL, and then we fire the query with a query dot list to fetch the data. Aliasing, you can assign an alias that is different name to the class. Suppose the alias name is ALS. The syntax can be from class name as ALS. So ALS acts as a placeholder that stands for the typical class name. Then we have the aggregate functions, which will give us the average, sum, min, max, count, count distinct, count of all, and we can use arithmetic operators and concatenation to add the result value to a string. Then we have a where clause like your SQL statement. From class name where column name equal to Ram. From class name where alias.column name equal to Ram, in case you are using a alias name. Then we have an expression where we can use mathematical, comparison, logical, parenthesis for grouping, not null in between operators, case, when, then, else, concatenation or concat, current date, time, timestamp, second, minute, hour or date, and so on and so forth. So these are the set of functions that are available: upper, length, lower, etc. So whole lot of functions that we will actually go ahead and explore and look at some of them in the demos that we do. Then we have an order by clause, which will do a sorting in a ascending or a descending manner. So we say from employee E order by E dot salary in the descending manner. We've got association and joins very similar to SQL. We have an inner join, left outer join, right outer join, and full join. The inner join, left outer join, and right outer join constructs may be abbreviated. You can supply extra join conditions using the HQL with keyword. So let's look at a demo on programs on HQL. We'll go back to our Eclipse. Again, we use the same Hibernate demo example, but rather than creating a table each time we execute our query, we will change this so we can just update the data in the table. Let's start writing the code for HQL. So here we say query equal to session dot create query and from the player table is where we want to get data. Now I have entered some records into the table. So here in the player table there are 11 records that have been created that we are going to use. Now we will say list of player list equal to query dot list. So we'll import let's get the list from java.util and the query from org.hibernate, and let me sys out player details, and we'll write a for loop for player P in player list, and we'll sys out the player object. let's make this player with a P capital, since our class name also is a P capital. And here you see the player information getting retrieved with the HQL query from the database. So the player information got retrieved when we executed this from the database. Now let's try some alternate HQL expression. We'll add a where clause here. So we'll say where player name equal to name, colon name. So colon name is a placeholder, and now we'll have to give the value for that. So we will have to say query dot set string name, and for the name parameter, let's say we give some cricketer's name. So let's say we say MS Dhoni. So this is the same as saying select from player where player name equal to MS Dhoni. Okay, and here you see that record has got returned. Now if we want to say instead of player name where team name, and in this case my team name will be India. So that's the data that we want. Let us execute this. And here you see all the records where the team name is India. Now let's say we want the data where the age is equal to colon age as a placeholder, and we order by player name. We'll have to specify the age here, which we did not. So let's say the age is 35, and this is an integer value, so we'll have to change this to set integer, and we'll execute this, and there you see the records where the player name is ordered by player name and age is 35, and now we will give descending so that it sorts in the descending order. And let's execute this, and here you see Yuvraj Singh comes on the top and MS Dhoni comes below. Now we can also say where age is between age 1 and age 2, and order by player name descending. So here age 1 will be 35, and for the second parameter, so these are named parameter queries or parameterized queries where we are providing two values at runtime, which you can also accept from the user. So here it would give us data that is specific to ages between 35 and 40. Let's save this. Age 2, I didn't give a colon there. We'll execute. So here you see the data where age is between 35 and 40. So this is how you can write simple HQL queries as if they were SQL queries. Let's look at native SQL queries. Now in native SQL query, which you can also write using this API, the create SQL query method is used to create a native SQL query for the session. You can create SQL including stored procedures for all create, update, delete operations using Hibernate 3x, and the result can be added to the Hibernate entity. So how do we write a SQL query? we create a session, and here you write your native SQL query. So consider a table with the following data, and let's say we have a class that maps to the attributes in the table. Now here again we begin a transaction. We write native SQL, select star from person, we create the SQL query, we add the entity class which is person.class, we fire query.list, we then iterate over the data and we print first name and last name, and of course the catch block, finally block, and here we commit the transaction. Let's look at criteria queries. Criteria queries allow you to apply filtration rules and logical condition with the query. The org.hibernate.criteria query is a method provided by Criteria API that helps in creating criteria query programmatically. The criteria package may be used by applications as a framework for building new kinds of criteria. However, it is intended that most applications will simply use the built-in criteria types via the static factory methods of restriction class. So here we have an EQ method we can use, which applies to equal, GT for greater than, any property for not equal to, like for like constraint, and between for the between operator. Let's look at an example with a table that has roll number, name, age and marks, and an appropriate class mapped to the attribute structure. So here we create a query without restrictions by adding a reference to student class. Here is a query with restrictions, criteria equal to s.create criteria, and the restriction is greater than age 23. This will show a list of students where age is greater than 23. Let's look at caching in Hibernate. Cache is an important component that stores data temporarily, so future requests for that data can be served faster, and hence this is a mechanism to improve performance. Cache is a temporary storage area. It is a process to store data in the cache, and caching in Hibernate avoids database hits and increases the performance of critical applications. So the Java application will try and connect with the Hibernate API, where you can have different levels of cache. You can have your first level cache, you can store data in the session object, or you also have a second level cache where the data in the database can be pulled and stored at these three levels of caching to improve the performance of the application. Let's talk about the first level cache. All caches must pass to the first level cache. When you close the session object, all objects being cached are lost and persist or updated in the database. Then we have the second level cache. Now this is an optional cache. It uses a common cache for all the session objects of a session factory. Example, JBoss cache as a Hibernate second level cache. It is tree structured, clustered, and it's a transactional cache. Let's talk about mapping relationships with Hibernate. Hibernate mapping is used for the following: to map inheritance hierarchy classes with the tables of a database, to meet the need of mapping collection elements of persistence class in Hibernate, to map dependent objects as a component, and Hibernate mapping is used to map Java data type to SQL data type and vice versa. Hibernate uses Hibernate type, which is different from Java data type and SQL data type. So value type has the following types. We have a basic value type, where Hibernate provides a number of basic inbuilt types. Composite types, where components represent aggregation of values into single Java type. And collection type, to map collections. Hibernate provides the collection type. Then we have the entity type. Entities are classes that correlate with row in table. And we have the custom type, where Hibernate allows you to create your own value type. In terms of the mapping, we have inheritance, association, collection, and component mapping. The Java inheritance relationship is pretty simple. So you have a base class, you have a child class that extends the base class. We can map the inheritance hierarchy with the table of the database using the inheritance mapping. There are three types of inheritance mapping: single table, per class hierarchy strategy, using the subclass element, table per class using the union class element, and joint subclass strategy using the joint subclass element. It is also known as table per class or single table per class. That is the first strategy. To distinguish cases, it uses discriminator column. Let's take an example. So here I have a person class with a discriminator column and a discriminator value, and then we have the person class with the ID primary key. We have an employee class with a value of E, and again it has department name, joining name, and this goes and extends the person class, so that is the inheritance relationship, the single table per class strategy. Now if you want to create an object, you create an object of the person, initialize the values, then you create an object of employee, initialize the data, and use the session object to save the person information and also the employee information. So here you see the discriminator ID, the P and the E. So the first name, last name, department, and joining information that is stored across both the records. Right, so here you see the discriminator P indicating it is of type person. Here you see the discriminator E indicating it is of type employee. So that is the how you will define whether it's the base class object that is being persisted or the child class object. So columns declared by the subclasses may not have not null constraints. Like in this case, I may not have a department name and joining date, because if you look here, the department name and joining date were only for the child class. They were not parameters which were there in the parent class, and hence when I store the parent class object, those two values obviously will be null. Table per class contains 3 tables in the database that are not related to each other. There are 2 ways to map the table with this strategy: by union, by self creating the table. So here we see the inheritance strategy as table per class. Class flight implements serializable. Each subtype has a column for all properties including inherited properties. Column name is the same in all subtables, and primary key seed is shared in all subtables. It is all known as one table per subclass. This is the joint subclass strategy. It uses n number of tables, where n is total number of classes including sub and super. It uses one-to-one association. All subtables use primary key association with super table, and the primary key join column and primary key join columns annotation define the primary keys of the joint subclass table. So here we see the primary key column and primary key join columns annotation to define the primary keys. So here we have a person class with an integer ID, first name, last name. We have an employee class with a person ID, date and character, and a owner class also with a integer ID, stocks and department name. So this is your joint subclass strategy. So here we see the inheritance strategy as joint. You see the person class with a ID auto-generated value and columns like person ID, first name. Then you see the employee class, and here you see the primary key join column is the person ID. So this will allow you to create a relationship between the base class and the extended employee class. Then we have the class owner, which further goes and extends the person class. Here again you see the primary key join column continues to be the person ID, so that you can have a relationship between both the values. This is the database representation of what we created in terms of OOPS implementation. So we created objects and classes. Now here you see the person table with a person ID. You see the employee table with a relationship based key. So you actually have the primary key and the foreign key associated here. And here as well in the owner table, you see the person ID, that is the relationship value that allows you to associate the person value with the owner and the employee table. Then we come to the association mapping, which is a mapping relationship between two objects in Java. So car with a model number and owner information, and customer with address, contact number and name information. The options here are, we have a one-to-one association, one-to-many, many-to-one or many-to-many. A one-to-one relationship occurs when one entity is exactly related to one occurrence in each other. Example, one person has one passport. So one person is associated with one passport and one passport belongs to one person. Here the person and passport class have a one-to-one relationship. So you see the person class with the ID and you see the passport class with the ID. The annotation used to generate one-to-one mapping between person and passport will be one-to-one. So here you see the one-to-one annotation. Hibernate creates one column in person table that corresponds to passport table ID column. When member variable is sent to person, set passport member of person class can be avoided. So here we create an object of person, we create an object of passport, set values and save them in the session. So you see the table equivalent or representation of the class objects we created, person and passport. If foreign key is added, annotation used should be @join column, name equal to the name of the foreign key relationship, which could be passport_FK standing for foreign key. Second scenario is one-to-many. We consider where one employee has multiple phone numbers and one phone number belongs to one employee. So the employee class has a mapping of one employee having multiple phones, which is a one-to-many. Here you see the person class and the phone class. You see the employee class with the one-to-many annotation. And here you see the phone class where again the phone ID is the primary key and here the employee ID is the primary key. Add user defined name using the following annotation: join table, name user vehicle, join column, name is user ID. Inverse join columns can be equal to @join column vehicle ID. Here is how you will pass the data. So we first create the phone object, add values, the person object rather. Then we create the phone object and add values. Okay. Then we get the phone information if we want by passing the user object. So if we say user.getPhone.add, so what we have done is we have retrieved a particular phone object and added it, associated it with a user. Then we create a second phone and again we are associating that second phone with the user object. So one user has two phone objects associated with it, P1 and P2, and finally we save the user object and we save the phone object. So this is how it will look like. The person table having John and Stella, the phone table with two phones, and the person table saying John has two phones, 101 and 102 associated with him. Let's consider the same scenario for many-to-one. So many phone numbers can belong to one person. Okay, so I can have one person having more than one phone number, which could be a many-to-one. So here we have a person class, a phone class. We have a person class here with a ID created, and if you look at the phone class, it has a many-to-one annotation indicating many phones can be associated with, phone numbers can be associated with one person. So here we create the user object of person, we create the phone, set the phone number, and we associate that user with that phone number. Create the second phone number, associate the same user with the second phone number. We then save the user and save the phone numbers. So here I have the person table, here I have the phone numbers table, and we can associate multiple phone numbers with the same person. A many-to-many association finally is defined logically using @many-to-many annotation. You can have to describe the association table and the join conditions using the @join table annotation. So here you see there is an employee class. So employee can have multiple meetings, okay, and a meeting can have also multiple employees associated with it. So one employee has multiple meetings. Multiple meetings can be attended by multiple employees. So it is many to many. And hence, to resolve that, you generally have a one more table in between which has the employee ID and the meeting ID, which allows you to manage the ambiguity effectively. So Hibernate allows you to map collection elements of persistent class. It can be done by declaring the type of collections in persistent class from one of the following types. You have java.util_list, util set, sorted list, map, collection, and so on. So components refer to the object-oriented notation. For example, student class has one class member, name. Name is also one class that has two members, first name and last name. So we see the person class with the ID, a many-to-many tag here as an annotation, and a collection of meeting. The reason we'll have to have a collection here as an array list, because multiple persons can have multiple meetings associated with them. And here as well, you again see a many-to-one, indicating that you will have multiple persons that can be associated with a particular meeting. So here you see a collection of persons, you see a collection of meetings, and that is the component mapping that you can have at the collection level as well. So here you see the person object getting created first, then the first meeting object, and the meeting object has a user assigned to it. You then see a phone object getting created, and a phone object also has a user associated with it. Finally, we save the person with the meeting. So we are also associating persons along with the user object and the meeting object. And then we are saving user and meeting information. So we have the person table with John and Stella. We have the phone table indicating that this phone number belongs to John. This also belongs to John. ID is 1, which is a match. We then have the meeting person table saying that there is a meeting ID 101, okay, which is associated with a person 1. So this person is attending both the meetings, and this person actually has both these phone numbers in the phone number table. So in component mapping, the dependent object is mapped as a component. A component is an object that is stored as a value rather than entity reference. This is mainly used if the dependent object doesn't have primary key. It is used in case of composition or has a relation. That is why it is termed component. Let's move to a demo on understanding HQL or Hibernate query language and relationship between objects. How do you do the mapping so that the appropriate tables can be set up in your database and you can have the relationship setups between the tables. So let's start with a demo looking at how are we going to map relationships between our tables, or rather between our entity classes. And the moment we set relationships between our classes and class objects, we will be able to map that to tables in the database. So let's go to our Eclipse code, and within the com.to package we'll add a new class. We'll name that class as theme. We'll add two variables called team ID and a string team name. We'll add a constructor and we will also add our getters and setters. And save this. On top of the team ID, let's create this as the primary key, and we'll add a generated value of strategy equal to generation type dot identity. Now we will also define this as entity and the table with the table annotation. We'll add the required packages. Now let's go into the player class, and here we have team name. So we will create this as an object of team, so we can have a relationship between player and team. We'll comment the get team name. We'll modify this to print the team, and we will call this team details. We'll modify the constructor so that it returns an object or accepts an object of time team, and here we will say this dot team equal to team. We'll go to the other constructor as well and repeat the same process and accept team here as type T. Now let's source the setters and the getters for the team. We'll also generate a constructor let's do that in the team class. So we'll generate a constructor which will only keep the team name since the ID is auto generated. And for doing a mapping in the player class, on top of the declaration of the team type, we will say one-to-one relationship. Indicating that one player can be associated with one team. We'll come to the configuration file, and here we have to add a mapping for that new class which is com.team. Then let's come to the main code. Here we will add the annotated class which is team, and here let's say team T1 equal to new team India, player P1 equal to new player Virat Kohli belonging to team T1 with the age. Session.save T1, session.save P1. Okay, let us look at the team class and we will check we need to add the constructor. We had added it, but probably Oh, it's already there, so need to save it, come back here. Yeah, now it accepts it. And let's run a check whether this status is create. Switch it so that it's going to create the new tables. And let's check now whether, so we've created a team object, we've then created a session, we've then created a player, and saved both the team and the player. So you can see the foreign key actually got created and the data got inserted, but let's check whether it actually worked for us. So we will go to the team first. So it has generated the team, as you see, with a team ID. Then we need to check for player. So we will check for player, and you see the player has a team ID associated with it. So this shows us how to go ahead and create a relationship. Now if we want to go ahead and create multiple players, we'll just paste this twice. We'll create another player called R Jadeja and a third player called MS Dhoni. All of them will be associated with the same team. And then we simply go ahead and save the players P2 and P3. So we do a P2 save and a P3 save and save this. And execute. And we check in the database. 3 players, each of them associated with the same team ID. So one player is playing for a particular team. Now what we want to do is we will try one-to-many, where one player playing for more than one team. So to do that type of a mapping, we'll go to the player class, we'll comment the relationship and this. We will now add a list of type team, since a player can be associated with more than one team object, and we'll call it team list equal to new array list, and we will import the java.util package. We'll go to the source and we will generate getters and setters for the team list. That's the new list that we added. Now we have a constructor that is taking 4 parameters. We will comment that. We'll also comment the get team, getter and setter, and we also comment this constructor and we modify toString to print team list. Then we go and we update the relationship, which will not be now one-to-one, but will actually be one-to-many. And we'll import the package. Now we'll go to the main class. We created a team. Let's create multiple teams. We create a player p dot set age and p dot set name. Then p dot get team list dot add t1. So we add this player to the team called t1. We'll change this to t2 and t3, and we'll add the same player to t2 and t3. And then let's save t1 and we will save t2, t3, and finally the player object p. So here you see the player team gets created, the player table gets created, the team player gets created, and the team list gets associated. Let's go and validate. Let's try to print the team information, and you see that the teams have got successfully saved. Now let's try to print a new table called player underscore team, which has got created, and here you see the player is associated with 3 different teams, indicating the one-to-many relationship. So here we saw in this demo how do we set up mapping. We'll now move on to the next concept, which is transaction management. A transaction represents a unit of work where if one step fails, the whole transaction will fail. For example, if we are having a loan processing application, when the user starts the loan processing application, everything in the step should go well in terms of accepting his Aadhaar card or accepting the PAN card, accepting proof, technical details, credit rating check. So all of those details should go successful for the loan to get dispersed or approved. If anything is incorrect in between, we want a rollback where all of the entries are either deleted from the database, or they are moved into a log table, or they are moved into a table which says unapproved loans, something like that. So it is described by asset properties, which is atomicity, consistency, isolation, and durability. So the initial state of the transaction is either could be in a committed state where it is successful, or you can roll it back if it is failed. So in Hibernate, we have transaction interface that defines a unit of work. A transaction is associated with a session and initiated by calling session.begin transaction, as we were doing in our code. Begin starts a transaction, commit ends the unit of work, and rollback forces the transaction to roll back. We have a set timeout which sets a transaction timeout for any transaction started by a subsequent call to begin on this instance. We have a isAlive to check if the transaction is alive. We have a register synchronizations which registers a user synchronization callback for this transaction. We have a was committed which checks if the transaction was committed successfully, and a was rolled back which checks if the transaction was rolled back successfully. So the key takeaways from this session is Hibernate provides its own language known as HQL. The syntax is similar to SQL. HQL is a Hibernate language for relational database management systems. HQL statements are used to perform tasks such as updating data on a database or retrieving data from a database. The criterion package may be used for applications as a framework for building new kinds of criterion. Hibernate provides the option to execute native SQL queries through the use of SQL query object, and a criteria query allows you to apply filtration rules and logical conditions with queries. org.hibernate.criteria query is a method provided by the criteria API that helps in creating criteria queries programmatically. We'll see you in the next session. So let's start with an introduction to Spring as part of the Java Enterprise Edition. We'll discuss Spring and its architecture. We'll describe IOC and DI, which is inversion of control and dependency injection, which are two design patterns. We'll understand the Spring Bean lifecycle, and we will explain bean wiring and bean scope. Let's start with Spring basics. So here is a typical multi-tier architecture for setting up a Java Enterprise Edition app. We have the client, which could be a browser or a mobile based app, the server, which will have the web content, the application layer, and the presentation layer. So this would have the business logic, this would have the UI. The business layer could be an app server which could host multiple Java beans or reusable components that could be accessible from different clients. The data access layer would have the DAO object that would communicate further with the data layer or the entity layer. So Java EE specifications don't help in understanding the implementation of the specification and the environment. The components in the architecture are written in a way that only the container can understand or handle them. Spring Framework is a framework that helps simplify Java EE architecture by reducing complexity involved in enterprise application development by using Java EE technologies directly. It gives an abstract layer for all the layers involved in Java enterprise architecture. So here you see a database provider and utilizer. This class is utilizing an Oracle connection, and this class is utilizing a MySQL connection. We modify the utilizer class according to the service we want to use. Now we observe that the utilizer class is tightly coupled to a particular provider, be it Oracle or MySQL. This implies that we need to modify our code every time we need a new provider. Due to this, it is always advisable to write different classes for utilizer logic and provider logic. So here you see we have our two classes that connect to Oracle and that connect to MySQL. You have a separate utilizer class which calls a particular method, which is either get Oracle connection provider or get SQL connection provider. Now this would involve calling two different methods from two different classes, which means I would have to recompile the connection utilizer class every time we need to change the data store or the provider. It is hence advisable to have a contract between service provider and utilizer to avoid calling two different methods name. In Java, we can provide contract with implementing interfaces. So now here you see the contract with a method called getConnection. You see the implementation of getConnection, the same method name in both the classes, managing or providing SQL and Oracle connectivity. And now here I simply call the getConnection method via the contract whether I need a Oracle or I need a specific MySQL connector. To change the provider class, obviously the application would need to be recompiled. To do so, it is advisable to either use properties file or XML file. You can write one container that reads the requirement and provides the required objects dynamically. So you can have a properties file that defines the provider class, whether the contract is going to implement this provider or get this provider. Next, you create a myProperties.properties file to mention the provider name. Suppose our provider is Oracle connection provider, it should be written as provider equal to Oracle connection provider. Now let's create a myContainer class to fetch the properties from the properties file. So here we create a new properties object, we load the properties file, we create a getBean static method which provides the key and gets that respective class name, and we pass that class name and generate a new instance of that specific class. Next, we write the utilizer code to create the object of the myContainer class. So here we say equal to new myContainer. We create the contract reference. We pass the provider that we are looking for, which is the key, and it will give us the specific connection object. If you want to change the provider class, just change the properties files. It creates loose coupling between the provider and the service object. Spring provides the container and Spring configuration XML file to configure the required provider classes instead of the properties file, and this can make the process even more easier and simplified. Spring was invented by Rod Johnson. The latest version of Spring is 4.0. It can be downloaded from here, and the common loggings can be downloaded from here. Spring Framework is a Java platform that provides comprehensive infrastructure support for developing Java apps. Spring handles the infrastructure to ensure focus on your application. It is open source, lightweight, developed in Java, eliminates common source code, and is from the Spring open source community. In Spring 3.0, it did not give us comprehensive support for JDK 8. It supported, or it provided, Spring MVC test framework and no support for datetime. In 4.0, it provides support for several Java 8 features. It introduces several new features for use in unit and integration testing, and it provides datetime value types for Spring data binding and formatting. The features of Spring: it supports multi-transaction environments such as JTA, Hibernate, and JDBC. It encourages good object-oriented design practices. It provides IOC DI container. It supports annotation and is faster than XML descriptor, and Spring also supports plain old Java objects. Let's go to the Spring architecture. We have the Spring Framework runtime, the data access integration component, the web or the MVC remoting component, the core container, and the test capability. Let's talk about the data access integration layer. The JDBC connectivity provides a JDBC abstraction layer that removes the need for traditional JDBC coding. ORM provides integration layer for popular object relational mapping APIs. OXM provides an abstraction layer that supports object XML mapping implementation. Spring provides Java messaging service integration to simplify the use of JMS API, and Spring Framework provides an abstract layer on top of different underlying transaction management APIs in transaction layer of Spring. Then we come to the web layer. The web module provides basic web-oriented integration features. Web Servlet, the Web Servlet module contains Spring Model View Controller implementation. Web Portlet modules, the Web Portlet module provides the MVC implementation to be used in a portlet environment and mirrors the functionality of Web Servlet Portal module. And Web Struts, the Web Struts module contains the support classes for integrating a classic struts web tier within a Spring application. Then we come to the core container, which is one of the other components in the Spring architecture. It consists of beans. It provides the bean factory or the factory pattern that allows you to decouple the configuration and specification of dependencies from your actual program logic. It has the core component, which provides inversion of control and the dependency injection feature. It has context, which inherits its features from the beans module and adds support for internationalization using, for example, resource bundles, event propagation, and resource loading. Expression language modules, which provide a powerful expression language for querying and manipulating an object graph at runtime. AOP, which is aspect-oriented programming, develops proxies for business layer and works as a solution for cross-cutting problems. Test, this module supports the testing of Spring components with JUnit or TestNG. And design pattern includes singleton MVC factory. Introduction to Spring, which is inversion of control. Recall, we have discussed that Spring provides the container and provides the Spring configuration XML file to configure the required class object that we need instead of using a properties file. The Spring container is an IOC inversion of control container. What is IOC? Now, IOC is a design principle that explains how object creation, dependency injection, object lifecycle management, object destruction, etc. can be managed using an external entity. Spring container is the external entity that implements the principles of IOC. It is the core container of the Spring framework, and it performs the following operations: creates the objects, wires them together, configures them, and manages their life cycle till destruction. Now, Java classes that are handled by this container are called Spring Beans. What are the uses of the Spring IOC container? It's used for instantiation of objects, dependency injection, and initialization to read configuration metadata. The Spring Framework's IOC container package contains the beans and the context packages set of classes. Let's look at the working of the IOC container. The Spring container uses POJO classes or plain old Java objects and configures metadata to produce fully configured and executable beans. So the metadata and the POJO is consumed by the IOC container, which generates the output results. There are two types of Spring containers which are based on the following interface. We have the bean factory. The application context extends from the bean factory. The bean factory and application context are the interface for container. We have XML bean factory, which gives the implementation for the bean factory interface. Spring Bean is configured in the configuration file. Bean factory container loads that bean. It is a lightweight container. It hence manages the entire life cycle of the Spring Bean, and the life cycle of the bean starts from calling the getBean method. It is generally used in the application where data volume and speed is significant, for example, mobile devices or applet-based applications. In terms of the application context, you see the class path XML app context, the file system XML app context, and the XML web app context, which go ahead and implement app context. If you use file system app context container, you need to pass the Spring configuration file to the constructor. If you change the project location once, you have to change it every time. If you use class path XML app context, you don't have to specify the complete path of configuration file. If you change project location, your file will work without modification. If you use XML web app context, you can use Spring MVC module. The container based on app context provides all the features of Bean Factory. In addition to this, it also provides event handling, EJB integration, transaction management, and security management. Creating the Spring Bean container involves creating an object of any implemented class in XML Bean Factory. So we can either say resource equal to new class path.resource and load the config file, or we can say provide the specific path and then say bean factory equal to new XML bean factory and pass the resource object as a parameter to its constructor. The constructor of XML bean factory class takes resource object as an argument. This represents Spring configuration file. There are two implementations of resource interface. We have the file system resource and the class path resource. One takes the absolute path and one takes the relative path of the resource file. The Spring Bean container involves creating an object of any implemented class. Here we are creating a Spring Bean container using the file system XML application context class, where we simply provide the path of the XML config file. Here we create a Spring Bean container using the class path XML app context class, where again we pass the XML context file setting. Let's look at Spring with respect to Eclipse. Creating a Spring application in Eclipse is pretty straightforward. We create a Java project in Eclipse, add a name to it, by clicking New Project, Java Project, and Next. We then add a Spring jar file where you right click on the project build path library, you click on add external library and you add your Spring libraries. You can also click on user library and add Spring jar to this user defined library folder. You then right click the project, you create a Java class in the SRC folder, you add a name, you write private properties inside the Java class, you select the properties, right click source and you generate your getter and setter. This class is called the Spring Bean and will look like this. You then create the XML file to provide values by adding a new config file to the project. You create a test class inside SRC folder. The steps to write the code for the test class. You create Spring container using either XML Bean Factory or app context, and here you set up a variable that can access all the methods of the Spring Bean class. Here are your configuration file tags. So this is how you're going to set up your Bean class. These are the standard namespaces, the reference ID for the class object and the class name within the Bean tag. Let's talk about dependency injection in Spring. Let's look at an example to understand DI. We have two classes here, author and book. The class author is dependent on the book class. That you see that the class author has an object of type book in its attribute structure. Class book will get injected into class author by using the inversion of control. Resolving the dependencies among the beans is called dependency injection. In Spring, DI is achieved in two ways. The setter injection, if the dependency is injected to dependent object via the setter method, it is known as setter injection. And constructor injection, if dependency is injected to dependent object via constructor, it is known as constructor injection. The dependency object can be changed dynamically. It provides loose coupling between dependent and dependencies. The code appears clean and readable. DI and IOC make managing dependencies between objects simple. How do we implement the setter injection? We create a simple Spring Bean class by the steps that we saw on the previous slide. We declare the member variables in the class, we define the setter method, and then we use the property tag in the bean config file, and we provide values for member variables in configuration. For implementing constructor injection, we create the Spring Bean class, we declare the member variables, we define a constructor that will take the variable as a parameter. We then use the constructor argument tag in the bean config file and we provide values for member variable configuration file. Here is an example of the setter injection. So we can see as part of the setter injection, we actually have the name of the class member variable, the value that has to be provided, or you can say property name of class member variable value. So this is how we are actually going to set up the setter injection setting in the config file. Setter injection where dependency is object type. So here we give a reference for the dependency class ID. Okay, property name equal to class member variable and the dependency of class ID. If we are using constructor injection, I will give the bean ID with the class name and the constructor argument value with the data type of what you're expected to pass as a parameter to your parameterized constructor. The implementation of constructor injection where dependency is an object, here again it remains the same, reference bean ID, or you simply say reference equal to the value. To pass multiple values to the bean, we use collection injection. Spring offers 4 types of collection configuration elements. List, which injects list of values allowing duplicates. Set, which injects set of values without duplication. Map, which injects name value pair, and props, which inject name value pair when name and value are both strings. The configuration file for injecting collection injection will look like this. In case of set, we replace with list tag. So here you see, you replace the list tag with set tag in case of the set. In case you are using the list, you provide the list tag with the values. If it is an object dependency, it needs the reference IDs. Constructor injection versus setter injection. In constructor injection, partial injection of dependencies is not possible. This is because we must pass all the arguments to call constructor. The constructor injection cannot override the values injected by setter. For dependencies greater than 15, setter method is not recommended, and constructor injection makes bean class object immutable. In setter injection, partial injection of dependencies is possible. It overrides the values injected by the constructor. It is ideal for dependencies greater than 15, and it makes the bean class object mutable, which means it can be changed. Let's look at a demo with Spring configuration, constructor and setter injection. So let's start with the introduction to Spring configuration, constructor and setter injection, and we'll do a demo that will actually allow us to get hands-on and understand how to configure Spring with our Java project and how to create objects by using the dependency injection and IOC design pattern that we discussed, using two approaches, the setter injection and the constructor injection. Now the first thing that we will need is the Spring configuration file to be downloaded. So we will need the Spring software. So I have downloaded here the Spring framework, and you can just Google for it and download the Spring framework and unzip it. Once you unzip, in the lib folder you will have an entire list of jar files that will actually be used for configuring the Spring framework. Going forward, you can use Maven to configure only those jar files that are required for your application. Now Spring actually supports a lot of additional options that are available to you. So if we just open up the Spring documentation, you will see that there are a whole list of options actually available as part of the Spring framework that you can go ahead and use. And it's a huge vast ocean. So I'll just open up Google, and here we'll say Spring. So that opens the Spring website, which is spring.io. Okay, and here you see the entire Spring framework available. I can go to the guides which allow me to actually get started. Alternatively, I can actually Google for Spring documentation. Okay, and that opens the Spring documentation for you. So if I click on reference documentation, it will actually give me all the sub frameworks that are there that club along with Spring, right? So it actually tells me these are the different versions available. If I click on reference, it will show me the reference documentation for the entire Spring core framework. And then along with it, there are a couple of additional modules that you can use. So you can look here, these are all the modules available under the core framework. And in addition, there are so many extension modules like IOC containers, etc., that you can actually configure, and it's an endless ocean. So you can keep, there is also Spring AOP, which we will also look up in our next session. There is a testing APIs, data access APIs. So an entire host of options are actually available along with the Spring framework. Okay, and if we click on the modules, it actually shows us what are the different framework modules available and how we can actually go ahead and use them. Okay, and there are various dependencies that Spring has. So Spring internally uses a lot of added dependencies. So you can actually see the Spring dependencies and how do you manage them. So that a whole set of dependencies that Spring relies on to get its job done and get the automatic injection of the code. Now, besides the Spring framework, we'll also have to download one additional jar, which is actually called the Spring Commons logging jar. So the Commons logging jar file is an additional file that is used by the Spring framework that we also need to go ahead and download so that we can add it into our project. So we will start our Eclipse editor and we'll create a new project. So we'll say new project, Java project. We'll give it a name, Spring Demo. Next, we'll go to libraries, add external jars, and I'm going to pick up the common logging, and also from the Spring libs directory the entire list of jars. We will add the entire list of the jars that we had downloaded. Let's open the Spring Demo project and we'll create a new package. com.transfer object and finish. Inside the package we will add a new class. We'll name the class as hello. We'll add this data to the class. So I'm going to add a simple string message and we'll go ahead and create the getters and setters. Now it is essential for Spring to actually create, since we are going to use the setter injection method, it is essential that we create a getter and a setter within the class. And I'll also create a default constructor and leave it there because Spring uses the default constructor to actually inject and create an instance of the class, which is the bean class. Now I'm going to use a file called beans.xml. Now this is a file that you can just create in your project. Okay, so I'm just going to go and use a ready-made file that I have. Reason being that I've already configured the namespaces in my beans.xml file. I'll just change the extension to XML, and when you open it up you should be able to see that it just has a standard namespace convention. Now this is the standard convention that you have to provide inside your beans.xml file for configuring any bean that you actually require in your project. So here I'm going to create a bean and configure by saying class is com.to.hello. And we'll try and instantiate the property that is there in the class. The name of the property is message and the value that we want to set for that property is welcome to Spring. So here you can see we've actually created an object of the hello class purely by using configuration. Okay, there is no hard coding, which means if I need to switch the bean, I need to create an object of another bean. It's all about updating the XML file and executing the program. You do not have to recompile. And that's the beauty and the benefit of using the Spring framework, which injects the objects that you want based on the configuration that you've set. So this is the line of code that will fire the setter that we created in our hello.java file and will execute it. We'll add a new package to this application, and let me call it com.controller. We'll create a new class inside it, let's name the class as Spring Main. We'll go ahead and add the main method. Inside the main method, we'll now need to access the XML configuration file. So we'll say application context. So let me pick application context equal to new, and we'll say class path XML application context, and we will load beans.xml, which is our config file. Then we are going to say hello h equal to context dot get bean, and we'll say hello dot class, and let us import that package. And let us sys out h.get message. So here we have created an object of type context, and we've passed it the XML file. We are using the getBean method to get us an object of the class. So we never say equal to new object. So the specific object can be injected at runtime, and then we just try and use the getter on it to get the message. And here you see the message that we set inside the bean.xml is actually returned to us. Now if we need to create multiple objects of the class, we'll just copy this and paste it again and save this. And now we'll introduce an ID to uniquely identify one object from the other. So ID equal to h2, and for the previous object we'll say ID is equal to h1. Now let's come to the Spring Main class, and here when I say that I want to get bean, instead of passing this, we will actually pass the ID identifier and say hello h1 equal to context.getBean, and forcibly typecast the return as an object of this class, and then go ahead and pass h2 and also get a reference to h2. So now we can go ahead and print h1.message and also go ahead and print h2.message. And we'll make a small change in both the messages. Welcome to my app. So now when I execute, you can see both the messages coming from the different objects printed. So multiple objects are getting created in the background just via a single config file in XML. The application context here is a singleton object that is generating the objects in the background, and we can also change the singleton design pattern to a prototype pattern. The demo that we just did is called setter injection. The property value for the message is being set by the setter inside the config file. If you observe, there is no parameterized constructor that we have created inside our class. Let's now add a new class and let's call it employee. We will add employee ID and employee name, and we will generate getters and setters for both the values. We'll also add a constructor which is mandatory so that Spring Framework can create an object of this class. We'll go ahead in the bean.xml, add a configuration parameter for an existing additional bean which is the employee class, and we'll change the ID equal to E1. Now we'll say property name equal to employee ID, value equal to 1 2 3 4 5 6. Again we'll copy the property, and this time we'll add a reference to another property which is employee name, and the value will be Amit. We'll save this. We'll come back to the employee class. We'll generate a toString so that it can print out the employee details. And I'll simply, in the set employee name, use a sysout to print setting employee name called, so we know when that particular setter got called. Then in the set employee ID, we will go ahead and say setting employee ID called. And finally, let's come to the Spring main class, and here we'll use the same config file. We'll create an object E1 of the employee, use the typecast and say context dot get bean and pass E1. And now we can say system.out.println E1. Let's add the com.to package. And now you see we are actually able to get the employee information, and the setting employee ID actually got called implicitly, and that was because we actually created this particular object using the setters, so the setters actually got called. Okay, now let's come here and you will see that we also have, so we had the employee ID actually defined here, and let me shift this to the set employee ID instead of the get, because that is the one that's going to be called. And let's execute, and there you see it has called the setters of both the particular properties that are there inside my class. Now let's go to the constructor of the employee class, and here I will attempt to print out default constructor called. We'll now execute, and you see the default constructor got implicitly called because the object had to be instantiated. So this was an example of setter injection. Let us now try constructor injection. For constructor injection, we'll go into the employee class, and here we'll select source and generate constructor using fields. We'll select both the fields and say OK. So we now have a parameterized constructor that has got created. We'll go to the beans.xml file. We'll copy this content and we'll paste it again. When we copy this content, we will see that we'll change the ID to E2, and let's make this 5678, and we'll change the value to another name. Let's go ahead inside the employee constructor, and here I'm going to add an additional system.out saying parameterized constructor has been called. We'll make another change in the beans file. Instead of property, we'll now say constructor argument and replace the property tag with constructor argument. And here we'll say the name is employee ID and name, and these are the values, because now we want to use constructor injection. Let's go here, and this time we'll pass the key as E2, so it creates an object of E2, stores it as in a reference of E1, and simply prints. So here you see the parameterized constructor now got called, indicating it created the object by firing the parameterized constructor and passing the values to it. So this shows us an example of how we can actually create and implement the dependency injection pattern using the Spring framework. Let's talk about the life cycle of the Spring Bean. The Spring Bean factory, as we discussed, is responsible for managing the life cycle of beans created to Spring. Spring container controls the life cycle of Spring Bean. It creates the objects for bean, injects dependencies, performs initializations, calls business methods, and removes it from the container when it is no longer required. So first we instantiate the bean, then we populate the properties. The bean becomes name aware in terms of the ID it has. It becomes factory aware. It gets registered in the application context factory. It becomes application context aware, then it gets initialized, then the init method or the post construct method is fired, then it is ready to use. The container is then in a shutdown mode. We dispose the bean or call the dispose method, and then the bean is removed. This is the entire life cycle of the bean that gets created by the Spring framework and gets injected into our code. So the instantiation is the creation of the object done by Spring container. We then populate the properties using dependency injection pattern. The bean name aware is an interface used to override its name, calling the set bean method, and the bean gets a name. At this stage it is used to get container information in which the Spring Bean is available. Then the initialization phase, the three options for controlling initialization: initialize bean, custom init, and post construct annotations. Then the method ready state, where the object is ready for use and business methods are called, and the destruction phase, where we have three options: dispose bean, custom destroy, and pre-destroy. Here is the initializing bean, which is an interface that is used to implement its methods after properties set is called, and the initialization can be written inside this method. Then comes the custom init, where we give a ID, class name, and init method equal to init. In the case of XML based configuration metadata, you can use the init method attribute to specify the name of the method. The post construct annotation, in the case of annotation based config metadata, you can use this annotation of JDK at the top of the method to specify the method as initialization method. So here you see this is the method that will actually fire the initialization code that you have written. Finally, the destruction is an interface used to implement the destroy method, and you can write initialization inside this method. So here is where you write the code for destruction and your bean will be disposed. In case of XML based configuration metadata, you can use the destroy method attribute to specify the name of the method. So here we have the ID, the class name, and destroy method, that is the custom destroy method that you want to write, which will execute when the bean is to be removed from memory. So in case of annotation based configuration metadata, you can use pre-destroy annotation of JDK, and this is another option available. So you say pre-destroy, and this is the method that will get called when it's time to destroy and garbage collect the memory of the bean. Let's talk about bean wiring. The Spring container can auto-wire relationships between collaborating beans without using constructor arg and property elements. This is known as bean wiring. Auto-wiring refers to injecting the dependencies automatically. It is used for object injection as it provides one way of injecting object dependency without property and constructor arg injection, and to implement auto-wiring we use the auto-wire attribute of the bean tag. We have constructor, by name, by type, and auto detect as different types of auto wiring. When auto wire equal to constructor, the container checks the constructor parameter type. Example, Spring Bean class. Here we are passing a student object. So the container looks for beans configured with the name student. If found, it injects all those beans. If a class has multiple constructors, then it checks the parameter type. Then if AutoWire is by name, the container will check all the setter methods that have only one parameter within the bean. For example, I'm passing the exam detail object. The container looks for beans configured with the name exam detail. If found, it injects all the beans. It doesn't bother about setter method parameter type. It only considers setter method names. Then if AutoWire is set to by type, the container checks all the setters method that have one parameter type in that bean. Example, we are passing the exam detail object here. The container now looks for beans configured with the name exam detail. If found, it injects all the beans. It doesn't bother about setter method name and bean ID. It only considers setter method parameter type. When AutoWire is auto detect, the Spring first tries to wire using AutoWire by constructor. If it does not work, Spring tries to AutoWire by type. This is deprecated as of Spring 3.0. Let's talk about bean scope. When defining a bean, you have the option of declaring a scope for that bean. There can be two choices. You want Spring to return the same bin instance each time one is needed, like a singleton pattern, or you want to force Spring to produce a new bean instance each time one is needed. So if we say the scope attribute is set as singleton, it creates the configured Spring bean only once in the container. If it is prototype, it creates the configured bean each time it is requested. If it is request, it creates the configure bean one per web request, and it is applicable only in web module. If it is session, it creates the configured bean one per session. It is applicable only in web module. And if it is thread, it creates the configure Spring bean one per thread. So we learned here that Spring Framework is a Java platform that provides comprehensive infrastructure support for developing Java apps. Spring handles the infrastructure to ensure focus on your app. Spring Container is a IOC container. IOC is a design principle that explains how object creation, dependency injection, object lifecycle management, object destruction can be managed using an external entity. Spring Container controls the lifecycle of the Spring bean. It creates the object for bean, injects dependencies, performs initialization operations, calls business methods, and removes it from the container when the bean is no longer required. And the Spring Container can auto-wire relationships between collaborating beans without using the constructor arg and property elements, and it is known as bean wiring. Thanks for watching. We'll see you in the next session. Let's move on now to the next session in the Advanced Java series, which is Spring AOP. We will explain AOP and its terminology. We'll configure AOP in a Java application using Aspect-J approach. Let's introduce ourselves to Spring AOP or Aspect-Oriented Programming. AOP is used in applications that have cross-cutting concerns, that is, pieces of logic or code that are written in multiple classes, layers as per the requirement. Some common examples are transaction management, logging, exception handling, security aspects, and instrumentation. Let's understand the concept of concern. A concern is a piece of code that performs a specific task, and there are two types. Core concerns are codes used for business logic. Cross concerns are functions that are conceptually separate from the application's business logic but affect the entire service layer. Example: logging, auditing, declarative transactions, security, and caching. Aspect-oriented programming provides one way to dynamically decouple core concerns from cross-cutting concern. AOP is one of the basic components of Spring Framework, and the main idea of AOP is to isolate the cross-cutting concerns from the application code, thereby modelizing them as a different entity. Services layer deals with two types of concerns: core concerns and cross-cutting concerns. Spring AOP provides declarative enterprise services such as declarative transaction management. It allows users to implement custom aspects. Spring AOP is used to track user activity in large business applications. It uses proxy as a mechanism to implement cross-cutting concerns in a non-intrusive way. Let's look at some AOP terminologies. What is an aspect? It is a feature or functionality that cross-cuts over objects. It has a set of API application programming interface that provides cross-cutting requirements. Join point. It defines the various execution points where an aspect can be applied. Point cut tells us about the join points where aspects will be applied. Advise provides concrete code implementation for the aspect. And target is a business object. It comprises of aspect business's core concern. Weaving represents a mechanism of associating cross-cutting concern to core concern dynamically. Proxy is an object produced through weaving. There are two types, static and dynamic. In static proxy, static method is used to develop and maintain proxy classes for each business method. In dynamic proxy, proxy is developed at runtime. Weaver is code that produces proxies. The proxy design pattern is an actual business object where it is wrapped into another unknown object known as proxy and substitutes that object in place of the actual object. We will discuss join point, point cut, and proxy in this lesson. Point cut defines where exactly the advice has to be applied in various join points. Generally, it acts as a filter for the application of various advices into the real implementation. Spring defines two types of point cut: static, where it verifies whether the join point has to be advised or not. It does this once the result is cached and reused. And dynamic, where it verifies every time as it has to decide the join point based on the argument passed to method call. So you see the point cut and the dynamic method matcher point cut, and finally the control flow point cut. So this is the structure and types that exist in terms of static and dynamic point cut. Let's talk about the static method matcher point cut, which has two types of point cuts. Name match method point cut. It interrupts a method via point cut in advisor. And abstract regex method point cut. Besides matching method by name, it can match the method's name by using regular expression. This point cut is used to verify join point based on pattern of the method name instead of name. Then we have JDK regex method point cut. It is represented by org.springframework.aop.jdk regex express method point cut, and Perl regex method point cut. It is represented by org.springframework.aop.support.perl5 regex method point cut. The dynamic method point cut. This point cut is used to verify the context from which business method call is made. If method call is made in specific flow, it will be advised, otherwise it won't. Point cut is an interface. It is represented by org.springframework.aop.pointcut. And the get class filter method returns a class filter object which determines whether the class object argument passed to the matches method should be considered for giving advices. A join point is a candidate point in the program execution of the application where an aspect can be plugged in. This point could be a method being called, an exception being thrown, or even a field being modified. These are the points where your aspect code can be inserted into the normal flow of your application to add new behavior. A point cut defines the join points where associated advice should be applied. So in terms of the join point methods, we have accessible object with a method, get static part which returns accessible object, and this returns the static part of join point. Get this returns the object that holds the current join point static part, and we have proceed to the next interceptor in the chain. How does AOP work? The proxy interrupts the call made by caller to original object. It will have chances to decide whether and when to pass on the call to the original object. In the meantime, any additional code can be executed. Spring uses the dynamic proxy approach where the caller calls to the business on the original object. A dynamic proxy class is a class that implements a list of interfaces specified at runtime so that a method invocation through one of the interfaces on an instance of the class will be encoded and dispatched to another object through a uniform interface. In the proxy pattern, a class represents the functionality of another class. This type of design pattern is a structural pattern. It creates an object that has original object to interface, its functionality to outer world. Proxy design pattern is used when we want to provide controlled access to a functionality. It is also used to save on the amount of memory used. Similarly, if you want to control access to an object, the pattern becomes useful. Let's look at the ways to generate dynamic proxy. The JDK approach: when the business class implements interface, JDK creates proxy for the business object. The CGlib approach: the CGlib.jar is used when a business class fails to implement any interface and JDK is unable to create the proxy. Advice refers to the actual implementation code for an aspect. Spring supports method aspect. Different type of aspects available in Spring. Before advice, it executes before a join point but does not have the ability to prevent execution flow preceding to the join point. After advice, it is executed after business method call. Around advice, it surrounds a join point such as a method invocation. It can perform custom behavior before and after method invocation, and throw as advice is executed if actual method throws exception. To configure these advices, we have to depend on proxy factory bean. This bean is used to create proxy objects for the implementation class along with the advice implementation. The proxy property called proxy interface contains the interface name for which the proxy class has to be generated. The interceptor names property takes a list of advices to be applied to the dynamically generated proxy class. And finally, the implementation class is given in the target property. The before advice, now this is used to intercept before the method execution starts. For example, a system may need to perform some logging operation before allowing users to access resources. So whenever the caller calls the business method, all before advice code is executed prior to the business method. If an exception occurs in the method, after returning method will never be called. Configuring before advice. Develop a business interface in its implemented class. Develop a class that implements after returning advice interface. Override its after returning method. Cross-cutting code is written here. The after returning method is the target method to be invoked. The object arguments are various arguments that are passed on to the method, and object target is the target reference to the object that is calling the method. Finally, we get a proxy and make a method call. Here is the sequence diagram with the steps. So we have the client which calls the business method on the proxy, which is the interceptor. The proxy will call the before advice method. Control will return back to the proxy. The proxy will then go ahead and call the actual business method. So if you want to perform some action before your business method is called, you can write that code in the before advice function. After advice is used to intercept after the method execution. For example, a system needs to perform some delete operations after logging out. After advice is executed after the business method. So the steps for configuring after advice are as follows. We develop a business interface and its implemented class. We develop a class that implements after returning advice interface. We override its after returning method. We cross-cutting code is written here. The method is the target method to be invoked. The object arguments are various arguments that are passed to the method, and the object target parameter is a reference to the object that is calling the method. Then we get a proxy and make the method call. If an exception occurs in the method, after returning method will never be called. Here you see the sequence diagram. We have the client trying to call the business method, but the proxy intercepts. The proxy goes ahead and calls the business method, and after that it calls the after returning, and then the return will come back to the proxy. Around advice, it can change the return argument of the method call. It provides finer control regarding whether the target method has to be called or not, and it can be performed before business logic or after business logic. How do you configure around advice? It develops a class, or you rather set up a class that implements method interceptor interface. You then override its invoke method. You write the cross-cutting code. You get a proxy, you make a method call, and the parameter of the invoke method is to be passed. So here you see you have a client trying to call the business method. The proxy intercepts. The proxy attempts to call the business method, and then immediately calls invoke, and then it calls the business method post that. When an exception happens during the execution of a method, throws advice can be used through the means of org.spring framework.aop. The throws advice is used to handle exceptions. This advice is executed only when the exception is raised. The advice has to implement org.spring framework.aop. The throws advice, it is just a marker interface. Exception handling code is considered cross-cutting code and can be done for entire service layer in throws advice with different kinds of exception parameters. To configure throws advice, we develop a business interface and its implemented class. We develop a class that implements throws advice interface. We then override its throwing method. Cross-cutting code is written here. We then get a proxy. We make a method call, and then the throws advice can take any of the following forms: public void after throwing, or public void after throwing, and the method, the object arguments, the target, and the exception. Let's look at configuring AOP in Java applications using the Aspect-J approach. Now there are two ways to use Spring AOP aspect implementation. You either create it with annotation or with XML configuration. We'll need to download the Aspect Viewer jar file to get this functional in our application. Here are the steps. For annotation with Aspect-J AOP, we have @ before annotation applied before calling actual method, @ after applied after calling actual method, @ around applied before and after the calling method, @ after returning applied after calling actual method and before returning result, after throwing applied if actual method throws exception, @ point cut is used to define your point cut, and if you give in its various forms, it can be applied on all public methods or on all public methods of operation class or on all the methods of operation class, etc. And @ aspect declares the class as aspect. Let's look at @ before. So there are two classes here, perform and track performance classes. So here is perform and here is tracker performance. Assume that perform class contains actual business methods. The Aspect-J before advice is applied before the actual business logic method using @ before advice. So here you see @ before, @ point cut with the operation, and @ aspect. So this is the tracker class which is going to track the performance class. So you see the output, it says calling message. Before advice called, it triggers this, then the message method, then it calls the method, then before advice again, the second method invoked, and then before advice again, method invoked. Then we have the @ after annotation, which is where we use the same person class and track performance. Person class is the same, but @ after annotation in the track performance class is used in this case. So the aspect and the point cut remain the same, only @ before is replaced with @ after. And you can see the difference. Instead of the befores now, you have the afters getting triggered, which is after the methods individually are called, and you can execute that method to take appropriate action after your business methods have executed. You see the around now getting replaced here instead of the before and after, and the code rather pretty much the same. And now if you look, you have a additional concern before, additional concern after, again for the second method a before and the after, and that is the impact of the @around annotation. XML configuration based AOP, it uses the following XML elements to define advice. AOP before, it is applied before calling the actual business logic method. After is applied after calling it. After returning is applied after calling the actual business logic method. It can be used to intercept the return value. Around is applied before and after calling the business logic method, and after throwing is applied if the actual business logic method throws an exception. So here you see the application context file. You see both the beans with IDs, the class operation and track operation. The point cuts have been defined with the expression. And here if I need a before or an after, so here you see the before, and if you need an after, this is the code that you will go ahead and specify. So let's look at advice versus aspect J. In advice, the Spring AOP is best used for application specific tasks such as security logging transactions. This is a proxy based AOP. You can use method execution point cut only. There can be little runtime overhead. It needs Spring Jar files only. Aspect J contains friendly design patterns. This supports all point cuts. There is less runtime overhead than that of Spring AOP, and you need extra build processes with Aspect J compiler, or have to set up LTW or load time weaving. We'll now start with a demo on Spring AOP, and we'll go through both the classical approach by the advice classes and the Aspect J approach. So AOP, or aspect oriented programming, as we discussed, speaks of aspects or events or advices. For example, before a method is executed, what advice is to be given, or after a method is executed if you want some type of action to be performed. Now AOP is constructed on the proxy design pattern, and the proxy pattern is actually a call which is made to a actual server via a proxy server. So the concept here is that the proxy interrupts this call, takes up the call, and as if it is the real server, and then forwards it to the actual server. This can be useful for auditing purpose, where you want to create an event log or a logger where you want to track every action that is performed in your application. And there are two approaches in AOP. The classical approach, where we have to write advices in a separate class, and it takes a lot of bean config to write in the XML file, or the modular or aspect4j option, which is via annotations, where one central class can handle aspects of any other classes. All methods that start with is, for example, is valid, etc., is where you want to perform a check when all typical methods are executed. Or if you want to track your application, this concept can be used again using aspect4j. You can also use regex expressions with modular approaches to get this done in a very simple way without having to do too much of configuration. So first we will look at the classical approach. Now I have a simple Java project here that is named as classical, as you can see. There are a couple of jar files that we have referenced. The first jar file that we will need is the commons logging jar that we had already downloaded in the previous example, and we can just Google for it and download it. Then we need all of the Spring AOP jar files, or rather the Spring jar files. So the Spring framework that we had downloaded in the previous demo, we have just added all of those files here. And we will also need Aspect J for the implementing Aspect J AOP and Aspect J Weaver. Both these files also we can just Google for them and download it. So these are the external libraries that have been added, or the external jars that have been added to the project. Then we created a new package and we called it com.to, and we created a simple business object or entity class here called SumBO. Inside it, we have written a validate method that simply prints validation stuff from BO, and we have overloaded that method with another method called validate, which takes the age parameter. If the age is less than 18, it throws an arithmetic exception that says not valid age, else it prints a simple message that says vote confirmed. We will now learn how to build aspects and advices around it. So there is another package that I have added which is called com.apps. In this package, a new class I have added called after advisor. Now this is the code that will execute after the function validate is called and any appropriate action has to be taken. So here you see after advisor, which has to implement from the interface after returning advice. We provide the implementation for the after returning method, which takes 3 arguments, and here we say some stuff post method call and argument dot get name. Okay, that is the code that exists in the after advisor. Now I have added one more class called the before advisor. Now in the before advisor, it implements an interface called method before advice and provides an implementation for a method called before. Here we just log a message saying logging before call of method argument dot get name. Then I have added a third class called both advisor. So both advisor will trigger a call, as we saw in the slides, before and after the execution of the method. So here we simply print before method, we then call the proceed, so it proceeds to the next step, and then after method. So it will execute the validate method in the business object and then it will proceed to call the after method. Finally, in case there is an exception, we have an exception advisor that implements throws advice and provides a method after throwing. Here we just print a message which says additional concern if exception occurs. Now we need the configuration file, so I have added a new XML file. This file could have any name like in the previous demo. It's called beans.xml. Okay, we have added all the references that are actually required on the top. So this is the standard header. Here is the first bean that is getting configured. So this is ID equal to BO. This is a custom name that we have given for our SumBO class. Then we have said BA, which is a ID that stands for the before advisor class. AA stands for after advisor. BH is an ID for both advisor and EA for the exception advisor. Then we have added a inbuilt class which is org.springframework.aop.framework.proxy pattern, and here we have said name equal to target, reference equal to BO. That means all these advices will be targeting this particular class object and methods. Then we have a list of values that we would want to populate according to the advisor that we want configured. Finally, we add a new package called com.exe, within which we add a class called main.java. In this class, we use the Spring framework to generate the object and inject it into our main method, which is SumBO.class. So we get the bean and we pass a reference to that proxy ID that we had given, and we call the validate method. Then we also have a overloaded validate method that takes an int parameter. We put it in a try catch block because that throws an exception. Now if you look at the bean config file, it is config to AA, which means the after advisor code is expected to execute. So let's go to the main and we'll execute this, and we will see validation stuff from BO, which is the validate method, and some stuff post call has been executed. So this is the after advice that has got executed, which is some auditing work or tracking work that you want to perform after the function is called. You can see that the after advice automatically executes. Now let us modify this and let us change this to 19 and save it. Once we execute this, you will see that it now calls some stuff post method called, then it actually calls the second method vote confirmed, and it again says some stuff post method call. So that is the after advisor executing after each method call. Now let's go to the beans.xml file and we change this value to BA, which stands for the before advisor. So we'll make this BA and save this. Now when we execute this, you can see it logs a call before the validate method, then it executes the validate method, then again it logs before call of method validate and vote confirmed. So this is the code that got executed twice, once before each method. Now let's go back to the beans.xml and we'll configure this as BH, which is the both advisor or the around advisor. Let's go to the main and execute this. And here you see before and after method functions are called, where you can take appropriate audit action, or if you want to log something, you can log it as well. If we change this back to 17, it will generate the exception. And you see here before method, after method, it only executed the before method, the exception was raised, so the method did not complete and hence the after method is not called. Now you can also add multiple aspects. So let's say I add another one called EA and I save. We again run. And here you see before, validation stuff, after, before, additional concern if exception occurs, and so this is the println that ran from the exception advisor class, saying that if the exception occurs, then you also have an exception which will run. We will now see the aspect J approach, which is very similar to this approach but with much better options, where you do not have to do too much of configuration and you can actually get everything done just by annotation. I'll open this project that I have called aspect approach. Let's go and look at the jars that have been added. Again, I have all the Spring AOP or the Spring framework jars that have been added. Besides that, I have the commons, the aspect J and aspect Weaver jars which have been downloaded from the web. So these are the reference libraries which have been added. Post this, we created a new package called com.businessObject. Within it, we created a business object class very similar to the previous example. Here we have a validate method and we've overridden another, or rather overloaded another validate method that simply checks for the age and throws an exception or prints a message. We added one more class to this project, which is central AOP aspect. Now this is the class that is actually doing all of the validations, or rather all of the logging before, after, both, around. So all the options are now there in a single class rather than configuring everything in the beans.xml. So let's look at what's there here. We have imported the relevant packages from aspect J. We then put the annotation @aspect because this is the aspect class. we provide the point cut annotation where we are targeting the execution of a method that starts with the word valid and is there as part of the SumBO class. So we have a method called validate. So this is going to track and map to that method, and the asterisk here indicates anything that comes after the word valid, which is, in our case, our method name is validate, and the dots indicate that it can take no arguments or any arguments. So we have two methods, one called validate which takes no arguments, and another one which is overloaded that takes the integer argument. Here we have a function v that now stands for the validate function. So when the validate function gets called, this will execute. Then we have a before, as you see here. So this is the before annotation, and this is the method that will get called before validate. Here is the after annotation. So this is the method that will get called after the validate. These method names could be anything as long as it takes a value of or passes an object or accepts an object of join point and maps to this synonym tag over here. Then the around, which prints before and after calling the actual method, and proceed, and then we return that object. And this is the after throwing for the exception. Any exception that is thrown from this class, we print additional concern, the method signature, the exception, and the end of after throwing advice. So you see the code is all now structured into a single class as against 4 different classes that we had to create with the previous approach. So hence this is much more simplified and much more easier and logical to write as compared to the previous demo. Let's go to the beans.xml and you'll see the header remains common. Here we configure the SumBO object. Here we configure the central AOP aspect class. So that is the class that we had created, and this is the bean org.springframework.aop.aspectj annotation aware aspect j auto proxy creator. So this is the class that we need to map to get this functionality working. Now let's go to the aspect class, and here we'll just have the before and after functional. So we'll comment this. So we just have the before, right? Or probably let me comment this as well. Let me come to the main and we'll attempt to execute this. So here you see before method validate and before method validate int, and it throws the exception then. Now let's come back to the central aspect class. We'll also uncomment the after and run this, and there you see we have the before and after for the validation, again the before and after for the int, and then it throws the exception. Now let's comment this bit. We'll uncomment this bit and we'll try the around annotation, and let's come to the main class and execute this. And now you see the additional concern before, additional concern after, additional concern before. The after did not execute because it was an exception. Let's come back here. We'll comment this and uncomment the after throwing, and now execute the main method. Now here you see the additional concern, the method signature, the exception, and the end of after throwing advice, and that is exactly what this particular annotation was managing. If we get rid of all the comments, it will execute the entire block. So we'll come to main and execute, and there you see now all of the aspects triggering that we have added. And if we correct this to 19, we will not have the exception thrown. So here you see additional concerned after calling after method. So that shows us how easy it is to use AOP to actually configure our application to write before and after join points that will execute and advices that will execute before and after our functions are called, so that we can do some important initialization, cleanup, or also logging activity from an audit trail perspective. So the key takeaways from this session has been that AOP is used in applications that have cross-cutting concerns, where a piece of logic or code that is written in multiple classes and layers as per the requirements. Spring defines two types of point cut: static, where it verifies whether the join point has to be advised or not. It does this once the result is cached and reused. Dynamic, it verifies every time as it has to decide the join point based on the argument passed to the method call. Spring uses the dynamic proxy approach. A dynamic proxy class is a class that implements a list of interfaces specified at runtime, so that a method invocation through one of the interfaces on an instance of the class will be encoded and dispatched to another object through a uniform interface. Thanks for watching. We'll see you in the next session. Welcome to session 9 of the Advanced Java series. Here we are going to talk about Spring JDBC and Spring Hibernate. We will explain Spring JDBC DAO, explain how to implement Spring JDBC in an application. We will integrate Spring with Hibernate. We'll explain how to create applications using Spring Hibernate template, and we'll describe Spring JDBC transaction management. Let's start with JDBC and Spring Hibernate, or JDBC data access object. This is used to build data access layer of enterprise application. It is a mechanism to connect to the database and execute SQL queries. The database related logic has to be placed in separate classes called DAO classes. Let's do a quick comparison. The difference between JDBC and Spring JDBC based on: first, transaction management. JDBC doesn't support to enable and disable transactions declaratively, whereas Spring JDBC supports. Distributed transaction management, Spring JDBC has support for it. Annotation based transaction management, Spring JDBC has support. Resource allocating logic, in JDBC the connection statement and prepared statement have to be allocated explicitly by the developer. Spring provides template object and it expects the database resource allocation logic. Resource releasing logic, in JDBC developer explicitly writes the logic to release the database resources. Spring provides the JDBC template object. Exception handling, JDBC throws Java SQL exception. There won't be specific exceptions for specific problems, and for Spring JDBC it provides fine-grained exception handling mechanism to deal with database. So here we see the DAO classes connecting to the Spring JDBC framework, which is an additional layer which then connects to the JDBC API and finally talks to the database. What is the advantage of using Spring JDBC API? It provides the capability to establish the connection and interact with database. It simplifies the development of JDBC Hibernate, JP and JDO. It provides multiple templates to interact with database: JDBC template, Hibernate template, JDO template and JPA template. The terminologies of Spring JDBC API: when a connection is opened and closed when required in an application, the object utilization becomes difficult and the cost of implementation increases. In such cases, connection pooling is used. It is a mechanism of pre-creating a group of database connections and keeping them in cache memory for use and reuse. It provides high performance and efficient resource management. It is an interface that is an object-oriented representation of connection pooling. That's what the Java SQL data source does. It is a connection factory for Java application. It is an alternative for driver manager and provides database connections to the Java application. Its implementation classes are provided by the following connection pooling mechanisms: Apache Basic Data Source, Spring Driver Manager Data Source, and C3PO Combo Pool Data Source. The JDBC template is used to handle common logic. It is an abstraction of the JDBC technology. The methods provided by JDBC template are for insert, update and delete methods. The template provides update method. For find by, balance, find by all, row count available in JDBC, Spring templates provides query, query for int, query object, query for map, query for list. To handle batch updates, JDBC template has convenient methods. Here we see some JDBC template methods. The update, for insert, update, delete, for DDL, for executing query by using prepared statement, for fetching records and fetching records using row mapper. Let's talk about Spring JDBC implementation in an application. To implement, we create a database and table in the database. We then create Java projects in Eclipse. We then create the Spring Bean class or the Pojo. We then create a DAO. We then configure data source and Spring Bean Spring configuration XML file. We then create Spring Bean or Spring container either by XML Bean factory or application context. For implementing Spring JDBC in an application, we create database and table in database. The syntax to create database is create database name, and the syntax to create the table is create table name with the respective columns. Next step, we create a project in Eclipse. Then we consider a user class that has 3 member variables, ID, name and salary. We then create a DAO class where we create an object of JDBC template. We set it in the constructor. Then to save the user, to update the user and to delete the user, we actually write string queries and pass them to the JDBC template.update method. To configure data source and Spring Bean configuration XML file, the JDBC driver can be used to establish connectivity to the database during development of basic unit or integration testing. Spring has 2 data source classes, driver manager data source, which returns a new connection every time a connection is required, and single connection data source, which returns the same connection every time a connection is required. We then configure data source and Spring Bean via the XML file. So here you see the Bean ID configured to driver manager data source, the property driver class name configured to the driver, the URL configured to the URL of the database, the username and password. The ID JDBC template configures to the JDBC template class, and the data source gets a reference name. Then we create a Bean ID for injecting the user DAO class, and finally we reference the JDBC template. The last step, create Spring container either by XML Bean factory or application context. So here we use the application context, we pass the XML file reference, we get the user DAO class injected, we then save the user information and print the status. Let's look at a demo where we will implement the JDBC template using a combination of JDBC and Spring Hibernate. So we'll move to Eclipse. The first thing we'll do is we have to add the reference libraries. So we now know that JDBC template is a design pattern by Spring. It welcomes the JDBC ORM Hibernate also to come in and assists us from saving our time with writing lot of config code. So the template design pattern is actually one of the creational COF design pattern. The architecture and configuration is pre-written, so we can focus on the business and persistence logic. So previously JDBC had lots of configs where we had to create the connection, etc. Spring now takes care of all of this, and also connection pooling and exception management as well. So JDBC template helps with this, and Spring takes care of the end-to-end JDBC config. So I have created a new project. Within that project we have added commons.login reference library, and also all of the Spring jars along with the JDBC jar to connector to SQL or MySQL database. You can add Oracle one as well, AspectJ and AspectJ Weaver, which we covered in the last session. So now let's open up the employee class. It has employee ID, name, age and password, and simple setters and getters, and also a toString override. that's there in the employee class, and this is the object that we want to save into the database. We've also created a database in SQL with employee ID, name, age and password, and that is ready. Now we have the mapper class, which is actually creating an object of employee, and it is mapping the ID, age, name and password of the employee to the database fields ID, age, name and password, and it's returning the employee reference. Then we have the DAO class, where we are defining the data source, the template object and the transaction manager object, because we also want to learn transactions here and run this as a transaction. In the set data source, we are initializing the JDBC template. We have an add employee method which takes the employee object and inserts it using a parameterized query into the employee table. So we fire the update method, we give the query and the 4 parameters of ID, name, age and password, and we return the count of the records that have been updated. We have another method that gets all the employees. It returns a list of employees. We say select star from employee, and we simply pass the query, the SQL statement and the mapper class, so that it maps the values that are there in our employee object to the database fields, and we return the list employee. Here we are just giving a suppress warning message so that it allows a cast from the return of the query method to a list of type employee. Then we are getting all employees based on the age, so we pass the age, we write a parameterized query, select star from employee where age is equal to question mark. Again we suppress the error that is returned and we return the list of employee. Then we have a multi-action method which takes the employee object. It simply prints performing multiple actions. It defines a transaction scope and a transaction status as well. We then write the query. The first thing we do is we insert into the employee a set of values which again are passed using the update method of JDBC template, and we print the result saying how many records have been inserted. Then we fire another query in the same transaction scope to get us the employee which has maximum age. We then fire that statement and we print the object of type employee which is returned, which has the maximum age, and we commit the transaction. So if there is any error with either of these statements, the entire transaction will roll back, and that is what we are doing if there is an exception. These are the setters and getters for the platform transaction manager and the template object. We then come to the beans.xml. This is the standard header. Here we see we are configuring the JDBC driver and also configuring the driver manager data source. We give it an ID of data source. We connect to our database, which is called simply2. We provide the username password, which is root. We then define the transaction manager bean to be injected, which is of type data source transaction manager, and we give it a reference of our data source which is connected to the MySQL database. We then inject the object of the employee DAO class. We also give it the reference of the data source, and we give it the reference of the transaction manager object that is injected. So with this project structure, we are now ready to attempt to use JDBC template and connect to the database, create a new record and attempt to see if it actually works for us. And you see the value here of actually using JDBC template, because JDBC template takes over the management of the connection, etc., rather than we going ahead and writing the code. So we'll go to the main class. Here we have created an object of application context, so we can load the beans.xml, and we are also getting the object injected using dependency injection of Spring, which is the DAO class object. We then creating a new employee object with an employee ID, name, age, password. We are calling the add employee method and passing the employee object and simply printing this is the list of records that have been added. And here you see one record has been added when we executed that, which is the output that we have got. Let us check in the database, and you can see the record actually got added into the database. We will now try to insert one more record and validate. So let's make it 104 and we'll change this to S, change this to TD, change the age as well to 20. Let's execute this once more and we will check, and the second record has actually now got added. Right, we did not save this and hence you saw the same ID. So let me run it once more after saving and execute, and you see the 104 record that we added has now got updated in the database. Now let us retrieve all the employees using the second statement that we have, or the function that we have. So here I will uncomment this. So here we are saying get all employees for employee in the list and simply print out the employee information. And there you see the employee records, 3 records that we inserted are successfully getting printed. Let's comment this. And we'll now call the method that we have that is performing multiple actions. It is also inserting a value in the database and also getting us the maximum age. Okay, so before that, let me just insert a record which has the maximum age. So we'll uncomment this and we will say 105 Y, and we'll change the value here, make it 50, save this, execute. Oops, I think I have not commented successfully. Oh yes, this is it. Save this, execute. One record added. So that's the record now with the maximum age of 50. We'll come down now and we'll execute the multiple statement method that we had written, and it's running in a transaction. So it says performing multiple actions, one record inserted, and it printed the employee details 50, which has the maximum age. Right, and it would have also updated the database and executed that value. So here you see the actual value of using the JDBC template and how it has actually helped us to retrieve relevant data from the database by outsourcing most of the job to the JDBC template framework. Let's move to integrating Spring with Hibernate. Spring Framework provides integration with Hibernate, Toppling, iBatis and JPA, and the reasons to integrate Spring with Hibernate. In large applications, this integration makes the maintenance very easy. When integrated, caching and other performance tuning is handled automatically. Database can be changed easily without affecting the application code, and integrating Hibernate application with Springs avoids creating the hibernate.cfg.xml file. All information can be contained in application context XML file. Configuring application XML. We configure Session Factory using class annotation Session Factory bean. We define Hibernate template by passing Session Factory, and for the database transaction, we define Hibernate Transaction Manager using the Transaction Manager configure AOP. Hibernate template is a helper class that simplifies Hibernate's data access code. It automatically converts Hibernate exceptions into data access exceptions by following org.springframework.tao exception hierarchy. The structure of Hibernate template class: public class Hibernate template extends Hibernate accessor, implements Hibernate operations. So we have multiple methods available, like persist to save the object, save to persist given object and return the ID, save or update to persist or update given object ID, to update which updates the object ID, to delete the ID, to get the object, to load the object on the basis of given ID, and to return all persistent objects. Let's look at how to create applications using Spring Hibernate template. We create a database. We create Java project in Eclipse. We create user Java file. It is the persistence class. We create user DAO Java file. It is the DAO class that uses Hibernate template. We create application context. It contains information of data source session factory. And then we create test Java file. It calls methods of user DAO class. Here, this is how we create the database. We have already discussed how to create a project. We then create the user.java file and mark it with the entity and ID tag as an annotation. We then create the user DAO file where we create the Hibernate template instead of the JDBC template, and this is how we would persist the information using the persist method. Finally, we create the application context XML file. Then we create the session factory so that we can register the bean. So we are registering the template by providing the template reference to the employee DAO bean. And then lastly, we create the main where we load the XML file. We pass the bean ID to get the bean object and we persist the information. So let's start with a demo demonstrating the Spring Hibernate template. So we have already seen the Spring JDBC template. We will now see the Spring Hibernate template. And the benefit of using this would be that the Spring container will initialize the Hibernate container for us, and Spring will take care of all the things like creating, opening the connection and configuring the connection and setting up the data storage for us, etc. So let's get into Eclipse so that we can set up our demo. We'll start with understanding what are the jars to be referenced. First of all, we'll reference all of the Spring framework jars. In addition, we'll reference common logging, the Hibernate jars, and the MySQL connector, which is the JDBC driver to connect to the MySQL database. Now, we'll start with the trainee class, which is going to play the role of the entity class or the DAO class to be saved. So we are going to mark it as entity @table annotation, so this remains the same from the previous demo. @ID, since this is a primary key and we want to auto generate the primary key as an identity column, so hence we have set generation type as auto. We have the trainee ID, trainee name, marks code and contact number. We have the default constructor, the getters and the setters. The toString has been overridden, and we have the parameterized constructor. It does not take the ID since the ID is automatically getting generated. We then have the DAO class, where we are now defining the Hibernate template object instead of Spring template as we did in the previous demo. We have a getter and a setter that sets and returns that object. We have a add_trainee method that takes the trainee object. It creates the session by saying Hibernate template dot open session. It begins a transaction. It saves the trainee object that is passed to it and returns the ID. We then commit the transaction and return the ID out of the function. We also have a function called getAllTrainees that returns a list of type trainee. Here we are defining a new array list specialized to type trainee. We are then saying Hibernate template.load all the values mapped to this entity will be loaded here from the database, and we will return that list back. Now let's set up the XML. So here we've just added one more namespace, springframework.org/schema/p for persistence, and of course the rest of it remains the same. Next we see that we've added the driver manager, jdbc.datasource.driver manager data source, com.sql.jdbc driver, that's the driver class name. The URL is localhost and name of the database is test. Username is root, password is root. Next we create the session factory that initializes the Hibernate session bean. We provide the data source, name data source, the reference is this particular data source, that is the database connection. The property name is annotated class com.2.trainee. So that's the trainee class in the com.2 package, that is the annotated class to be initialized. Then we set the Hibernate properties. This is the SQL dialect to communicate with the database. Okay, initially we will set this as create since we want to create the table. show SQL true, so it generates the SQL in the console. Then we are creating a bean with ID temp, setting it to Hibernate template and referencing the session factory that we have created here. Post that, we create an ID DAO, we connect it to and map it to the trainee DAO class, since we need to create an instance of that as well, and we reference the Hibernate template out here. So that's all that is there inside the beans.xml file. Now we just need to go and set up the main program. So we'll go to the main.java. This line remains the case same. The application context is loading the beans.xml. Post that, we get the bean name called DAO. That's the same name that we have actually specified here, that maps to the trainee DAO class. We create a new trainee, provide some values. We call the add trainee function and provide the method there to the DAO class. We then print all the trainees that are there in the database. So now you can see when we execute it, we create the table, we insert one value. So here you see the trainee value Vinay12 with the contact number actually gets returned with the select all. Now let's check in the database as well. Select star from trainee. Let's select the test database. Okay, and there you see this is the record with the ID automatically generated that we had actually inserted from the backend. So now here, if I need to add another record, let me make this 13. Let me change the value. We'll go to the beans class and change this from create to update and save this. Right, so there are two records now, trainee1 and trainee ID2, that are returned, and let's refresh this and you see the second record also has got added with the name Ajay. So this shows us how it is pretty easy to set up the JDBC template using the Hibernate template option and outsourcing all of the hard work to Spring. So Spring will take care of managing all of the connection. We actually did not create a separate CFG configuration file for Hibernate. It was the single beans.xml that actually did the job for us. Welcome to Spring JDBC transaction management section of the JDBC template integration. So here we'll start with Spring JDBC transaction management. Now Spring provides extensive support for transaction management. This helps developers to focus on business logic rather than worrying about integrity of data in case of systems failure. Spring provides an abstract layer on top of different transaction management APIs. It helps application developers to focus on the business problem without having to know much about the underlying transaction management APIs. The concept of transactions can be described using the following 4 key properties known as ACID: atomicity, that requires each transaction to be all or nothing. If one part of the transaction fails and the entire transaction fails, the database is left in a unchanged state. Consistency properly ensures that every transaction will bring the database from one valid state to another. Isolation ensures the concurrent execution of transactions result in a system state that would be obtained if transactions were executed serially, that is, one after the other. Durability property ensures that once a transaction has been committed, it will remain so even in the event of power loss, crashes, or errors. Platform Transaction Manager is a general interface of all Spring Transaction Managers. Spring has several built-in implementations of the interface that can be used with different transaction management APIs like Data Source Transaction Manager, Hibernate Transaction Manager, and JPA Transactional Manager. Methods of Platform Transaction Manager. We first have the transaction status. This method returns a currently active transaction or creates a one according to specified propagation behavior. We have commit that commits the transaction and rollback that rollbacks the transaction, which we saw as part of the demo. Here we have the transaction definition, which is the core interface of the transaction support in Spring, and it is defined as follows. We have get propagation behavior method, which Spring offers all of the transaction properties and propagation offered by EJB CMT. Get isolation level, that returns the degree to which the transaction is isolated from work of other transactions. Get name, which returns the name of the transaction. Get timeout, that returns the time in seconds which the transaction must complete. And is read only, this method queries whether the transaction is read only. Transaction status interface provides a simple way for transactional code to control transaction execution and query transaction status. We have the have same point method that returns whether this transaction internally carries a save point, is completed. The method returns whether the transaction is completed, whether it is already committed or rolled back. Is new transaction. The method returns true in case the present transaction is new. Rollback only. The method returns whether the transaction has been marked as rollback only. Set rollback only. The method sets the transaction as rollback only. Spring supports two types of transaction management, programmatic and declarative. In programmatic, it manages transaction with help of programming. It uses Programming Transaction Manager directly to implement the programmatic approach, to implement transactions and to create instance of transaction definition with appropriate transaction attributes. Once the transaction definition is created, you can start your transactions by calling getTransaction method, which returns an instance of transaction status. The transaction status object helps in tracking the current status of the transaction, and programmatic transaction management uses the commit method of Platform Transaction Manager to commit the transaction. Then we have the declarative transaction management, which separates transaction management from the business code. It allows you to manage the transaction with the help of configuration instead of hard coding it in your source. It uses annotations or XML based configurations to manage the transactions, and it uses TX-advice tag, and this creates a transaction handling advice and defines a point cut that matches all methods needed for the transaction at the same time. The key takeaways from this session have been that Spring JDBC is used to build data access layer of enterprise application. It is a mechanism to connect to the database and execute SQL queries. The database related logic has to be placed in separate classes called DAO classes. Connection pooling is a mechanism of pre-creating a group of database connections and keeping them in cache memory for use and reuse. It provides high performance and efficient resource management, and Spring supports two types of transaction management, programmatic and declarative. Thanks for watching this session. We'll see you in the next session. Welcome to sessions 10 of the Advanced Java series, and here we'll talk about Spring MVC. We'll explain Spring MVC architecture and components, discuss the framework, and look at the steps to write code. Let's start with Spring MVC architecture and components. The problems in enterprise application development with Servlet and JSP. Servlet and code are not usable. Web designing tools can't be used in case of Servlet. Parallel development is not possible. To solve the problem, Sun Microsystems introduced two design patterns for developing enterprise applications. Model 1, page-centric model, and Model 2, MVC. So here we have a request coming in to the JSP page. The request is forwarded to the Java bean so that the object can be created. It connects to the enterprise server or data source, and then the response is generated to the browser. Request is sent by browser and received by JSP. Java bean object is created and business methods are called. If required, it communicates with the databases to get the required data. JSP then displays the processed data to the end user. There is no clear separation of responsibility. JSP acts as both controller and view, and the business logic is separated using Java bean. So now here you can see that the request comes to the servlet, which acts as the controller. The servlet can actually connect to the model Java bean, which maps to the data source using some ORM like Hibernate. That content can directly be pushed into the JSP as well in case there is no data, and it can then go to the model bean and retrieve data from the database via the JSP as well. And finally the response is sent to the browser. Controller or servlet receives requests from browser and captures the input. Controller invokes the business method of model or Java bean. Model connects with database and gets business data. Model sends response to controller, keeps the process data in heap memory request, session and servlet context, and controller switches the control to appropriate view of the application. The limitations of the MVC model: clear separation of responsibility, code reusability, single point entry for application, and support for multiple view technologies. Spring MVC is used to develop web application that uses MVC design pattern. Spring MVC is meant to make web applications development faster, cost effective, and flexible. Contents of Spring MVC: we have the dispatcher servlet, we have the handler mapping, the controller, mode and view, and view resolver. The dispatcher servlet, it is given by org spring framework.dispatcher servlet. It controls the front controller design pattern, and whatever URL comes from client, servlet intercepts the client request before passing the request object to controller. In the web config file, write servlet mapping in such a way that dispatcher servlet is invoked for client request. Then we have the handler mapping. It is an interface implemented by objects to define mapping between request and handler objects. When a request is made to Spring's dispatcher servlet, it hands over the request to handler mapping. Handler mapping inspects the request, identifies the appropriate handler execution chain, and it delivers it to dispatcher servlet. Handler mapping provided by Spring MVC module can be implemented in many ways. Bean name URL handler mapping, which is the default handler mapping class that maps the URL request to the name of the beans. If URL pattern welcome.htm is requested, dispatcher servlet will forward the request to welcome controller. If street name.htm is requested, it will forward the request to street name controller, and if process credit.htm is requested, it will forward the request to process controller. The controller are components that are called by dispatcher servlet for any kind of business logic. All controllers implement controller interface. The types of controllers are abstract, multi-action, and abstract wizard form. There are components called view resolver. Their job is to provide mapping between logical view name and actual physical location of the view resource. Then we have the model and view. It is represented by class org.springframework.web.servlet model and view, and is returned by the controller object back to the dispatcher servlet. This class is just a container class for holding the model and the view information. The model object represents some piece of information that can be used by the view to display the information. This gives abstraction in the Spring framework. Any kind of view technology can be plugged into the framework, like Excel, Jasper reports, PDF, XSLT, FreeMarker, HTML tiles are supported frameworks. Then we have the view resolver. It is an interface implemented by objects to resolve views using name Spring MVC's module. It encapsulates the module view and the view object in a single entity, which is represented by the object of class model and view. To resolve the view object, dispatcher servlet view resolver is used. Internal resource view resolver. It resolves the logical name of the view to an internal resource by prefixing the logical view name with the resource path and suffixing it with the extension. It resolves the logical name of the view to the bean name, which will render the output to the user. The bean should be defined in Spring app context file. This view resolver is the same as bean name view resolver. The only difference is that instead of looking for the beans in Spring's application context file, it looks for beans defined in a separate XML file. Spring MVC framework. The Spring MVC web framework provides model view controller architecture that can be used to develop flexible and loosely coupled web apps. So here we see the steps. The request comes to the servlet dispatcher. It goes to the handler mapping. The handler mapping sends back to the respect dispatcher servlet that acts as the controller. We then call the handler request method on the controller, which calls the business methods on the service, which in turn calls the DAO method, which talks to the database and gets the response. The response is sent to the service, sent back to the controller, sent back to the servlet dispatcher, which forwards it to the view resolver, so the right view can be returned to the servlet dispatcher. The servlet dispatcher then picks up the model, attaches it to the view, and generates the response. So client requests a resource in the web application. The Spring front controller dispatcher servlet requests the handler mapping to identify the particular controller for given URL. Handler mapping identifies the controller and sends it to the dispatcher servlet. Dispatcher servlet calls handle request method and passes these two objects to the controller. Controller calls the business method. Service class calls the DAO method for business data. DAO interacts with the database to get the data. Database shares the result. DAO returns this result data to service. DAO data is processed according to business requirement and returns to controller. Controller returns model and view object back to font controller. Dispatcher resolves actual view by consulting the view resolver object. View resolver renders view to the dispatcher. Dispatcher servlet consults the view to the dispatcher servlet. View executes and returns HTML to the dispatcher servlet. Dispatcher servlet sends output to the browser. The request processing workflow of Spring Web MVC dispatcher servlet is illustrated in the following diagram. The handler mapping going to the dispatcher servlet. Second is the controller data exchange with the dispatcher servlet. Then it communicates with the view resolver, and finally the view and the response is sent out. After receiving an HTTP request, dispatcher servlet consults the handler mapping to call the appropriate controller. The controller takes the request and calls the appropriate service method based on used get or post method. The service method will set model data based on defined business logic and return view name to the dispatcher servlet. The dispatcher servlet will take help from view resolver to pick up the defined view for the request. Once view is finalized, the dispatcher servlet passes the model data to the view that is finally rendered on the browser. Configurations required for Spring MVC. Map requests that you want the dispatcher servlet to handle using URL mapping in WebXML. Create servlet name servlet XML file. Define a controller. Create a view. So you map requests that you want the dispatcher servlet to handle by using URL mapping in WebXML file. Use the following code. Declare the map hello web dispatcher servlet. The web.xml file will be kept in webinf directory. Then you create the servlet.xml file. Framework will try to load the application context from a file named servlet.xml located in the application's web content directory. The file name is helloweb.xml. The servlet name XML file will be used to create the defined beans, override the definitions of beans with the same name in the global scope. The component scan tag will be used to activate Spring MVC annotation scanning capability, which allows you to make use of annotations like controller and request mapping, and the internal resource viewer resolver will have rules defined to resolve the view names. We define a controller. The @controller annotation indicates that a particular class serves the role of a controller. The @request mapping annotation is used to map a URL to either an entire class or a particular handler method. The request mapping method is used to declare the print hello method as the controller's default service method to handle HTTP GET requests. Then we create a view. Spring MVC supports many types of views for different presentation technologies. These include JSP, HTML, PDF, Excel worksheet, XML, Velocity template, XSLT, JSON view in WebInf. Finally, the Spring MVC program. Let's write a simple web-based application using Spring MVC to create a Spring MVC model to display Hello World. So the request will come in here saying hello.jsp. We will use @request mapping. Then the dispatcher servlet will communicate with the hello controller. Then the internal resolver view resolver, and finally the hello.jsp, which will generate the response. The Hello World example uses Spring Web MVC framework to follow the model view controller architecture. The controller is responsible for processing user requests and building an appropriate model. It then passes the model to the view for rendering. In this example, Hello Controller Java class is controller. The view is responsible for rendering the model data. In general, it generates HTML output that the client's browser can interpret. In this example, hello.jsp is the view. We create a dynamic web project with the name Hello Web. We then add jar file to web content webinf lib. Then we create a Java class Hello Controller under src folder. Then we create Spring configuration file web.xml and Hello Servlet under the web content inf folder. Then we create a subfolder with a name JSP under web content. Then we create a view file hello.jsp under the subfolder. The final step is to create the content of all the source and config files and export the application. Here are the steps. We create a dynamic web project that we have already learnt. We add the following jars: Servlet API, Common Logging, Spring AOP, Spring Beans, Spring Context, Spring Core, Spring Expression, Spring Web MVC, and Spring Web. Then we write the @controller and request mapping to /hello. We write the controller with the request method as get, and we say model.addAttribute message hello Spring Framework. Then we create the Spring config file that maps the dispatcher servlet object. and the hello web. Then we map the Spring Framework internal resource view resolver as well, and we put the webinf/jsp property mapped to that particular folder path. Then we create the subfolder with a view hello.jsp, which simply returns hello world and $of messages, the expression. To run the application, we say localhost port hello web and hello. We'll write a simple web-based application that makes use of HTML form using Spring MVC framework to submit the data to the controller and display a processed result. So the moment we say project name/employee, it will go to the dispatcher servlet, which will talk to the employee controller, retrieve the employee object, move to the internal resource view resolver, which picks up the result.jsp and employee.jsp views and send it out as a HTTP response. MVC architecture for form handling example. The form handling example uses Spring MVC framework. It follows model view control architecture. The model encapsulates the application data and consists of POJO. It creates employee class containing ID, name and age. The controller is responsible for processing user request, building an appropriate model and passes it to the view for rendering. It creates an employee controller.java class to call employee class methods. The view is responsible for rendering the model data, and in general it generates HTML output that the client browser can interpret. Java JSP files, result.jsp and employee.jsp are used to display employees information. Steps to write a web-based application using Spring MVC. We create a dynamic web project and add the required Java files. We then map the request that you want the dispatcher servlet to handle by using URL mapping in WebXML. You then create the Java class employee. You then create employee controller in SRC folder. You then create Spring config web XML and servlet XML under web contact webinf. You then create a subfolder with the name JSP under web contact INF. You then create view file employee.jsp. You then create second view file result.jsp, and the final step is to create the content of all the source and config files and export the application. Now we create a dynamic web project and add the required Java files, common logging, Org Spring Framework ASM, Org Spring Framework Bean, Org Spring Framework Context, Org Spring Framework Core, Expression, Web Servlet Web, and Spring Web.jar. We then define the Spring Web configuration file web.xml, where we set up the dispatcher servlet. We give the servlet name as hello web. We then set up the employee class with age, name and ID. We then create the controller with a request mapping of a URL/employee and map to a request.get method. We then return model and view with the employee and command and the new employee object. We then do another mapping for the request method.post. This is from the form data to be posted. We provide the add employee method and add attribute mappings for name, age and ID. Next, we create a Spring config file web.xml and servlet.xml, which map the JSP page. Then we create a subfolder in a view, which maps the view information as a employee.jsp file, where we create a simple table to print out the data. We create a second view called result.jsp, which has a separate table that gives us the name, age and ID of the employee. We create content for all the source and config files and we run the application. Let's look at a demo on Spring Web MVC. Let's start with a small demo demonstrating the capability of Spring Web MVC. So let's move to Eclipse. So Spring MVC is an end-to-end solution for complete web app development. The servlet plays the role of the controller and JSP plays the role of the view. It follows the fun controller design pattern. This means there will be a servlet as a controller and the model caters to collecting the data. There is complete sync between the model. The view is handled by the controller, which is a form of MVC design pattern. So Spring MVC has a front controller, which is the dispatcher servlet. So we have created a dynamic web project and we have added the libraries. So the reference libraries are all the Spring libraries. In addition to that, we have added the commons logging, which is the other important library that we have added. We have a views folder that has 4 views: home, profile, register trainee, and success. Let's look at the web.xml file. Here we have the dispatcher servlet configured with the name as my servlet, and here we are configuring my servlet with a URL pattern of / indicating that any request that comes to the dispatcher servlet which acts as a controller will be catered to by the dispatcher servlet. So the moment you put a / which is the root URL in the address bar, the request will come and hit the dispatcher servlet. Then we have the myservlet-servlet.xml file. So here we can actually see that the Sprig Vim container is going to look for this file. It is going to look for JSP pages inside this path, which is webinf/views, and that is where we have stored our JSP pages. It will search for the controllers in the com.controllers package, and here in the source, in the com.controllers package, we have set up our controllers, as you can see here. The internal resource view resolver will find out which particular JSP page is to be returned. So the prefix is the path where the JSP are stored, and the suffix is it's going to postfix all the view names with a .jsp extension. Next we come to the mycontroller.java file. We use the annotation controller. We are mapping to the root. So if somebody gives the URL, the end user passes the URL as a /. We are going to print home in the console and simply return the home.jsp page. So the suffix will be appended to this. We have another function called sayName. So in case we request for this particular URL route, we will get the first name parameter from a form. We will map the attribute of this particular value, first name, and we will return the profile view, which is again present in the views folder as we see here. We have a third route set up for the URL login. So if the URL is /login, we will trap the username and password fields from the form. We will check if the username and password equals Tom and Jerry. We will add the attribute and we will return the profile page. If there is an error, we will simply return an error message. So that constitutes the mycontroller. Let's look at the home.jsp. We have the sayName action method, which will post to the sayName request map that we saw in the controller. The method is post. We have a submit button with fname, and we have a login controller with username and password and a submit button, and this is mapping to the action method login. And those are the two action methods we saw. We are mapping to sayName or login. We'll come to the home page and we'll execute this. We'll go to the default route, which is just a /, which takes us to the home page, and here it simply gives us a welcome message as of now, which says hello, welcome to Spring, which we see is the default welcome message that we are actually getting. And we also have a sayName function that is actually getting mapped when we click on this button. And we are going to route to a success page. So here let's print first name, and we can see here that we are actually going to map to the first name function. And if we go to the controller, we have created an attribute first name to which we are mapping this value, okay, and we are simply returning the user information. So in case there is a success, it will simply go ahead and route to that particular URL. So we'll just provide, or rather let me go here rather than the success, and we'll make that change. So we'll go to the profile because we are navigating there, and here we have a first name. And now if you see here, we are saying that we are going to post this form to say name. First name is going to be the attribute that we are going to trap, and we are going to return profile. So the first name attribute that we are going to trap here, if we look at the home.jsp, okay, the user is going to enter a first name which we will trap as an attribute. So here that value is going to get trapped. We then return the profile JSP. When I go to the profile JSP, we are simply outputting that attribute first name. So this is my page execution. I have just entered a first name. I'm going to click on the submit button, and it says welcome that particular user, right? If I add another user, it actually goes and traps that user ID. So again, the flow is that in the controller, it's hitting this particular request map. It then traps the F name, stores that value into an attribute called first name, and forwards it to the profile page. The profile.jsp is returned by the controller and simply prints the first name. Now we have another page here which is register trainee. We are posting to an add trainee method. Okay, we are posting to an add trainee method. The command name is trainee command, and we have here, if you look at this, we have actually included a custom, or rather a system defined tag library, which is springframework.org tag/form. So what we are using here is Spring forms rather than the system defined HTML5 forms. And here we are saying sform : which is the prefix for this particular namespace that we have imported on the top. The action is add trainee, and we have a trainee name, we have a marks code, we have a contact number, and a submit button. Okay, and now we are already going and setting part to COM controllers. So in the COM controller, we've created a register controller. Here you see that we have a request map for register and a request map for add trainee, and here you see the trainee command that is actually getting trapped. So the trainee information will automatically be passed here, and this is the model map which acts as a scope which allows us to pass data between the controller and the view. So this trainee object acts like the model data. So if we come to the com.to package, you actually see the trainee class which has trainee name, marks code, and contact number. It has a parameterized constructor, it has an overridden toString, default constructor, and getter and setter. That's all the trainee class actually has. The register controller, as we saw, has two maps: a register function that returns register trainee.jsp, maps to the attribute trainee command, and a add trainee map that accepts the trainee object along with the scope, the model map which passes data between the controller and the view. We are adding attribute trainee and we return success. Okay, so if I go to the success.jsp, we are printing the trainee object. If you look at the register trainee, here you see the command name that we are trapping, and trainee name, marks code, contact number, which map to the fields that we have in the model class or the entity class, which is the trainee itself. So now if we actually look at so let's close this, come back. We don't add any credentials. We click on login and it says invalid login credentials. Okay, so this is the login that is getting called. So you see here it maps to the login, and here if we do not enter anything, it simply returns invalid login credentials. So this is the login that's actually getting hit when we click on that button. And if you look at the register trainee, we actually see the input type over here equal to submit, and the moment we hit that particular login URL, it will simply throw this message saying that you did not enter the right credentials. So that is the login screen for us. Okay, now if I actually add the right credentials, so if I add the correct credentials here, or let's say we enter the incorrect credentials, let's say Amit and password, and we say login, it continues to say invalid login credentials, right? So in the home.jsp, you actually see the login. So this is the login block, which is giving us that action equal to login, username, password, and it is displaying $error message, right? So the moment I click on this input button, it looks for a JSP, or rather it looks for a controller which has a request map. So this JSP page looks for a controller that has a request map of login. So inside the my controller, I have a request map of login. It will go here, it traps the username, password, checks. If it's not Tom and Jerry, it goes to error message. If it is Tom and Jerry, it displays profile, right? And if I look at error message is being printed in the same page below. So in the home.jsp, we actually are if you look at the home.jsp page, $error message is being printed, and that's why you get the invalid credentials out here. Okay, and if it is a success, it will show you the success page and print that information. Okay, it will just display. So if you look at the my controller, what we are doing is we are displaying the profile page here. So if I go to the profile page, it will just display the first name. Okay, so let's try that. So here, if I say Tom and Jerry, it should just display the first name successfully saying Tom. So when I log in, it says welcome Tom. Okay, the URL continues to be login. Now when I click on this register link, what happens? So let's look at the home JSP again. href equal to register. So when I click on the register link, I simply have a registration which says click here to register. Okay, and I already have a register trainee form created, and this is created using Spring Forms, as we discussed, by importing the tag library for Spring Forms, right? So that's the register trainee. Now I have a separate controller that is managing that. So here is the register. So moment I click on that link, it will hit this request map and it will bring up the register trainee.jsp. Okay, and remember we had added the suffixes here in this particular file. So when I say register trainee, the .jsp suffix will already be automatically be added. So we'll try that. We'll click on register, and here you see the register trainee Spring form has come up. So we enter the trainee name, we enter the marks code, and we enter the contact number, right? Now if you look at the register trainee form, this is posting to add trainee. So if I go to the register controller, here is where I have my add trainee. It accepts the trainee object as a parameter, maps to trainee command, and the scope, which allows us to pass information between the controller and the model. And here we are mapping the trainee object and just returning success.jsp, and in success.jsp we are simply printing the trainee object. So let's see when I click on submit query. So let's try the register now. So when we click on register, we'll enter a name for the trainee, we'll enter the marks code, and we'll enter some contact number, and we'll click on submit query, and there you see the trainee object actually getting displayed. So in the success page, we were actually displaying the trainee object. On the register trainee, as we discussed, we were connecting to the add trainee action. In the register controller, we had the add trainee action. We were passing the trainee object along with the model map and adding the trainee attribute to the map, and finally returning success, and on the success page we just went ahead and printed the trainee object. So you saw how the Spring MVC pattern got the request to the dispatcher servlet, it forwarded it to the right model, picked up the model data and went and displayed successfully the required view, which was the final view that actually got registered for us, and that is the success.jsp page that finally got displayed. The key takeaways from this session have been that Spring MVC is used to develop web applications that uses MVC design pattern. Spring MVC is used to make web application development faster, cost effective and flexible. Dispatcher servlet, handler mapping, controller, model and view resolver are the components of Spring MVC. Thanks for watching the session. We'll see you in the next session. Welcome to session 11 of the Advanced Java series. Here we'll talk about SOA and web services. We'll look at SOA architecture, we'll explain web services, we'll list the steps to create a SOAP-based web service and steps to create a RESTful web service. Let's start with basics of SOA and SOA architecture. Software evolution has distinct phases. These layers are built up one by one over many years. Software evolution begins with understanding the concept of 1 and 0, bits that give rise to machine language. This is followed by assembly, procedural, OOPs, component and service-oriented languages. A procedural language is a type of computer programming language that specifies a series of well-structured steps and procedures within its programming context to compose a program. It contains a systematic order of statements, functions and commands to complete a computational task or program. Structure or procedure-oriented language is unable to model real-world problems. It uses global data concept and is thus assessed by all the functions. It is difficult to maintain because the line of code is high. Object-oriented refers to a type of computer programming software design in which the programmers define the data type of a data structure and the types of operations or functions that can be applied to the data structure. Although it offers better implementation, data security, code reusability and flexibility, it is difficult to manage complex applications. Component-based software engineering, also called component-based development, is a branch of software engineering that emphasizes the separation of concerns with respect to wide-ranging functionality available throughout a given software system. A component modifies complexity through the use of a component container and its services. Component development is a complex task and comes with the following limitations: component maintenance costs, reliability and sensitivity to changes, and unsatisfied requirements. Service-oriented consists of web service, which are self-describing services that will perform well-defined tasks and can be accessed through the web. Service-oriented approach follows an architecture called SOA that focuses on building systems through the use of different web services and integrating them to make up the whole system. SOA is the architectural solution for integrating diverse systems by providing an architectural style that promotes loose coupling reuse. It is a programming model or paradigm where web service and contracts become a dominant design for interoperability. This is the architecture of SOA. You have the security aspect of it, and you also have the management aspect of it. So there are two core aspects of the SOA architecture, which is the security aspect and the management aspect. We have the communications layer, within which we have the SOAP protocol, the SOAP extensions, and the messages that flow between the client and the service. And the data that is transferred is typically in an open format called the XML format, and the schema of the data is stored in a document type definition or DTD. Then you have a WSDL file that describes the set of methods or functions etc. that you're exposing as a service, and then you have a layer which allows clients to discover your set of services. So SOA is a collection of services. The following diagram shows how an online shopping website selling gadgets is involved with different services like ordering, tracking and checkout to give service to its customers. So here we see the ordering service dependency, the tracking and the checkout services, and the customer is dependent on those. First step is to establish communication, where the service consumer and the service provider start communicating with each other, and SOA is a solution for making two softwares communicate to each other. The advantages of SOA: a service provides improved information flow, agility to expose internal functionality and organizational flexibility. The service reuse has lower software development and management costs. The messaging has better configuration flexibility. The message monitoring focuses on business intelligence, performance measurement, security attack decision and detection. Message control, where application of management policy and security policy is involved. Message transformation for data translation. Security for data confidentiality. And complex event processing for simplification of software structure, better ability to adapt and improved manageability and security. For the implementation of SOA, we have the corporate network. Here we have the enterprise service bus with a couple of adapters to connect to various components like in-house apps, out-of-the-box vendor-based apps or other external apps. We could have a workflow engine where it defines a set of steps where you can graphically model your business process. It has a registry where your services can be stored and deployed so that clients can come to know that there is such a service which can be retrieved. The service broker that acts as an intermediary between the consumer and the publisher of the service and the SOA supervisor. And then of course we have the presentation layer, the data service layer, the infrastructure layer which does security management and authentication, and the software development layer. I can also do business process modeling, which is graphical modeling of the business process, store my services into a SOA repository, also look at testing and then governance model. So first thing, we have a service provider that publishes a service into the service directory so that the consumer is aware that there is such a service available via the description that the service provides. The service provider publishes the service description. The service consumer via the service provider connects to the implementation of the web service, and the web service is an implementation of service-oriented architecture. Let's go into a deep dive on web services. Why use web services? Web applications enable interaction between an end user and a website. Web services are service-oriented and enable application-to-application communication over the internet and easy accessibility to heterogeneous applications and devices. Web services can be invoked through XML-based RPC mechanisms across firewalls. Web services provide a cross-platform cross-language solution based on XML messaging. They facilitate ease of application integration using a lightweight infrastructure without affecting scalability, and they enable interoperability among heterogeneous applications. Web services are based on the concept of SOA. According to Gartner research, web services are loosely coupled software components delivered over Internet standard technologies. They are self-describing and modular business applications that expose the business logic as services over the Internet. This is run to programmable interfaces and Internet protocols to provide ways to find, subscribe and invoke these services. Web service operational model can be conceptualized as a simple operational model that has a lot in common with a standard communication model. So here you can see the service provider where it registers the service towards the service broker. The service requester discovers the service at the service broker layer and invokes the service. Operations are conceived as involving three distinct roles and relationships that define the web services providers and users. Consider the scenario. A travel service provider deploys its web services by exposing the business applications obtained from different travel businesses like airlines, car rentals, hotel accommodation, credit card payment and so forth. The service provider registers its business services with descriptions using a public or private registry. The registry stores the information about the services exposed by the service provider. The customer discovers the web services using a search engine or by locating it directly from the registry and then invokes the web services to perform travel reservations and other functions over the internet using any platform or device. In the case of large-scale organizations, the business applications consume these web services to provide travel services to their own employees through the corporate intranet. So here we have a wireless device, a desktop, a PDA, an automobile and an organization communicating with the service requester, or rather playing the role of a service requester. We have the airlines reservation system, car, hotel, weather information, credit card systems provided. The service requester finds services on the service registry portal and it then invokes the service based on the server on which that particular service that the requester is looking for has been deployed. Web services are based on the following standards: extensible markup language, universal description, discovery and integration, web service description language, and simple object access protocol. Let's talk about XML. Now these technologies are interoperable at a core level as they use XML as data representation layer for all web service protocols and technologies that are created. So here we have the XML generator or the interpreter, which then communicates to the communication manager. The communication manager at the server end again converts your message into XML and processes it. The response of the outcome of the set of functions you probably have in the service will again be converted to XML. Via the communication manager, it will be serialized and sent over the network back to the client. The client will again convert it into XML and transfer the data into the user interface. So here you see the service provider pushing the service onto the directory and the consumer consuming the service from the directory and then calling the appropriate service. So the consumer formulates its message to the provider using XML. So in all of the communication that happens between the client and the service, the message format or the transfer format is always XML, because services are meant to connect applications together. Those applications could be across technologies. You could have a .NET and a Java application communicating, and hence you need a data standard like XML which is open and industry accepted, so that any fourth generation language, be it .NET or Java, can make sense of the data and messages that you are sending across. UDDI provides a worldwide registry of web services for advertisements, discovery and integration purposes. UDDI could be dynamic or static. Business analysts and technologists could use UDDI to search for available web services. The UDDI Business Registry provides a place for a company to programmatically describe its services and business processes and its preferred methods for conducting business. The directory is implicit in web services. WSDL describes the interface of the web service. It is compatible or comparable to the concept of remote interface of Java RMI or the interface definition language of RPC. It standardizes how a web service represents the input and output parameters of an invocation externally, that is, the function structure, the nature of invocation, and the service protocol binding. Web services with WSDL. So the service provider will upload a service and publish it onto the directory, and will also put out a WSDL that will define what are the various methods and data types that and arguments those methods take. That information will be available via the WSDL. The service consumer will read the WSDL to understand which are the methods and what are the parameters it needs to pass, and hence consume your service. So step 1, the service provider will use the WSDL via the directory. Step 2, the service consumer will query, or rather the directory queries that particular service for the information. It gets a response via the WSDL. The XML service request is always based on the WSDL, and the response is also always based on the WSDL. And all the data between the service and the client is always transferred using SOAP messages. SOAP being the protocol, open standard protocol for communication between applications. And within the body of the SOAP message, you actually have the data in the XML format that is flowing between the service and the client. SOAP is a simple XML-based protocol to let applications exchange information over HTTP. It is a protocol for accessing a web service. It is important to have internet communication between programs for application development. Firewalls and proxy servers generally block traffic that creates a compatibility and security problem, even if they are used for application communication like RPC. HTTP is supported by all internet browsers and servers. However, SOAP was created to accomplish better communication between applications. SOAP supports different technologies and programming languages. Here you have the HTTP protocol. You see the SOAP envelope. Within it there is a header and a body. The body contains the XML data as a message and also WSDL information in terms of metadata about the message, what are the types it takes, what are the function names, and what are the parameters that they accept. So messages are sent and received in a directory always via the SOAP standard. The SOAP envelope identifies XML document as a SOAP message. The header is an optional element that contains metadata or header information. The body contains call and response information, and fault, it provides information about errors that occurred when processing the message. The envelope is the root element of a SOAP message. It defines the XML document as SOAP message. The optional SOAP header contains application specific information like authentication, payment, etc. about the SOAP message. If the header element is present, it must be the first child element of the envelope element. The required SOAP body element next contains the actual SOAP message intended for the ultimate endpoint of the message. The immediate child elements of the SOAP body element may be namespace qualified. This is the SOAP fault element used to indicate error messages. The optional SOAP fault element is used to indicate error messages. The SOAP fault element holds error and status information for a SOAP message. If a fault element is present, it must appear as a child element of the body element. A fault element can only appear once in a SOAP message. The SOAP fault element has the following sub-elements: fault code for identifying the fault, string for explanation, fault factor for information about who caused the fault, and detailed hold specific error information related to the body elements. So let's start with a small demo to understand how do we create a SOAP based web service. We will set up the client and the server as well using the inbuilt features of Eclipse, and we will automatically get it deployed onto Tomcat. So we'll create a dynamic web project and let's call it my SOAP demo. We'll create a new package, com.service. We'll create a new class, calculator. Create a new method, public string, say hello, and it will just return a string value saying welcome to SOAP. Now all we need to do is right click and say other, web service, next, pull up the slider so that it generates the test service, and pull up the slider so it generates the test client as well along with the WSDL. Browse, pick up the calculator class, next, say hello is our function to publish in the WSDL, which is the client proxy. We'll move next. Next again. Next again. You see the see hello, the say hello method is visible here. That's what we want to publish and finish. So it should now open a test client perspective, create a sample JSP as well for us. You see it's added a project here saying my SOAP demo client automatically. So it's created that client project for us, and it will publish both the service and the client. So here you see the test client.jsp. These are the methods. So we had say hello. We'll click on that, click on invoke, and welcome to SOAP is the message we had put there, which comes up. If we go to the web content WSDL, we'll actually be able to see the WSDL file which defines the parameters and the functions that we actually had. So say hello, it defines that. It says it returns a string. Okay, it defines the SOAP message as well, and you'll actually also be able to see the client URL. This is the URL that we need to share with the clients to connect to our service. So this shows us how do we set up a simple SOAP service using Eclipse and Tomcat. Let's talk about Java APIs for web service. There are two main APIs defined by Java for developing web service applications: JAX WS for SOAP web services and JAX RS for RESTful web services. Let's talk about creating a SOAP-based web service. Access facilitates easy development and undeployment of services using XML-based Web Services Deployment Descriptors or WSDDs. It enables deploying and undeploying services and also access specific resources like handlers and chains using an administration utility called admin client provided as part of the Access toolkit. It helps deploy a service, ensures that access class path is set and runs the following command. It helps undeploy a service, ensures that the access class path is set and then runs this particular command, which is deploy and undeploy. To create a web services and access environment, the following models are required. Create the service provider, server application. Create the service requester, client application. We start with creating a new dynamic web project and name it SOAP example. We then create a new package called com web service. We create a simple Java class called hello world which works as a service. We right click project new web service. We click next. In service administration text box, we write the qualified class name of created class hello world Java. Move both above slider to maximum level and click finish. You are done. A new project named SOAP example client will be created in your workspace. Click start server. After clicking start server, Eclipse will open test web service API. With this test API, you can test your web service. Create a new web dynamic project. Create a new package. Create a simple Java class called hello world with a simple method. Right click new web service. Then click next. Then click start server. Then test your web service. Creating a RESTful web service. RESTful web services are lightweight, highly scalable and maintainable. They are basically based on REST or representational state transfer architecture. REST is focused on two things: resources, its application functionality which is represented by unique URL, and interface. Its HTTP method works as an interface to access the resources. A RESTful web service usually defines a URI, which is a service that provides resource representation such as JSON and set of HTTP methods. There is no need to use XML data interchange format for request and response. The REST web service can return XML, JSON or even HTML format response. We create a web service called user log management with the following functionalities. It responds to HTTP methods like get, put, post, delete and options. For the environment setup, we set up JDK, then IDE as Eclipse, then Jersey framework libraries and Apache Tomcat. We first start with creating a dynamic web project named user log management. We then add Jersey framework and dependencies. We then create user log service Java, user log DAO. We then create a web XML config file to specify Jersey framework servlet. We then export the application as a var and deploy in Tomcat. The class user has ID, name, designation, member variable, and it uses XML root element and XML element annotations. As we see here, the root element name equal to user and XML element with respective property name getters and setters. We then write the user log DAO class. It has two methods to get user details. First, it checks for the first name user.dat. If it does not exist, it adds one more user data to user list. It then opens user's file and reads it. So if the file exists, we create a user object, we create an array list, we add the user to the array list and save the user list. Else we create a file input stream object and read the data and close it. Writing log service class. Here we create a user log service class. You can see the @ annotation for get of HTTP method. The path will be /users and the application data type will be XML, and we simply return the list of users. Then we create the web XML file which configures the Jersey servlet and the REST application pattern. SOAP versus REST. The main advantage of SOAP, it provides a mechanism for services to describe themselves to clients and advertise their existence. It brings its own protocol and focuses on exposing pieces of application logic, not data as services. SOAP-based reads cannot be cached and SOAP only permits XML. In RESTful web services, client have to know what to send and what to expect. REST is focused on accessing named resources through a single consistent interface. REST has better performance and scalability. REST reads can be cached. REST permits many different data formats. We'll now start with the demo on RESTful web services. The first thing we have created is a web.xml file, and we have also added the relevant jar files to the project. In terms of the jar files, you need to Google for the Jersey REST API. This is the Jersey REST API, and just download the Jersey REST API jar file. Once you download the jar file, you can simply add it to your project. So these are the set of jars that we've actually referenced in this project, and all these jars have come from the Jersey RESTful API.jar. Once we unzip it, you will have the entire set of jars. You simply need to add those references to this project. Next, we'll create a web.xml file. The name is Jersey RESTful application. This is the servlet class, which is the inbuilt servlet container that manages the RESTful service. Here is the name of the package that will have the handlers and the files that will handle this HTTP post, get, and put requests. So if you look at your source folder, we have created a com.dao package with the relevant files inside which have the HTTP request handlers. Here is the name of the servlet that exactly matches the servlet name in the servlet mapping, and it maps to /rest./*. So any URL that hits this particular pattern will be managed by the Jersey RESTful API. The first thing we've done is in the com.dao is created a interface. The interface has methods to add an employee, delete an employee, get all employees, and get an individual employee based on the ID. The implementation class that implements employee service has a @web service attribute. It has a data structure that takes integer and the employee object. It has an add employee to which you can pass an employee object. If it is null, it returns -1, else it simply puts that employee object into the temporary collection. The ID is the first parameter and the object itself is the second parameter. The next method implemented from the interface is delete employee. It takes the employee object. In case the employee object is not found or it is null, it will return -1, else it will remove that object from the map by passing the ID. It then gets all employees. We simply convert the employee list into a array list and return it, and to get an individual employee we pass the employee ID and get it out. In terms of the service, /employee service is the URL that we will hit. We have two constants, failure and success. We create a object of the service. We map it to the get HTTP request. So all get requests in the browser will be managed here. If the URL is /employee service /employees, it will be managed here. We will return XML data and we'll simply get a list of employees from the service. If the URL is /employee service /employees /employee ID, we will return XML data by mapping the employee ID in the text box in the form, and we will simply pass that to the service and return the relevant employee ID. If we have a form to insert a new employee and the URL is employee service /employees and we are posting data to the service, we will produce XML data. We will consume data that is passed through us from the form. The form should have employee ID, name, age, and password as text boxes, so we are mapping to those parameters. We are creating a new employee object and we are adding it into the service. If the result is 1, we return success, else we return failure. In the com.2, we have the employee object itself, which is the transfer object. So here you see the root element of the XML file to be returned should be employee. It should be serializable since we are passing it as and calling it as a RESTful service, and we will be passing it over the web. It again has ID, name, age, and password, default parameterized constructors, and setters and getters, and everything is prefixed with @XML element because we want this data to be converted into XML and returned. And employee service, that is exactly what we have actually created there. We are producing XML data, right? So let's try and so now let's go to the 1.xml, or rather the index.html file. Here we just have a simple file to test whether the URL is working. It says welcome to RESTful service, and in the 1.html we have the form that is posting to rest/employee service/employees. If you go to the web.xml, rest/ will be mapped to the com.dao package as a servlet container to manage the request, and that's what we've configured. So that is exactly the URL we are giving, employee service / employees. And if you go to the service class, you will see /employee service, and when we say /employees, this is the method that will be executed. It will pick up the name, age, password and employee ID, and that is exactly the name, age, employee ID, password that we have mapped as part of the post method. So when you post this form, it will come to the service class. It will, because here is the URL, it will hit this URL and it maps to post. It will consume the form data and create the employee object and return accordingly whatever success or failure. So we will just try to execute this. We'll say run as, run on server, okay, let me save all. We say run as, run on server, next, finish, and there you see the simple index.html page. And now when we ask for the 1.html, we get the form. So we are simply going to add some data into the form, and we would expect XML data as a response, and there you have the success flag indicating that the record was successfully added into the collection or the map. So we have just seen a RESTful service responding to the HTTP GET and POST methods. The key takeaways from this session: software evolution begins with understanding the concept of 1 and 0, which is bits, that gave rise to machine language, followed by assembly language, procedure oriented, object oriented, component oriented and service oriented. Service oriented approach follows an architecture called SOA that focuses on building systems to the use of different web services and integrating them to take up the whole system. Web applications enable interaction between an end user and a website. Web services are service oriented and enable application to application communication over the internet and easy accessibility to heterogeneous applications. RESTful web services are lightweight, highly scalable and maintainable web services. They are basically based on REST architecture. Hope you've had an amazing learning with the Advanced Java series. Thank you.